Okay, great. So welcome back, everyone. So what I'm going to go through now is important past paper questions you should know on the big old topic of algebra. Now, the way StudyClix is this laid out, they have it broken up into kind of six individual PDFs. And so the very first one I'll go through is probably the shortest, easiest one, which is on simultaneous equations. So this is going to be part one, and there'll probably be six parts, and then we'll put them all together into one big video. Okay, so right, so we'll get straight into this. So as always, this is a big-ish document, and I have put red stars beside the important questions we're going to do. So I'll hop into this here and explain what's going on in each of them. So obviously, as I always say, be pausing the video and giving them a go yourself, and see can you get them out, and you'll learn that you'll get the most from the videos that way. Right, so this is an interesting one because when you look at this, you see a system of two equations and there's actually three unknowns, okay? So realistically, we need a third piece of information, like a third equation, to find the third unknown. But they actually do give us that third piece of information if you read it here carefully. It says one of the solutions to this pair of equations is on the y-axis, right? So you got to think about that. If because when you think about this, x and y are like a point, right? Uh, when you're told one of them is on the y-axis, that means x is 0. Okay, so that's a piece of information we're going to use while solving these. Right, use this information to find the value of n. Okay, so let's give this a go. Let's try and use this what they're on about one pair. Let's find that point that's on the y-axis. That's when x is 0. So let's sub that in, see what happens. So when x is 0 in the first one, we go 2 times 0 minus y equals 7. So then you can see there y equals a negative 7, right? So then that solution is like 0, 7, that point that 0 minus 7, that point I was marking in on the x-axis, or the y-axis. Okay, right, that's straightforward. So then you just kind of put that in here and you'll get n. So this was stupidly simple, this question. So 0 squared, but it looked like it was going to be much more complex than what it really was. Minus 7 squared equals n. So then we got minus 7, that's 49. 49 doubled, probably 98, equals n, and that looks like n is 91. Okay. Yeah, that's just what that was. Great. So they don't ask us to go and find the other solutions, but we could go and find the other solutions by setting this like equal to 91 and solving them, but they didn't ask for that, so we'll push along anyways. Okay. Right. So I'm going to pause the video, get our next question. Right, so this is our next question here. So like this is pretty boring when you look at it, like it's three equations, three unknowns, and like a lot of people will learn how to solve this where you just like cancel one of the variables, and that is what you do. But I'm going to show you kind of another kind of unique way to do it here. To be honest, it looks a lot neater when the examiner is correcting it if you do it this way, rather than like say multiplying the top one by minus 1 and then adding that to the bottom one to cancel the y, that kind of a thing, okay? So I'll show you an interesting way to do this. So we will cancel the y's here, or we could cancel the x's, given the x's there. Um, so I know I'll go with I'll actually go with canceling the x's that it's given here, right? So what I'm going to do here is I'm going to get x on its own in the second equation. So I go x equals minus 1, bring everything away from the x, minus 2y plus 2z. And this is how simple this is, right? So now that I have x on its own, I am going to sub this in for x in this and for x in this, and then there will be no more x. X will be gone. X will be replaced with stuff in terms of y and z. So pause the video, have a think about that. If that makes sense to people, great. So into the top one, we're going to put this for x, minus 1 minus 2y plus 2z. So it's really just multiplying now, you know. Minus y plus 3z equals 1. And then we'll multiply this out here. Minus 3 minus 6y plus 6z. And then you have your minus y, your plus 3z, and your equals 1. And then you put this together. What am I getting? Like a 9z. 9z minus 7y. And then I can bring the numbers all to one side. It's no harm. So then I get a 4. So you see you got an equation now with no x in it. And so you just basically do the same thing here with the other one. I'll probably just do it here and then I'll pause the video and do the multiplications. So you go minus, so this is really easy for the examiner to correct, um, because it's very clear what you're doing. You're getting x on its own and getting rid of x this way. And it's, to be honest, it's a nicer way to solve the problem. Okay, so I'm going to multiply that out and get something similar to this down the box. Okay, so I basically just multiply that out, got something like that down there, and then here we are again now. So what do we have? We have that this is now a junior cert problem. You know, everyone's able to solve two equations, two unknowns. So I'm nearly not going to finish it out from here, but like you know what to do basically from here. But what you could do is you just sort of could reuse the method that I've already shown you there. You could, for example, get 13z on its own in this one. 13z equals 9 plus 9y, right? So then z equals, you could say 9 over 13 plus 9y over 13. And then you just put that in down here. So for this z. So then you just got to be neat subbing in for the examiner. So you go 9 bracket 9 over 13 minus, or sorry, oh yeah, I'm putting this in, plus 9y over 13, take away 7y, and then that's equal 4. So look at this now in purple down here. Let me put another box around this here. That's gone a little off the screen there. I see that for so that's equal 4. There you go. And so basically this here now is just one equation, one unknown. So you can find y from this. This is what's nice about when you have it this way. Once you get your y, you put it in here. You'll get your z. And once you have your x and your y, you put it back into your original thing that you move around to get your x. So yeah, what I would do here for people who will be solving this is I'd multiply everything by 13 then, and then that should tidy things up a lot. Okay, great. I'm sure everyone can solve this. The hard part really is just getting down to these two boxes here. We have two equations, two unknowns, and this move up here is really smart. Just get one of the variables on its own and sub it into the other guys. Okay, right. I'm gonna go to our next problem. Oh yeah, just for anyone who did pause and did sub that out, x there works out as -1, y works out as 2, and z works out as 2, okay? And the great thing in an exam situation is you can check if they're right by subbing them back into, say, like one of the equations, or two of them if you want to be doubly sure. So you can check this if I put and as well too, write them like this, of course. They're 2's, not z's. Write it as a point like this. So this is like a point in 3D space, okay? So x, y, z with the commas between them. But yeah, you can sub them back in, make sure you're right. So you go 3 minus 1 minus y, which is 2, and then plus this, which would be 6, equals 1. So looking at that there, does that work out? Yeah, I'm seeing -3 minus 5, and then add that to 6, I get 1 equals 1. So yeah, that does work. And so yeah, you can move on happy in an exam knowing you've solved that correctly by just subbing your solutions back in. And if they don't work, then you know you've done something wrong. So that's kind of great about them. Okay, I'll pause, find your next question. Okay, so I scroll along here to 2016 mock paper 1 and I chose this question. So what this is here is where one of your equations is linear and one of them is non-linear, and the way you solve this is you put the linear equation into the non-linear one by, say, getting x on its own kind of thing. So the reason I picked this one is because it's interesting. This is the equation of a straight line and this is the equation of we should all know, that's a circle. Okay, and that is a circle with center 5, 4 and it's got a radius of √32. Okay, √32. We can get a rough idea for what that number is in our head because we know √36 is 6, so we know this number is a little bit less than 6. It might be like, 5.8 or something. And then this is a straight line, so we could get y on its own there. So it will be x minus 1. So we know it has a slope of 1, so it goes up to 45 degrees and it crosses the y-axis at -1. Okay, so you could actually draw a pretty good diagram of this yourself. So I'm going to draw it in Desmos in a second. But I'm just demonstrating to students here how just some basic knowledge, you can draw a line fairly well. So it goes through -1 there and goes up at 45 degrees, slope of 1. Your rise and run are the same. And then I have a circle centered at 5, 4. So where would that be? Maybe 5 up here, 4, something like this. And then a radius of about 6. So if this is up 4, 6 might be about down there, a little bit over here. See how I done the 4 dots there? Something like that. And then just whip a circle somehow. Now you could obviously draw this more accurately in your exam. But yeah, at least now when you go and get solutions for this, I'm expecting them to be somewhere around here. I'm expecting a solution there and a solution there. Anyways, I'm going to draw this more accurately in Desmos, but it's nice to do a quick sketch. You see, I only spent a few seconds on that. Okay, I'll draw this in Desmos. Okay, so I've drawn, let me clear this away for a second. So I've drawn them up in Desmos so you can see them there. Now this was the circle and the line, and let's just forget about what's on the screen there for a second. So let me turn these off, and let's remind ourselves of my sketch there a second ago. Now that's not a, if you look at this, this isn't a whole bit off. It's really accurately close actually to what's drawn here in Desmos. So definitely you want to be able to kind of sketch things the way I did there at reasonable speed. So when we solve these, we're expecting to get these solutions 1, 0 and 9, 8. And like if you look at my diagram there a second ago, like I was nearly able to, from some of the roughest sketch in the world, I was nearly able to guess that one of the points down here was something like 1, 0 and some other point is way off here like 9, 8. Okay. Anyways, we're going to go and do the algebra on this. So absolutely, see how it says solve these? You could have drawn a graph of these and found those points and you'd have gotten full marks. If this said solve using algebra, you couldn't do the graph method. You would have to do the algebra stuff I'm about to show you here. Okay, so hopefully that benefits people there, seeing how important it is to draw sketches and understand what's going on. Right, so what you do here, maybe get x on its own. X is equal to 1 plus y when you bring it over. And you just put that in for the x here. Now before you go, now you could put it in now if you wanted, yeah. That's actually a good, before you square it out, it's no harm putting it in now, because the 1 will go together with the minus 5 quite nicely. So you just show it for the examiner. 1 plus y minus 5 squared plus y minus 4 squared equals 32. And then I'd put those together before I square it, so I'd get y minus 4 squared plus y minus 4 squared. So they just both happen to be y minus 4 squared. A bit unusual, isn't it? Yep, so that's just the way it works out. Anyways, we know the solutions we're looking for, so we can be sure if we're right or wrong at the end. Y squared minus 8y plus 16. You should all know how to square out a bracket. Y squared minus 8y plus 16 equals 32. Now what's interesting about this is you see the 16s add to 32 and they'd cancel with the 32 on the other side. So you're really just left with 2y squared here minus 16y. Okay, and then that's equal 0. You divide everything by 2, you get y squared minus 8y equals 0. Factor out a y, that's how you factorize this. And you get the two solutions for y. Y are 0 and y are 8. And what's great about when you do simultaneous this way, well, this was the only way to do this question, is you already have gotten x on its own. So you then just put these values in here. So when y is 0, you can pretty clearly see that x is 1. And then when y is 8, you can see that x is 9. And then you would just write them together as points, 1, 0, and 9, 8. And didn't you just see them a second ago in Desmos? Okay, super fun, super easy. Hope you enjoyed that. So I'll get the next question. Yep, so I've only one more on this because, you know, these simultaneous equations, they're not all that complicated. So I'm just going to do this one here, and then that's basically the end of the document. So yeah, solve these simultaneous equations. I've only kind of picked this one because it looks a little complicated with a's and b's. One of the equations, this is basically a linear equation. It doesn't look like it, but it is. Whereas this one up here is non-linear because you've got the squares and stuff. Okay, so let's get into it. So obviously pausing the video, give it a go. So it's just the same thing, isn't it? Again, you know, you just sort of get a on its own, bring them away from the a. You get minus 1, minus 2b. So that's the linear one on its, you move that one around and put it into the non-linear one. Same logic. So then subbing it in here, so this is where you get your marks of the examiner, so you want to be clear when you're subbing in like this. So minus, nice good clear brackets. That's a b multiplied by another b plus a b squared equals a 3. And then just always check before you go working it further, did you sub in correctly here? Because this is a place where people could mess up. Minus, see all the minuses, you know. And yeah, that looks reasonable to me. Yeah. Okay. So squaring this one out, you square the first term, you multiply them together and double it, so that becomes a 4b. And then you square the last term, and that's a 4b squared. This is awkward now, you got to be very careful here. This is minus times a minus 1. So what you could do there is you could make 2 goes out of this, or you can just be careful multiplying it out. I'll let you do this whatever way you like. So I would go minus by the minus 1 by the b. So then that gives me a plus b. Then I go the minus, by the minus 2b gives a plus 2b times the b, so that's plus 2b squared. And then we have a b squared, and then we have a 3. So a lot of stuff going on here. We have 4b squared, 2b squared, and a b squared, so that's a 7b squared. We have 4b and a b. I see a 5b, and what else? Just a number 1, is it? Yeah, and then there's a 3 over here. So I'll bring the 3 over. We might get a minus 2 here. So it looks super awkward, and we'll see if this factorizes. If it gives completely crazy answers, we might have done something wrong, okay? Yeah, so I'm going to put that into the quadratic formula and see do we get anything reasonable. Yeah, so I put that into the quadratic formula there. You'd want to show that for the examiner as well, of course. You all know how to use the quadratic formula, you know, that kind of thing. So you pick up marks for showing it as well, even if you type in your calculator wrong. So the two solutions there from this when you use the minus b formula, I have it typed into my calculator here, but you'd want to show that in the page. I'm getting minus 1 and I'm getting b to be 2 over 7. And then obviously the way this goes down, you've already moved a around on its own, so then you just kind of sub them back in here. You can do this one in your head. You go minus 2, minus 1, so that's plus 2. So then a is a plus 1 when you do that one. And then you put the 2 7s in there. You might want to use the calculator for that. Minus 1, that'd be a bit like minus 4 over 7, wouldn't it? So then I get it like a is equal to like a minus 11 over 7. And you just maybe want to put them together as points. So go like 1 minus 1 and just tell the examiner that's a, b. And then the same here, go like minus 11 over 7, 2 over 7. Okay, cool. Easy stuff, isn't it? I'm not gonna waffle on anymore. Just move one of the variables around, put it in, be careful with your algebra, and do basically when you're using the minus b formula, like I did there to get these two answers, make sure you show that on the page. Don't just type it into your calculator and think you're going to get it right, you know? Because you could type it wrong and then you get no marks for showing how you solve the quadratic. Okay, hopefully people are okay with that. Sure, I'll stop the video there and then we'll move on to our next algebra document. Okay, thanks for watching. Okay, so welcome back. This is part 2 of important past paper questions you should know on the topic of algebra. And there's 6 PDFs here, so we'll try to do it in 6 parts. This is the second PDF. It's got about 30 questions and it says it's focused on the quadratic side of algebra. So we're going to just get straight into it here. I think it's only 33 pages, this document, and I've put red stars beside the important questions. So I'll get this one set up. And as usual, after I have them set up, you know, pause the video and give them a go yourselves. See, can you get them out? Let me see, can I make that a bit bigger? The writing's a bit small on that. Just for anyone on a small screen. Okay, so pause the video, give that a go. Right, so you got to understand what this format is. This is what we call completing the square. Okay, we're completing the square. Here you can see there's 2 x's, but we can write it in a certain way where there's only 1 x. And this format is useful if we want to find like the turning point. So this is a U-shaped quadratic. We know it's U-shaped, it's like the smiley face. If the highest power of x here is positive, it's up on the right. Okay. So, and there's an important graphs video on the YouTube channel for anyone who's interested in knowing more about that. It's called Graph Tricks. Okay, so let's get straight into how you do this, how you complete the square. It's pretty straightforward, and you've got to practice a few of these in your book and get good at them. So what you do here, first of all, is this is your g of x. You can call it y if you want. Probably no harm calling it y. I'll call it y in the next step. So first of all, you want to factor out the thing in front of the x squared. So that leaves behind x squared plus a 4x and then a minus 12 over a 5. Okay. So you factor out the 5 first. And then the next thing you do is the 5 is just out there. The 5 will be out there until we do stuff in here. What you do is you half the value in front of the x. You half the value in front of the x. So then you'll get something like x plus 2 squared. Now, that's all you do. You just half the value in front of the x and then you write it like this. Now think about this. If you were to square this out, what you would get is x squared. And then the next term will be you multiply them together and double it. That will get you your 4x. Now this is what's really important. The last term to come out of this is when you square the last number. When you square that last number, you get a plus 4. You want to kill off that number. You just kill it off like that, okay? So whatever number will come out when you square the last term here, you want to kill it off with a minus 4. So now your number is basically back to 0. and you manufacture in the number you want here. We want the number to be minus 12 over 5, and so we'll just write that in, minus 12 over 5. That's done. So you can, if you want to test if you've done this right, you can go and you can multiply all this out, and you should get the thing inside there, okay? It should all, when you multiply everything out, it should all come back to this up here when you multiply the 5 in. Okay, so what you'd usually do, sometimes the fractions can be a bit nasty here. This definitely is, it's not the most straightforward thing, so usually it's always safe just pick up the calculator and type in what minus 5 minus 12 over 5 is. And the calculator will give you the correct answer. No guesswork. So it's minus 32 over 5. And then what we do then is we just multiply in our 5 at the very end, and we get ourselves a 5x plus 2 squared, and then that'll work out as a minus 32. And that is how you complete the square. Now, why is this format useful? Okay, so let's have a talk. So that's the first thing. Make sure you make a note on this and practice them in your textbook. Why is this useful? So we look at this up here. This is our function. X plus 2 squared with a 5 out the front and a minus 32. We can, as we said, this is a U-shaped quadratic. From this, we can find this will have a minimum point because it's a U-shaped quadratic. We could obviously use calculus to find that turning point, but we can use this as well for it. What we do is we realize, how do we make this guy, all of this here I'm underlining in green, as small as possible? Well, the idea is anything squared is basically always positive. So the best thing we can do is make that thing in green there 0. And the way we can make that thing 0 is by letting x be minus 2, right? So when x is minus 2, this thing here is basically 0, right? And so then y just becomes minus 32. So that's the minimum value this can have, is y equals minus 32. And that occurs when x is equal to minus 2. And so the coordinates of this turning point down here are minus 2, minus 32. Okay? And that's its minimum point. And I'll draw that in Desmos just to confirm that for people. But yeah, that's why we complete the square, because it can help us find the turning point. If it's an n-shaped quadratic, that will be a maximum point. Okay, right, let me pause the video, type that into Desmos and show you it turns at minus 2, minus 32. Okay, we're in Desmos, that's the function, and this is it down here. Oh, who would have known? It turns at minus 2, minus 32. Okay, everyone's happy. Right, back to the PDF. So I'm going to pause this, scroll along to our next one. Okay, so this is our next problem here. So let me snip it, obviously, and make it nice and big for us. This is from 2025, paper 1. So when you see stuff like this is a bit of a buzzword for these type of things, like exactly one solution. What they're telling you here is they're set h of x as y, so they basically set y equal to 0. So when you set y equal to 0, you're basically finding where a function crosses the x-axis like this, okay? So when you set y to 0, that's finding these points, which are called roots. Now, there's kind of 3 scenarios that can happen. You can have 2 distinct roots like this. You can have this scenario here where the graph just touches the x-axis, so you'll only have one root there where my mouse is. Or you can have this scenario, which is there's no real roots. And you should know, if you've done algebra in the textbook, that the thing that determines whether or not you get option 1, 2, or 3 is this guy, b squared minus 4ac. And he is called the discriminant. Okay, that's the discriminant. And so when you get exactly one root, you should have learned this off in the book, b squared minus 4ac is equal to 0 when you get this scenario of exactly one root, okay? So I recommend people revising the discriminant if that doesn't make sense. But I'll actually pause the video, get it up in the book here for people. Okay, so there's the flashcard you'd make for yourself. You can pause the video and write this in. Anytime you're getting real roots, there's 2 scenarios where you get real roots. So that's when you have the 2 equal roots, basically when you just touch the x-axis like I was showing you there. And then when you're greater than 0, that's when you slice the x-axis twice to get 2 distinct different roots. And then this other scenario when b squared minus 4ac is less than 0, that's this kind of bad example here where you don't actually ever get any root. You don't cross the x-axis. Okay, so hopefully people are good with that. And then there's a little diagram on the next page for this. When b squared minus 4ac is greater than 0, you cut the x-axis twice in 2 different places. When it's equal to 0, the discriminant is equal to 0, you hit it only once. And then when it's less than 0, you never hit it. Right, back to our question. Okay, so if we have only one solution for this, that means b squared minus 4ac is equal to 0. Right, so then this looks crazy here, but what we have here is a is the coefficient of x squared, so that is 6m. B is the coefficient of x, and that's minus 4r. and c is the constant at the end, and that's 54m. Okay, so we've extracted that info. We sub it in up here, and we go, you want to show it for the examiner, minus 4r squared minus 4 bracket 6m times c, which is 54m, and we set that equal to 0. So then we get 16r squared. What's this here now? I'll have to use a calculator for that. 4 by 6 by 54. So this is this really big number. It's minus 1296m equals 0. I bet you 16 will divide into that. So let me go 1296 divided by 16. It does. So we got r squared minus 81m equals 0. Now, what are they saying here? Somehow r is equal to 9m. So yeah, we can do that. We could basically bring r squared on one side, 81m on the other, and we could take a square root. You got to be very careful here. When you take a square root, you've got to remember to go plus and minus. So it's plus and minus. Yeah, I lost an m squared here. M squared, because there's two m's there, isn't there? So there's an m squared, and then you go, it gets plus and minus m. Plus and minus 9m. And then it says m and r are positive constants. So then after you write this, you then write that the answer is this here. Okay? Because m is greater than 0. Okay, yeah, hopefully everyone's good with that. A really interesting question, so I'll clear that away, get our next one. So this is our next question here. It's a pretty straightforward one. Pause it, give it a go, obviously. So couldn't be easier. I'm going to maybe try show you two ways to do this. Yeah, I'll show 2 ways to do this. The easiest way to do it is use the factor theorem. If this is a factor, that means x equals 4 is a root, and you can just put h of 4 in here, and the thing will equal 0. That makes sense. When you put the root back in, the solution will be 0. So then 0 equals 4 bracket, I'm putting 0 in for y, and I'm putting 4 in for x, plus 4b minus 12 equals 0. And then what do we got there? We got ourselves a 16 plus a 4b minus a 12 equals 0. That gives a 4. So we got 4 plus 4b equals 0. So then b is clearly minus 1. Okay, so we got b to be minus 1. The answer is done. All right, I'll show you another way, another cool way for your notes. If you went through the textbook, you'd have realized there's a formula. Yeah, like that is the best way to do it. Like I showed on the YouTube channel actually a comparing coefficients method, where you could just write this here is equal to x squared plus bx minus 12. So there's a video on the YouTube channel called comparing coefficients. So you can actually guess what the missing factor is here. If this is an x, this must be also an x because this gives the x squared. The number by the number gives the number at the end. So this has to be a plus 3. If that makes sense. And then we can go then and look at the coefficient of x here. Coefficient of x. Where do our x's come from? They come from the 4 by the x there, so that gives a coefficient of minus 4, and they come from the x by the 3, which gives a coefficient of plus 3, and then that should equal the coefficient of x over here, which is b. So then, as you can see there, b is minus 1. Okay, right, that's another cool way to do this. And you can watch that video on the YouTube channel called Comparing Coefficients. It's basically titled Why Not to Be Using Algebraic Long Division. Okay, it's very interesting. Right, 2 ways to solve that problem, so I'll find your next question. Yeah, so this is a good question here. It's more of a functions question, but it's tied in with algebra. So as you can see up here, this is from 2024, and there's some weird business going on here, where there's a function called s of x, which is a n-shaped quadratic because it's got a negative x squared, and k of x is its image under axial symmetry through the y-axis. And the question that we're interested in doing here, you can pause the video and read this if you want. I can probably snip it and bring it up so we can see both the graph and the question. Okay. I'll probably have to zoom out just a touch, make this work. Okay, people will be happy with that. So what are we seeing here? There's also a video on the YouTube channel called Graph Tricks, and this talks about how you do this. If you have a function like this, let me mark it in for you here. This is him here, s of x. It's an n-shaped quadratic, right? If you want to mirror that function through the y-axis, what you do is you put a minus in front of your x's, okay? And this was detailed in the in that video, so I recommend people go and have a look at that. So all you're doing is you're putting in for x, you're replacing your x's with minus x. So then you go to bracket. So all your x's, you isolate them like this in brackets, and you replace them with minus x, and that mirrors you through the y. So then that equals minus 2x. When this gets squared, it becomes plus x squared, and then you put the minus out in front, so you get minus x squared. So then this then is as it's called, this is called k of x. K of x is this. So now we know the value of b and c. Let me write it this way: minus x squared minus 2x plus 0. So b must be minus 2 and c is 0. I'll draw this in Desmos for people, but it's already contained in that video that you should be watching for homework. So I'll pause this. Okay, so we're in Desmos now. This is the function that was in that question, 2x minus x squared. And as I'm telling you, if you want to mirror that through, what's this axis called? It's called the y-axis. If you want to mirror it through the y-axis, you just isolate your x like this, first of all. Power 2. See, I've isolated x, and you just put minuses in front of your x's. And look what happens. That red graph has been perfectly mirrored through the y-axis. Okay, and obviously the question doesn't plot these bits over here in the question. Okay, they're not part of that question. Okay, so basically stops it after you hit like the maximum point here, which is at 1. Hopefully that makes sense to people. Right, so I'll pause the video, find our next question. Yeah, so I said I'd do this again because you see this buzzword again, has equal roots. So that then again is to do with the discriminant. Okay, so I'll hammer this out in a second. It'll only take a second to solve this problem. Obviously, pause the video, give it yourself, see if you've learned how to use the b squared minus 4ac. Okay, if it says it has equal roots, it's this scenario. And then you just do the same thing again. A is 1, b is 2p, and c is 3p plus 4. You sub it in up here, make it clear for the examiner. That goes in for b, this goes in for a, this goes in for c. That discriminant is equal to 0. You get 4p squared. Multiply this out, you get minus 12p minus 16 equals 0. That's annoying because that's a quadratic, but we can divide by 4. P squared 3p minus 4 equals 0. Factorize it. You get a p and another p equals 0. Probably minus 4 plus 1. So then the solutions are p is equal to 4 and p is equal to minus 1. P is a positive constant. You put a mark through that and you circle that, and then that's p. Okay, couldn't be easier. Okay, hopefully that makes sense to people, and you gave that a go, of course. Find the value of p, and yeah, sure, then that's easy. Once you have p, right, you can just put it back in there. You put the 4 back in there, and then you get a quadratic, and you get 2 solutions for x then, okay? Right, I'll pause the video, find our next one. Yeah, so I found this question interesting. So this is part of that same year, whatever year that was from above there, where we're doing the one with the equal roots. So definitely pause the video and try and get something going for yourselves here. See, can you get out answers? Because it's very interesting. It says find the equation whose roots are 3 times those of this. So that's a bit of an interesting instruction. So a good idea maybe might be go and get this guy's roots. Okay, first of all, that'd be my logic. So let's see, can we get this guy's roots? So we'll go x and x. Factors, so I'm seeing 6 and 2 could probably do this. So we go minus 6. Sorry, did I say 6? What will make a 9 actually? Will anything make a 9 there? No. So I don't know, will this factorize? So let me pause the video and let me think. Okay, yeah, I had a pause to think about that. So that thing obviously doesn't factorize, okay? So what you do is you'd need the minus b formula if you want to do this question this way. So we go x equals minus b, which is minus 9 plus and minus. You want to show your workings for the examiner. B squared, so you just write that squared. That's fine because the sign doesn't matter. B squared minus 4 bracket a bracket c. And then make sure your square root covers everything. And then it's over 2 times 1. So you type this into your calculator. So I typed it into my calculator to confirm that there was no roots that time. Just checking it's all typed in correctly. Yeah, it is. So the solutions are minus 9 when you use the plus root 129 over 2. All right, so we're going to show you 2 ways to solve this question. So this wouldn't be the way I want to solve it, but this is the way I'm sure a lot of people would have went and solved it, so that's why I'm doing it this way. So then this will be minus 9 minus root 129 over 2. Okay, so yeah, so there are two roots. So then what we want to do is basically times them by 3 and make a brand new quadratic, and that would work. And we just kind of multiply it out carefully. So you go x. So the actual two roots that we'll want will be like x equals like minus 27 plus 3 root 129 over 2. And then the other root, then you could call it like x1 and x2. The other root will be minus 27 minus 3 root 129 over 2. So that's where we've taken the roots and times them by 3, okay? So then we just make a quadratic from this. As we know, say like in an easy example, if x was 3 and x was 4, we could make the quadratic from going x minus 3 bracket x minus 4 equals 0, okay? So you basically just subtract the roots and then put them in brackets instead of equal to 0. So that's what you got to do here, and it's a complete menace. You go x, and you want to take away this. You need to be very careful. You could just maybe do it like this for the examiner first, so you can pick up the marks at least before you go doing the crazy business of trying to multiply this out. Over 2 bracket, and then that's going to be multiplied by the other guy. Let me try and get it in here for you without everyone panicking. So then it's x take away this guy minus 27 minus 3 root 129 129 over 2, and you close off the bracket and then make sure you say equals 0. Now you pick up a ton of marks off the examiner for that, but that's an absolute headache to have to go and multiply all that out, okay? And I'm going to leave that for you for homework if you want to try and multiply that out, but I'm going to show you the other way that this question is kind of meant to be done. But if you do multiply that out, you will get the answer, okay? But the whole intent is not to have to do it this way. The hint that there was another way was when you get these crazy looking roots, okay? So the idea is, in general, there's a formula that was discussed in the textbook at some point and I'll write it up here for people in case they forgot it. This is particularly important for your complex numbers. It's x squared minus the sum of the roots, times x plus the product of the roots, equals 0 works. So let's confirm that this formula works. So remember I gave you an example of, let's say x was 3 and x was 4, right? So then the two factors for that, if we were to do it the factor way, we would go like x minus 3 bracket x minus 4 equals 0, and we'd multiply this out, and when you'd multiply this out, I'll just do it here quickly, that would give, you get a minus 3x, a minus 4x, that's a minus 7x, and then you go multiply the numbers together, you get plus 12. Okay, you can obviously pause the video and multiply that out if you don't believe me. Okay, so you can do it that way, which is what we were doing there a second ago, right? Or you can use this really quick formula. So you just go x squared, what are the two roots? You sum them together, they give 7. So then you go minus the sum of them, so minus 7x, and then you multiply them together in your calculator and you get a 12. And it's equals 0. And that's how you get back to the original quadratic. So that will be quite useful for what we were doing there just a second ago, where you had two awkward looking roots. All you have to do is just add them together in a calculator and then minus them. And then minus once you've added them together, because that's what sum means. And then just take your two roots that we had there that looked really awkward, and then just multiply them together. You'll get yourself a number, and that'll be your product of roots, and then sub it in there. Hopefully that makes sense to people. And then another way, the absolute main way this question was meant to be solved was you not to actually work out the roots at all, okay? So the idea was here that you just compare this thing to this thing here. So x squared minus the sum of the roots. So this actually turned out to be quite an interesting question, so happy I done it. So it was well thought up whatever year this appeared. Plus the product of the roots equals 0. So this tells us something. So let's call the two roots. Let's call the first root here a, and then let's call the second root b, okay? The first root is a, the second root is b. So what we can see from this, all right, let me get another color for this, is that if there's a plus 9 there, the plus 9 is minus the sum of the roots, okay? So hopefully people are okay that minus 9 equals a plus b, if the two roots are a and b, as I said here. So think about it. If the 9 is minus sum of the roots, then minus 9 itself is the sum of the roots, okay? You'd have to put a minus 9 in here to turn that into a plus 9, hence that sum of the roots is a plus b. Pause the video and think about that if that doesn't make sense to you. And then the product, which is this minus 12 thing, would be equal to a times b. Okay, great. So that's one way of doing that there. So in general, though, for the quadratic that we want to put together, our roots will be x1 would be equal to 3a and x2 would be equal to 3b, wouldn't it? So they're going to be our three roots. So then let's put this, there are two roots, sorry. So then we sub that into the red formula up here. We get ourselves x squared minus the sum of these three roots. That would be bracket minus 3a plus 3b times x, because that's the sum of the roots. And the product of these, everyone I'm sure can multiply two things together. You get yourself 9ab, and then set that equal to 0. So now we just need to know what to sub in here, but this is easy. We know that AB is minus 12, so we can just put minus 12 in there. And this is a little awkward, so we know 3A, we're looking for 3A plus 3B, but we know A plus B is minus 9, so then 3A, if you just multiply both sides by 3, you see this is minus 27. And so the quadratic you were looking for were x squared minus 27 x plus basically AB is minus 12, so you just go 9 times minus 12, replacing AB with minus 12. And you just multiply this together, so you get x squared plus 27x. I think that's minus 108, but I'll just check in my calculator. It is minus 108. 9 multiplied by minus 12. Yep. Okay, so there you go. So you see how I really done this without ever finding out the roots. I just called the roots A and B, and I just done some basic algebra stuff. So that's the way this question was meant to be done. So obviously make a few flashcards on this if this formula is a complete curveball to you. This formula works. I showed you how it works with the 3 and 4 example. X equals 3, x equals 4. And you've seen a kind of a really cool, interesting question here on how you can work through a problem like this. Okay, without actually ever working out the roots. Great, so hopefully you enjoyed that. So let me pause the video, get our next one. Yeah, I didn't put a star beside this one, but I was scrolling past it and I said it's quite interesting. So the next document that we'll do on algebra will be to do with these inequalities, but I'll actually just hammer one out here. It's kind of interesting. So for those interested, this is from a 2023 mock paper. And both of these are very interesting questions. So pause the video, give them a go, see can you do them, see where your algebra is at. So it says has two distinct roots, so that's our good old friend the discriminant again, isn't it? And then if you have two distinct roots, you're greater than 0. And you can see here A is going to be equal to 1, B is going to be equal to K, and C is K plus 3. So you can just kind of, I'll sub it in here, but you can see what it's going to give. It's going to give K squared when you sub in for B, and then it's minus 4 bracket A, which is 1, bracket C, which is K plus 3, greater than 0. And you get yourself a K squared minus a 4K minus 4 times the 3 is minus 12, greater than 0. Okay, full marks. Now I'm going to do this here. So when the way you solve these, right, is you factorize it, first of all. They're usually factorizable. Be a very mean question if it wasn't. Probably 6 and 2 minus 6 plus 2. Yeah. Now, your solutions are not 6 and minus 2. Okay. What you got to do here is you got to draw a number line. And you put 2 dots on the number line. Okay. You can write those solutions up here in the corner, but they're not actually your answers. You can write them in small. K is 6 and K is minus 2. They're not your answers. Okay, you draw a number line with 2 dots. The furthest one to the left is you write the furthest, whoever is the furthest left here on a number line. Minus 2 occurs first on a number line, then 6. Now, this thing is usually a U-shaped quadratic, okay? If it wasn't a U-shaped quadratic, you would have multiplied everyone by minus 1 at the beginning to make it 1 anyways, you know? And that would have changed the direction of this inequality. So, yeah, it's good to always be working with a U-shaped quadratic, okay? So then you draw a U-shaped quadratic through this because that's what this is, okay? Then this thing is, look at it here, it's greater than 0, okay? It's greater than 0. Because it's greater than 0, you shade in the part of the U-shaped quadratic you drew that's above the number line, and then you just describe the green region. This green region is when x is greater than 6, and this green region here is when x is less than minus 2, and that's the answer. Okay, that's this question done. If this was a greater than or equal to symbol, these would be less than and greater than or equal to symbols, okay? Okay, hopefully people are good with that. So I'll find our next question. Yeah, so this was an interesting bit of a question here this year. So I said I'd do this because it's got like kind of three unknowns in it, A, B, and H. X is an unknown. X is a variable. We like X to not have a value. Okay. Um, right. So pause the video, give this a go. Very interesting question. Show that for any real values, the quadratic equation has real roots. Okay, so that then again is our discriminant. So when it has real roots, its b squared minus 4ac is greater than or equal to 0. So I showed you that in the yellow box if you remember it. You can rewind the video back to where I showed it. But when it's greater than or equal to 0 when you have real roots, it takes into account both the scenario when you have two distinct roots and one real repeating root. Great. So to get this to look like that though, we have to multiply this out a bit. So we get x squared, you multiply everything out here, you get like a minus, what was it, xb? Or sorry, you'd write the b first. Minus bx, then it's the a's turn, it's minus ax, and then it's a plus ab, and then it's a minus h squared. Quadratic equation, yeah, this is a mock paper. They obviously meant to write that equal to 0, okay? It means nothing if it's not equal to 0. Yeah, or at least it should have been equal to y if they meant something there, you know? They can't just say this. Okay, anyways, we'll push ahead. So what is the value of a? A is everything in front of the x squared, so that's 1. So the b then, now that's a bit annoying because there's b here and there's b here, but this is the b from, you know, the ax squared plus bx plus c equals 0. B is everything that's the coefficient of x, and there's two x's here, so you can factor out the x and you can see that the coefficient is minus b minus a. Hopefully people are okay with that. And the c here, the c is everything without an x in it, and so that's an ab minus h squared. Okay, so we'll sub those in here, right? So in for b, we put this, so minus b minus a squared. We'll go minus 4 times a times c, which is this, ab minus h squared, and then that's greater than or equal to 0. Okay, so we'll go and we'll multiply this out and see what happens. It's hard to know where this question is going to go, but we'll do what they're instructing us to do. So we'll go a squared. Yeah, so I'll keep the order here. You square the first term, multiply them together and double it, 2ab plus a squared. Be careful multiplying this out. This will be a minus 4ab, and then this will be a plus h squared, plus 4h squared. We get times it together. And then that's greater than or equal to 0. Right, so this is looking a bit awkward, but we can tidy it up a bit. So I'll write it as a squared. Nice to have a first because it's alphabetically first. Minus 2ab when you put the 2ab and the minus 4ab together. And our plus b squared. And then we have our plus 4h squared here. And then this is greater than or equal to 0. You should know what this thing is here. Okay, this here is a minus b squared. Okay, think about it. That's just one of those things. Like you've got to be so used to squaring things out that this is two things doubled and multiplied, you know. So that's a minus b squared, and then this is a plus 4h squared greater than or equal to 0. So it's saying here, show that for any real values of a, b, and h, this quadratic has real roots. Okay, so then the question now basically is, let me clear up some of my workings here so I have space to show you where this question has actually gone now. So we've done all that algebra, and we got this, okay? And we just need to wrap this up for the examiner and explain how this thing is true, okay? We need to explain why it's true. So you just say to the examiner basically, right? This thing here, the a minus b squared is always greater than 0. And you can say as anything squared is greater than 0, which, you know, greater than or equal to true. That's true. And then we focus on this guy. 4h squared is greater than or equal to 0. Why? Well, because h is being squared. So it doesn't matter what h's value is. It's 4 times something squared, which is always something positive or equal to 0. Okay? So therefore, a minus b squared added to something else here. Both of these two things are positive, so then this thing is true. So basically, hopefully that makes sense to people. The examiner will leave you alone there because you've shown that this thing here, a minus b squared, is always greater than or equal to 0 because when you square something, you can't get a negative number. And the same here, 4h squared, because the h is being squared. It doesn't matter what h's value is. It could be like minus 100. When you square minus 100, you get plus 10,000, you know. So you just state for the examiner here that thing is always greater than or equal to 0. Therefore, the whole thing is always greater than or equal to 0. Okay, that was an interesting question. A lot of students might have got to here and then struggled with wrapping it up there to prove that the thing is true. Okay, hopefully people are good with that. Very interesting question there. Very, very well thought up. Completely fair game to find something like that in an exam. Okay, I'll pause this, get our next question. Okay, this was a smart question here from a 2022 paper. Explain why this quadratic has no real solutions. So everyone should pause this, give this a go. See, can you explain why it has no solutions? So first thing I'll comment is what format is this in? This is in the completed square format. Okay, so you could actually find this thing's turning point from this if people are aware of that. So when does this turn? Okay, this will be a U-shaped quadratic if you multiplied it out. Where does it turn? Well, the way we find this thing's turning point is this is something being squared, so the minimum value that could have is 0. That will have a value of 0 when 2x plus 3 has a value of 0, and that occurs when x is equal to minus 3 over 2. And when x takes on minus 3 over 2, this thing takes on a value of 0. So then, remember, this will be equal to y when you're finding the turning point. So then it would take on a y value of 7. So then this function has a minimum point located here. Now, if we were to graph that on an x and a y plane, we can do this you can actually draw a really accurate diagram of something, a quadratic, once you know its turning point. So you would just come over here, minus 1.5 on the x, come up here 7, draw a dot, and then draw a U-shaped quadratic there, okay? And that would be completely full marks as long as you just say to the examiner, therefore never crosses x-axis, therefore no roots. Do you get me? If it has no roots, when you set y to 0 like they have in this question here, there is no solutions. There are no roots, okay? So that is one way to solve this question, is basically find its lowest point here by completing the square, which it was already in, and show that that point never crosses the x-axis. So then there's no roots. It never does this. For there to be roots, it would have to cross the x-axis like this, and it never does. So hopefully that makes sense to people. Now, not everyone would do it that way. That's only one way to do it. What people would do is they'd multiply all this out and use the fact that if it has no roots, b squared minus 4ac is less than 0. And that'll fine. We get the same solution. So we go 4x squared, we square this out, plus a 12x, multiplying together, double it, and then square the last term. Then we get 4x squared plus 12x and then a plus 16 equals 0. Okay, obviously we might divide everything by 4 here to tidy it up a bit. X squared plus 3x plus 4 equals 0. Okay, no point factorizing this because we know it's not going to have any roots based on the way the question's working. So we'll just get b squared minus 4ac here. State for the examiner that a is 1, b is 3, c is 4. Sub them in up here nice and neat. 3 squared minus 4 times a, which is 1, times c, which is 4. Say it's less than 0. Then multiply this out. You get yourself a 9 minus 16 is less than 0. And then 9 minus 16 is minus 7. Minus 7 is less than 0. And that's true, therefore true, isn't it? Minus 7 is less than 0. And as that discriminant was clearly less than 0, it means therefore there are no roots. No real roots, okay? There will be 2 imaginary roots, but that's from the complex number chapter. But there are no real roots. So you can do this 2 ways. You can use your discriminant, or you can just find, as we done there, where it turns. And if it turns in a place that's above the x-axis, in other words, the x coordinate can be whatever it wants. But if the y coordinate here of the turning point is basically greater than 0, it means it's turning above the x-axis and there'll be no solutions. Hopefully that makes sense to people. If that doesn't make sense, you can just do the discriminant thing there to get you out of trouble. Okay, I'll do the next problem. Yeah, so scrolling along here, I've seen another one. This is interesting where it tells you there's going to be something like a remainder. So usually all our factorizing and long division, it never usually has a remainder, but this was a unique question this year in 2022 where they made students kind of think about what you would do if there's a remainder. So your long division would be pretty useful here for this. Right. So pause the video, give this a go. So we'll do this the long division way, but you could also do it a little bit of a factorizing way as they have it done up here. But we'll do the long division way. So you go 3x squared plus 2x plus 5, and you long divide x plus 1 into this. Okay, so what would you multiply this by to get a 3x squared? You'd multiply it by a 3x. So then you multiply this by 3x and write it in here. 3x squared plus 3x. So you just multiply this by 3x. You draw a line under it always, and you subtract always. This minus this gives 0. This 2x minus 3x gives a minus x. You bring down the 5. And you ask yourself, what do I multiply x plus 1 by to get minus x plus 5? You multiply it by minus 1. Multiply this by minus 1. So you get minus x minus 1. Draw a line under it. Always subtract. Take minus x minus minus x gives 0. 5 minus minus 1 gives 6. That goes into that with a remainder of 6. Okay, that's the remainder. So what they've got written up here is x plus 1 times 3x minus 1 with a remainder of 6. And you can move on happy in your exam knowing you've done this correctly. Multiply that out in purple and it should go back to this. And that means you've done everything right. Okay, hopefully people are good with that. Yeah, like you could do this using factorizing. Okay, so I'll just kind of maybe just do a little demo for people here on how you could do this, doing a bit of factorizing. Plus C. So we know for sure this has to be a 3x. Like it has to be a 3x because what do we have over here? 3x squared plus 2x plus 5. Because this is the x times the x. This is the only place you get an x squared from, okay? So this has to be 3x here, okay? So then what's here? This is just a number. We can call it something like, they actually have it called plus b up there, so we'll call it plus b for now. So where does the 5 come from? The 5 is made by a combination of the 1 times the b, add with your remainder here. So then that's b plus c equals 5. So that's like looking at the constant, okay? And then there's one thing we haven't looked at, and that's the coefficient of x. Okay, where do x's come from here on the left side? You get them from going 1 times the 3x, so that gives a coefficient of 3. And then you go get it from the x times the b, so that gives a coefficient of b. And that'll be equal this coefficient of x over here, which is 2. So then that tells us that b is minus 1 there. And so if b is equal to minus 1, we can sum that back in up here. Minus 1 plus c equals 5. So then c, bring the minus 1 over is 6. Ta-da! Same thing as before. Okay. If that didn't make sense to you, maybe go have a look at that comparing coefficients thing on the YouTube channel. I think it's called Why You Don't Ever Need to Use Long Division. So that's how you would do it using this method here. But the long division worked pretty neat as well in this example here. So, you know, whichever way you prefer. For this example, but in the harder ones with cubics and weird letters floating around, the comparing coefficients wins every time. Okay, right, I'll pause the video here, get our next one. Okay, so we're back to 2020 here. So they had a smart part 1, part 2. Was there any more parts? Yeah, then there was a part 3 here. This was very smart. Okay, so we'll do these 2 parts first of all. Obviously, I recommend people pausing the video and giving them a go yourselves. You get the most learning from it that way. Okay, hopefully you try that. So it's some quadratic and we don't know the p-value, but we're told the p-value will only go between here and here. Okay, that's useful. And p is like a whole number here. It's a positive, negative whole number. It's an integer. So easy one to start us off. Find the value for p for which this is a factor. So we can just use the factor theorem here. If this is a factor, that means x equals minus 3 is a root. And when you put a root back into the function, y will equal 0. F of x is 0. F of x is y, so y is 0 when you put the root back in. So you basically set y to 0, and then you put minus 3 in for x. And that is what's called the factor theorem. Plus p. And then we get, what is this, 9 minus 15 plus p equals 0. That's a minus 6, so, you know, doing this very quickly, it looks like p is a plus 6. Looks good. Okay. This is an interesting one here. Find the value of p for which f of x has roots that differ by 3. Right, that's a bit confusing. And what you have to do here is you got to call. Okay, let's say one of the roots is a, and let's say the other root is b. Right, and then let's just give one of them the dominance. Let's say a is greater than b. Okay, now we've kind of set up the problem a bit, and now we can do this differ by 3 thing. We can say a minus b equals 3. Hopefully that makes sense to people. So we have now come up with a way of converting this very complicated statement here into a bit of algebra. A minus b, which are our two roots, are equal to 3. Okay, that's them differing by 3. So then what could we do here? Well, we could put our thing back into our quadratic. So we could make a quadratic out of this. So we could go x minus a, x minus b, basically making the quadratic equal to 0. When we take our roots and make factors of them like this, we multiply this out, we get x squared minus bx minus ax plus ab. This is just one way to solve this question. You know, there's others. So then this is this up here when it's equal to 0. Okay. So then I could probably tidy this up a little bit. I could call it x squared. I can factor out the x plus x multiplied by minus a minus b, and then we have our ab at the end, and then that's equal to 0. Right, so then we can just line this up a little bit up here. Look at this. The 5 must be equal to this, because this is the thing that's in front of the x here, and this is the thing that's in front of the x. So you can write 5 equals minus a minus b, and you get marks for the examiner for that. And so now we have two equations, two unknowns, and we could just solve for a and b here. So then what would I do here? I might say that you can just probably add these, you know, you can solve this. I'm just going to add both equations to one another. So I'm going to add, I'll write them about, do the real junior cert thing here. I'll write them above one another like this. Minus a minus b equals 5. Draw a line under them and add them. The a's cancel, so you get minus 2b equals 8. So then b is minus 4. And then if b is minus 4, then a is equal to, okay, this is tricky here, so let me go a. You put a minus 4 in for b, you get a plus 4 there equals 3. And then you bring that over and you get a is minus 1. Okay, so they're your two roots, but that's not the value of p. P is what you're looking for, and p itself is the ab that's here. And if a and b are minus 1, minus 4, then in this scenario here, p is a plus 4 because it's a times b. Okay, very interesting question that I hope people can appreciate the way I set it up. What was hard here was for the student to realize, okay, that's fine. I'll just make up roots called a and b. I'll say a is the bigger one, and then I'll write this equation, and then go and make a quadratic with my two roots that I made up, and then I'll just compare what this becomes with the original, and then I'll get another equation from 5 equals the whatever the coefficient of x is here. Great, hopefully people appreciated that. So the next one down here, let me snip this so we have our original thing, and then we'll go down to the part 3. Right, pause the video, give this a go. This is a really interesting question. Find the two values of p for which the graph will not cross the x-axis. Now, from all the questions we've done, you should start to be seeing the pattern. When a function quadratic does not cross the x-axis, this is related to the discriminant, okay? This is when it has the no real roots. If you do not cross the x-axis, you have no real roots. So this thing has no roots. And when it has no roots, b squared minus 4ac is less than 0. And that's the solution to this question. So we're going to do that. So basically what they have given us as an instruction here, right, is to basically go b squared minus 4ac is less than 0. A is equal to 1, b is equal to 5, and c is equal to p. Sub them in here, you get 25 minus 4 times 1 times p is less than 0. What else then is here? We can move this around. We'll write it like this first of all. 25 minus 4p is less than 0. What will I do here? I'll go minus 4p is less than minus 25, and I'm going to multiply both sides by minus 1. What's that going to do to the inequality? It's going to flip its direction. So then I get 4p is greater than 25, and I get p is greater than 25 over 4. Now, if we remember from the question, look at this here. Now that looks like there's a load of values here. Do you get me? That looks like there's loads of possible values. Any value above 25 over 4 is an answer, but you got to tie that in with this up here and the fact that p can only be like an integer. So 25 over 4 is 6.25. So it says p is greater than 6.25. So if p is, it's supposed to be less than 8, but then greater than 6.25, and it's meant to be an integer, there's only really two solutions here. P can be 7 or P can be 8. Ta-da! So it's a little bit of a, that's a really tough question because the students have to be able to decode this into realize it's b squared minus 4c is less than 0. And then they need to understand not to panic here and say that this, how to convert that into the two values by remembering this thing up here. Okay, hopefully he enjoyed that. So I'll find the next question. Shouldn't be too many more. Okay, so I found our next question here. It's from a 2019 mock paper 1. So it's a graph question. So we're first of all asked to match these up here. And then we're asked to sketch a graph down here, okay? So obviously pause the video, give this a go, and see can you work it out. Okay, so I would have done a graph video on the channel, so that would have helped people if they've already seen that. There's a big thing here. If a function like this is down on the right, it means its highest power of x has a negative coefficient, right? And all of these are down on the right. So if I see any one of these that will be up on the right, it's not one of those functions. So do you see this guy here? If I was to multiply all of this out, I get a coefficient of plus x to the 4. And if you don't believe me, you can just go and multiply all that out, you know, if you've loads of time on your hands. But the idea is that will give an x squared as its leading term. This will have an x, and then you go x times the x squared times the x, and you get a plus x squared. X to the 4 is the highest power of x. It has a coefficient of plus 1. So this guy, if you were to sketch him, he should be up on the right. And none of these functions are up on the right. So this guy is not one of our guys. Okay? Hopefully that makes sense to people. So all of these are down on the right. And that means the highest power of x will be negative for them. And so you can see the rest of these will have negative leading powers for their highest power of x. Hopefully that makes sense to people. So this is obviously the quadratic. You can see that if you were to multiply it out, you'd get like, what is it, like minus x squared. I'll multiply this one out just for the sake of it. You get a 2x, and you get a minus 2x, so it has no x, so then it's just x squared. Minus x squared plus 4 is what that h of x is equal to. And that's what this is here. For people, if you want to find where this crosses the y-axis, you set x to 0, but the number at the end anyways is always where it crosses the y-axis. So that crosses it at 4 there. And these are its two roots. Its two roots are when x is minus 2, and then when x is a plus 2 here. So that's definitely graph B. Okay. Hopefully people are good with that explanation. I'm sure you worked out that was obviously the quadratic, but nice to see the extra bits there. Okay, so who's f of x and who's g of x up here? Well, this guy only turns twice, as you can see here. So a cubic turns twice. So who's the cubic? This is obviously the cubic. So this is C. This guy turns once, twice, 3 times. So he's obviously an x to the 4. And so that's A. So that'll be pretty much full marks there. I'll just go through another bit of stuff here. You can see this guy's roots. See, he has a root of when x is 0, will give him a y value of 0. Also, when x is equal to minus 3 would be setting y to 0. And then if you let x be 1, that will be another one of his roots. And so you can see the root of 1, you can see the root of 0, and you can see the root of minus 3 there. Great. And same here. This guy has a root of x equals 0. This guy has a so when you see a squared like this, that counts as a double root. Okay? So he has x minus 2, but that's a double root. And double roots look like this. It's when you just touch the x-axis like that. That's a double root. So that's really important for people to make a note on. And then he has this other single root, x equals minus 1. So there's his double root at x equals minus 2. Here's his root of 0. And then here's his last root then of minus 1. No, minus 1. Why is that working out as... Oh, because I'm looking at the wrong one, am I? silly me. Obviously up here, this is it looks very similar. So that still gives a root of x equals 0. This gives the double root of x equals minus 2, and then this gives the root of x equals plus 1. So there's your root of plus 1 there. Okay, so that's another proof for why t of x isn't the answer, because it's supposed to have a root at minus 1, which this one doesn't. Okay, hopefully people get that. Hopefully people get that. So then we're asked to sketch this guy here. Okay, so pause the video and see can you sketch that on your page or whatever. So this is, if I was to multiply all of this out, we'd get a plus x to the 4 as our highest power. You can pause the video and multiply all that out if you want to. So that means I'm going to be up on the right. Okay, I'm definitely going to be up on the right. This is going to be an x to the 4, which means it's going to turn once, twice, and 3 times. Okay, so I'm going to be looking at something that's a w. Okay, x to the 4 is turned 3 times, usually. Cubics turn twice, and quadratics turn once, and linears turn no time. They're just a straight line. Okay, so I'm basically sketching a w. Now, I know its roots. It has a root at x equals minus 1. It has a root at x equals 0. And it has a double root. Okay, I'll write it twice. It has a double root at x equals 2. So basically, I could say that this here is x equals 2. And that's going to be a double root. So he actually comes down and touches it here, okay? Touches it. I also know where it's going to cross the y-axis. If I was to multiply all this out, people, right? I'll just multiply out the quadratic part here. That'll be minus 4x plus 4. And then that's times an x and times an x plus 1. If you were to go and multiply all of this out, the number at the very end would be a plus 4. And if you don't believe me, go and multiply the whole thing out and you'll see the number at the end is a plus 4. That number at the end tells us where we cross the y-axis. So that means this function is going to cross the y-axis at 4. Okay? Okay, hopefully people are good at that. It also has a root here of x equals 0. So we have to go through this point. And we have a root of minus 1. So we're kind of a bit tight in here now. We want to, how many boxes did I came over there? I should have came over maybe a bit more here. We'll go over six blocks, we'll say, is 2 units. So then minus 1 will just be 3 blocks back. So then if I'm doing 4, I want to come up 12 blocks, if that makes sense. 6, 12. So the 4 is up here. That's the 4. Okay, hopefully people are good at that. Right, so we know the points we want to go through. We want to go through that red point, and this red point somehow, and we've got to draw a W. All right, so let's give this a go. So we come down, touch this, we've got to do a turn here, and we've got to, so how's that going to give, oh no, sorry, that's me waffling on there. So the idea is if you were to multiply all of this out, because there's a single x there, that's not a 1, it won't be able to go through the 4. And you see anyways why that couldn't have gone through 4. How am I going to cut through here and then also cut through here somehow? It just doesn't work. Okay. If that was like a 1, for example, then it would have had that 4 at the end. So sorry about that explanation there, that it would have go in at a 4. But anyways, it's all corrected now, so you won't lose sleep over. So we're not aiming for this 4 up here. So we're aiming for this 0. So you want to maybe come up here, turn somewhere, go down there, and then flip back up there. Anything like that would get you fairly reasonable marks. What the examiner will be looking for is the student realized it was up on the right. They realized it turned 3 times. They realized that the x equals 2 was a double root, so they came down and touched it here, and they crashed through 0 and minus 1. Okay. So we'll have a look at that in Desmos and see how close this was. If you wanted to make an even more accurate sketch, you could go and work out, say, how far it comes down here. So what's in between 0 and minus 1? It's minus a half. You could go and get p of minus a half and see what its y value is down here, okay? See how far it goes down. I'll actually pause the video and I'll work out what p of minus a half is, okay? Rub that out there. Okay, so p is minus a half there. So I have it as a fraction, but you want it as a decimal when you're doing graphs. So it works out as about minus 1.56. So yeah, that's actually quite accurately drawn there, because I want to come down here, you know, kind of, if 3 units is 1, I want to come down maybe 4.5 blocks. So it's like minus 1.56 is down here. So we'd want to crash in down here. because the turning point would be between the two roots, if that makes sense, because of the symmetry. So that would be her turning there. And then the same here, we could actually find how high up this point is, because this is 0 and this is 2. We could just work out how high it is when you go p of 1. Okay, p of 1, so I'll get p of 1 on my calculator. This is actually pretty easy, you could do this in your head. If you put a 1 in there, that'll be a minus 1 squared, so that gives a 1. And then this is 1, and then this is 1 plus 1, so then this is 2. So that's 2. So this goes too high. So then we go and plot 2. So this should have actually only came up to here, okay? So that red graph should have went up there and turned there. If that makes sense? Should have turned there. So yeah, that's actually pretty good now. There. So let me tidy that up a bit now with that new information. I'll clear this away and pause the video. Okay, so I've kind of updated our points there. See, I still have my three roots of my double root there at 2. I have my root of 0 and I have my root of minus 1. Remember, we worked out this turning point here by putting p of minus a half in, and then the p of 1 we got here, this turning point, because we know it's going to turn in between its two next roots, if that makes sense. So basically just have it coming down here, touching here, come up here and touch its max point there. So you see the bit of symmetry there. You want to make this obviously a bit more curly when you're in your exam. Come down and turn there and that. So that would be what you'd be aiming for there. Now I'm going to check that in Desmos, see how close I came. Okay, so there you go. So yeah, pretty close, pretty close to it. So it was a tough question making a graph something like this. So you see we got the W shape pretty good. You can see that when x was 1, you got this value of 2, which was really close to where it turns. So you're seeing a bit of the symmetry there, you know. It's not perfectly symmetrical, but it's pretty close to symmetry. So between your two roots here, you can see, remember when you're like the minus a half here, you're like the 1.56 we got there a second ago, about there, yeah. Okay, great. Hopefully people learned something from that, and you see the up and the right action. Okay, tough one for sure. Okay, so hopefully that helped. So let me pause and get our next one. Okay, so our next question here comes from 2017, so I think this is our second last question. So what are we told? We're told about some quadratic. We're told to write it in the completed square format and then find its minimum point, and we're told hence, so we can't go and use our differential calculus to find its turning point. We have to use the completed square format, and then explain why it must have two real roots. So we've actually already done stuff like this. So this is a good chance for students to kind of check, see if they've learned stuff from the previous part of the video. So the idea is here, if you want to complete the square on this, what you do is you factor out the 2. You get yourself an x squared minus 7 over 2x minus 5. And then the 2 will just hang out here all the time. You half what's in front of the x, a little bit tricky. You can do this in your calculator. You can go like 7 over 2 halved, which is the same as multiplying by a half, and you'll get minus 7 over 4. Remember, we have that thing being squared. Now, if you were to square all of this out, you know, the number that comes out of this at the end would be, you square the last term, so it would be 49 over 16 positive. You kill off that 49 over 16, and now your number is back to 0. It's very simple. And then you just manufacture in the number you want up here, so this is minus 5. So this is a good example here because the numbers were a bit more awkward, you know. And then you get your calculator to combine what minus 49 over 16 and minus 5 are. So you get another awkward number. So there's a 2 out here. It's x minus 7 over 4 squared. And then this number is minus 129 over 16. And then you multiply back in your 2, and the final answer is 2x minus 7 over 4 squared minus 129 over 8. Okay, very awkward. And that's equal to f of x. You're asked then to find the minimum point from your completed square. The minimum value this can have occurs when you let x equal, this thing will always be bigger than or equal to 0. So the best scenario you can be is give this thing 0. That will take on a value of 0 when you let x equals 7 over 4. And when you let x equal 7 over 4, this takes on 0. And then y's minimum value is this number here. That gives y minus 129 over 8. Okay, so the turning point, or the minimum point, is 7 over 4 minus 129 over 8. And remember, this is like a U-shaped quadratic. So its turning point kind of crashes down here. 7 over 4 is a little bit less than 2. So that's, you know, this is say the 7 over 4, and this isn't drawn to scale, but then this thing down here is the minus 129 over 8. I'll draw that in Desmos for people. Okay, so we're in Desmos here, and this is our turning point here, and there it is. That is 7 over 4, and if you type what 129 over 16 is 129, what was it? 129 over 8 was the turning point. Let me get it back up here. Yeah, 129 over 8. You go 129 divided by 8 in your calculator, and you get that number down there, negative 16.125. Okay. So yeah, it obviously worked, okay? So hopefully people are okay with that, and you're okay with my little sketch up here in the top right for what this is. And now look at this here, part C, it's such easy marks. Explain why it must have two real roots. You do not need to go and use the discriminant here. You can just explain straightforward to the examiner. Based on this here, it has a turning point which has a y value of what? A negative 129 over 8. If its turning point, this is U-shaped quadratic, is negative, its y value is negative, that means it must have crossed the x-axis twice, and that means it must have two real roots. Okay, so you can basically just say that because its minimum point is below the x-axis, for that to have happened, it must have crossed the x-axis twice. And you would have had to explain it that way if they said hence explain, you know. You probably, if they did say hence explain, you wouldn't actually have been allowed to go off and use the discriminant because they wanted you to speak about why the minimum point tells you that it has to have two roots because that minimum point is below the x-axis. But they weren't that mean here. They just said explain it. So you could absolutely go and show b squared minus 4ac is greater than 0 for this, which it is. I'll do it here quickly. It will be 49 minus 4 times 2 times minus 10 greater than 0. Then this is 49, and you can see this is a plus 80, isn't it? Plus 80. And sure, yeah, that's 129 is greater than 0. Anyways, it's positive, so that means there's two real roots. Okay, so that's grand. That's grand. So that's that question done. Hopefully people got some good learning from that. That was a tough one to complete the square on. The numbers are really awkward. Let me pause the video, get our next one. Right, so this is the last question on the document on our part 2 for important past paper questions on algebra that you should know. And this topic was on quadratics. But obviously, for some reason, they have a cubic here in this document on quadratics. Who knows why? But this is a very interesting question, so we're going to do this. Okay, and I put 3 stars beside it because it's very important. Okay, so pause the video, obviously, people, and see can you get a good proof, a good reason why this thing has only one real root. Okay, give that a go. Okay, so this here is a cubic. Now, what do we know about cubics? Usually a cubic will go up, turn once, turn again, and go up like this. Now, this one will have something like this, right? It will, because its coefficient in front of its highest power of x, which is x cubed, is a 1, a plus 1, it is up on the right. Okay, so this is correct. And it usually will have two turning points like this. We also know another piece of information about it. We know it will cross the y-axis at 15. So like this number here will be 15. Now, the example I've shown for you here crosses the x-axis how many times? 3 times, okay? Now, there is a scenario where this thing does not cross the x-axis three times. There is this scenario here when I move it up, like such, still crossing the 15 there, where it only crosses it once. In other words, just this tail, its back tail here, is what crosses the y-axis, okay? Or sorry, the x-axis. So then it has only one real root, that new pink dot there. Now, the way we prove this is by finding this point here. We got to find this point here to prove this. And we got to show that this point's y value is something like, say, 2, or it's something like 3. As long as it's anything above 0, if this guy's y value is above 0, we know that it misses the x-axis. And that proves that this thing only has one root. Okay? So hopefully people are okay with that. Now, we're going to find that green point. And the way we're going to find that green point is using our differential calculus. Okay? Now, if you haven't covered the calculus chapter when you're watching this video, now you probably have if you're doing past exam papers. But if you haven't, you'll learn what I'm about to do on the screen later on, and it's very straightforward stuff. Maybe another way to do this question is to actually go and, as we know on the leaving cert, we're able to actually factorize these cubics by guessing one of the roots. So you could have by all means guessed whatever this root is down here. and once you guess that root, you could then long divide it in and get the other quadratic and show that there is no more solutions. So we'll talk about that other method after we get this. Anyway, so we're going to find this green point, which is the turning point of the cubic. So let's do that. So what we do is we get f dash x. So 3x squared plus 7x plus 17. And then we set our derivative equal to 0. We find the solutions. So basically you take your first derivative and then you set it equal to 0, get the solutions for this. Maybe it'll factorize. Let's find out. Factors of 17, it's probably just 17 and 1. So look, it probably won't factorize. So I'm just going to use the minus b formula. Back in a sec. Oh, sorry, a little bit of a hiccup there. I seen it there. I got an error in my minus b formula, so I knew something was wrong. Obviously, when you multiply down by the 2, that becomes a 14x. So this might actually factorize now. This could be 3x and an x. But how would you get a 14 from it? Yeah, fair. Okay, so I'll still use my minus b formula. So back a sec. Okay, so I typed that into my calculator and it said math error. So this thing obviously has no solutions, okay? So that means if you can't set f dash x equal to 0, which is the slope of the tangent, and you can't get any solutions, that means this function never turns. It never turns around, right? It never turns. Okay, if you can't find any turning points like this, that means it never turns around. And we can check as well why I wouldn't get any solutions here. Basically I could just use b squared minus 4ac on this and check what value it gives. So b is 14, so 14 squared minus 4 times a times c. Type that into a calculator. 14 squared minus 12 by 17. And I get myself a minus 8. And sure, minus 8 is less than 0. Therefore, there are no solutions, okay? So this thing never turns around. And that'll be full marks for the examiner. Because that has no solutions, you would just write no turning points, okay? So what does that mean? So that means basically the cubic just busts through the x-axis once, never turns around to have another look, okay? It just does whatever. It just doesn't turn, okay? So we're going to have a look in this graph in Desmos to see what's actually going on with it, but we've basically shown that whatever it's doing, it never turns around, so it can only ever go through the x-axis once. Okay, that will get you the marks there. So let's have a look at it in Desmos. Okay, so this is it here, and this is what we predicted. Here it goes, it busts through the x-axis there, and it gets through at minus 3. And it never really turns, it just does a bit of a squiggle here, but they're not actual proper turning points, and then it just goes on like that forever. So the reason these aren't turning points is, if you know what f dash x is, it's the slope of the tangent. And I'm drawing tangents here, and never does this tangent equal a slope of 0. It never equals a slope of 0. When you actually do have a proper turning point like this, and you draw a tangent at the turning point, that's a horizontal line, and the slope of a horizontal line is 0. And that's why f dash x equals 0 at the turning points, because f dash x is the slope of this tangent. Great, so that would be full marks, basically what we showed there. We showed that f dash x had no solutions, so this thing had no turning points. So basically it just busts through the x-axis once, and that's it, which means it has only one real root. Now the other way students could have obviously done this was actually guess this root here. Okay, that's the way we factorize quadratics on the leaving cert. So usually what people do when you're trying to guess the roots here, you're usually going to guess like minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. It's always guessable. It's either one of them 9 here. And now, because we've obviously seen the graph, we know this is the 1, okay? So you would have done your guesses here. You know, you would have done like f of minus 3, you would have done f of 1, and that they wouldn't have worked, but this one will work. So then you go and you'd have done the guess like this. You go like this, squared, plus 17 times the minus 3, plus the 15. You work it out here, that's a negative 27. Your calculator would tell you that if you didn't know that. Then this is a plus 9 times 7, probably a plus 63. And then this here is a negative, what is it, 51? That's a negative 51. And then this is a plus 15. I'll type that into a calculator. Minus 27 plus 63 minus 51 plus 15. All of that is 0. And because that's 0, that because this is y, because y equals 0 there, that means x equals minus 3. was a root, according to the factor theorem, okay? And so what this means then is because x equals minus 3 is a root, it means x plus 3 is a factor, right? So what we can do then is we can long divide this in here and we can get a quadratic from it, okay? Now, I'm not going to do the long division here. I already told you there's a video on the YouTube channel where I show you a method called comparing coefficients, and it's much quicker than long division. So that's what I'm going to do here to get the missing quadratic. And if you're seeing something here you've never seen before and it looks interesting, go watch that video, okay? So basically you put your linear, which you know, and then you leave room for a quadratic here, and then you write your cubic on the other side, like such. You know without any work at all that this must be an x squared here, because the x by the x squared gives the x cubed. And then if this is a 15 and this is a 3, it must be a 5 at the end, because the number by the number gives the number. This is the missing thing here. You put a plus ax, and you can get that by looking at the coefficient of x. Where do x's come from here on the left? They come from the x times the 5, which gives a coefficient of 5. They come from the 3 times the ax, which gives a coefficient of plus 3a. And the coefficient of x over here is 17. You bring the 5 over, you get a 12. You divide the 12 by a 3, you get a is 4. You double check that with the coefficient of x squared. Again, if this doesn't make sense to people, go watch that cool video on the channel. It's much quicker than long division this. I basically have the answer now. The answer is x squared plus 4x plus 5, but I'm just double checking it here. Where do x squareds come from on the left here? They come from 3 times the x squared, so that's a coefficient of 3. They come from x times the ax, which gives a coefficient of a, and the coefficient of x squared on the right then equals 7. And then you move it around, a is 4. Okay, so the idea is here to if this guy had 2 other roots, we'd get them by solving this guy, and this guy is x squared plus 4x plus 5. Okay, so what we'd normally do is we'd go and we'd set him equal to 0, and we'd go off and try factorize him or use our quadratic formula. But we're not going to do that now because we know it's not going to have any roots because there's only one real root, and we can confirm that with the b squared minus 4ac. We sub in our b here. Our b is a 4, so that's a 16 minus 4 bracket a, which is 1, times 5 times c, which is 5. You get 16 minus 20, which is minus 4, and sure, minus 4 is less than 0. And then when the discriminant is less than 0, it's therefore no real roots. So that quadratic has no real roots. So the only root came from the x plus 3, and that was when x is equal to minus 3. Okay, really interesting question for people. So that's the way you'd solve that problem if you don't know differentiation and what f dash x is. You guess the root of x equals minus 3. Then you get the factor x plus 3, and you long divide it in or use this new method here, comparing coefficients, to get the other quadratic. And then you try and factorize that, see it gives math error, and then you go and you use the discriminant to show that the discriminant's less than 0, which means there's no more roots. There's no real roots from this quadratic, so the only root is this. Okay, hopefully people enjoyed this video. There was definitely a lot of learning here. You learned quite a good bit of algebra stuff and a lot of varied stuff, so if you enjoyed the video, be sure to like and leave a nice comment, and of course subscribe for more content. Okay, thanks for watching. Hope you enjoyed it. Okay, hello, welcome back for part 3 of important algebra questions, past paper questions you should know. So we've got another document here to do with algebra inequalities. So that's what they call it when you've got these greater than or less than or equal to symbols, okay? They call it algebra inequalities. So I have another document here. It's about 20 pages long. It's not very long. And I put red stars beside important questions you're meant to know. So we'll get straight into it. And yeah, obviously be pausing the video and giving them a go before I do them, because you'll get the most out of it that way, you know. So pretty important type of question here we have. We have a modulus sign on one side, and we have an inequality here. So when you have an inequality and a modulus sign, you absolutely want to be squaring both sides because it's too risky to do this any other way. You know, particularly if like there was like another like modulus over here, it gets a bit crazy. Trying to think through what to do. So yeah, just square both sides. It always works. Okay, so let's do that. So when you square both sides, what it looks like is x minus 3 squared less than or equal to, and you can write 12 squared here. Just a little thing on why we're allowed to square both sides. This thing is positive because it's inside a module. Like when you modulus a number, you're guaranteed to get a positive number. And so the idea is you're basically multiplying this side by another modulus x minus 3. So you just multiplied it by another positive number, and that's how it becomes this. And so that's why you haven't multiplied it like by a negative number or something, you know. And then if you did, like you wouldn't know which way this thing would have to point. Hopefully that makes sense, people. Anyways, if it does it really matter? All you need to know is that you move from here into here. Okay. Right, we square it out. X squared minus 6x plus a 9 is less than or equal to 144. Bring it all to one side. X squared minus 6x. You take, you go 9 minus 144. You get negative 135. Now, usually these things do factorize fairly well, okay? The question's hard enough without them like giving you a nasty quadratic that doesn't factorize. So you usually do spend a second trying to factorize it. Like I just made a random guess dividing this by 15 and it worked. So 15 went into it, and that leaves it went into it 9 times. So they make a 6, so I just need to work out probably a minus here and a plus here would do it. Now, your answers aren't 15 and 9. What you do is you kind of just write them up here for a second. They're not your answers. Okay. What you got to do here when you've got an inequality is you've got to draw a number line. You got to put 2 dots in on that number line, and whoever occurs first, let me move that over because that's not easy to see. Whoever occurs first on the number line, that will be a minus 9. That's the most left value, and then a 15 occurs later on a number line. Okay, so that's how you know where to put where. This is a U-shaped, this thing here that we solved. This is a U-shaped quadratic, and we fit a U through this. If it wasn't a U-shaped, say this was an N-shaped, we wouldn't have tried to factorize it yet. We would have just multiplied everything by minus 1 and changed this guy's direction. Okay, you'd be stupid to be working with an N-shaped quadratic and then trying to factorize it. You're better, first of all, make it a U-shaped one by multiplying everything by minus 1, you know? Anyways, so we fit the U-shaped through this because it is U-shaped. And then this is the big thing. The quadratic is what to 0? It is less than or equal to 0. Less than. So that means we shade in the part of the quadratic that is below the number line, okay? And then we just describe that pink region. That region is when x is less than 15. That's a 15. Less than 15. And it's greater than minus 9. And if this has a less than or equal to in it, you include an equal to thing here as well. And that's the answer to this question. That's how it goes down, okay? So hopefully people are good with that. Hopefully you enjoyed that one. Okay, we'll do our next one. So we got this. This is, I was scrolling through the document looking for things to mark. The amount of times this type of question repeats itself, it's incredible. It feels like it comes up nearly every year in an exam. It definitely comes up every second year. It's like incredibly common. So you need to know how to do this. So pause the video, give it a go. So the big thing is you don't just multiply across by 2x minus 3. The reason you can't multiply by 2x minus 3 is because x could be, say, minus 10, and you've really multiplied across by minus 23, and then this thing would have to have changed sign. Do you get me? Or this thing, x could have been 6, and then this is a 9 on the bottom, and then you've multiplied across by a plus 9, which would be fine. So you can't multiply across by this because you don't know if it's positive or negative, so you don't know what to do with this. So that's why you need a new technique here. Just on this here, don't be too worried about this. This sort of means nothing. It's not part of the question. They're just telling you don't put 1.5 in for x because then you'd get a 0 on the bottom, and you can't have a 0 on the bottom because the whole thing blows up. Okay, so what you do here is you multiply by the square of the thing on the bottom. Okay, so this will be the longhand workings for the examiner. So greater than or equal to 5. So you multiply both sides by the bottom thing squared. That would be, the examiner would be really happy with that. Now the reason we do that is because if you have a squared number, it's guaranteed to be positive. Okay, that number inside a squared bracket, once it gets squared, it becomes positive, guaranteed, you know. So then this thing doesn't have to change sign because you've multiplied both sides by a positive number. It's fine. What's great about this then, this squared cancels with the thing on the bottom. And so then what you're really left with is 2x minus 3, a single one, multiplied by a 3x minus 1, greater than or equal to 5, and I'll square this bracket out, 4x squared minus 12x plus 9. Okay? Yeah. So then let's multiply this together. We get 6x squared minus 2x minus 9x plus 3 greater than or equal to a 20x squared. So there's loads of room to make like a small calculation error here, you know. Bring it all to one side. So I'm going to bring everyone to this side, and then I'm going to, it'll obviously make a minus 14x squared, but we'll deal with that in a second. Minus 14x squared. This comes over, oh, we've got a minus 11x here. Minus 11x. The 60x comes over, comes positive, so I'd be going plus 49x here. That's good because 14 and 49 are a factor of 7. I bring this over here, it hits the 3 and it makes a minus 42. And that's good because 42 as well is a thing of 7. So then I can divide everything by 7. I'm actually going to divide everything by minus 7. So that's going to change this guy's direction. So when I divide everything by minus 7 here, I get 2x squared minus 7x. And that goes in 6 times there. So that's a plus 6 because we're dividing by minus 7. And now we change this guy's direction because we divided both sides by a negative number. Great. So they, as I said, they usually factorize. Okay, they're not that mean that they usually don't factorize. So let's see, can we get it to work? Would 3 and 2 do the job? 6 and 1. So it doesn't look like it's going to work here, unless that's me being silly. Factors of this, would it be 3 and 2? Oh, it is, yeah, it is me being silly. So that's a 3 and 2, and they're both negative. Because that gives a plus 6, and then we get, what do we get here? We get a minus 3x and a minus 4x. Good, that's correct. Now again, our answers, we can write them off in a corner here. X equals 2. These aren't our answers, and then when you set this equal to 0, you get a solution of x equals 3 over 2. Okay, 3 over 2. So what we do, they're not our answers, so we draw a number line. 2 dots on the number line. Who occurs first? This is 1.5 and this is 2, so the 1.5 occurs first. This is a 2. This pink thing was a U-shaped quadratic, so we fit a U through this. And again, the quadratic is less than or equal to 0, so we shade in the below the number line. And we describe that region. That region is x less than 2 and greater than 3 over 2. And this had equal to signs here, so we put them in there. And that is the answer. Okay, the amount of times this question repeats, it's incredible, where you just multiply across by the square of the thing on the bottom, go through it all, factorize it, get 2 roots that are not your answer, plot them on a number line and do this trick. Great. It's an extremely repetitive type of question, that. Okay, we have another really interesting one here. It's kind of a bit of a unique question. So obviously pause it, give it a go. So this is one equation. How many unknowns? 2 unknowns. Because it has 2 unknowns and we've only one equation, you cannot find x and y from this. You can't find their values. But what you could get with a bit of trickery is you can get what x over y is equal to. You can get what the ratio is. So let's do this. We'll first of all cross multiply. So we'll cross multiply. So it's 5 times 2x plus 3y equals 4 times x plus 6y. So it's an interesting question, this. We get a 10x plus a 15y equals a 4x plus a 24y. Now we bring the x's over to this side, we get a 6x. We bring the y's over to this side, we get, I'm going to go for 9y. And then we can pretty much just divide by the 6 here and then divide by the y. So I'm sure people can put the y, they can just realize that the y can go underneath here when you divide both sides by y, and the 6 can go under here. And so it's just 9 over 6. And you know it's right because, like, what would you do if you, like, if you cross multiplied here, you'd get 6x equals 9y, you know? And so x over y is 9 over 6, which is whatever, 3 over 2, isn't it? Divide by 3, yeah, 3 over 2. Okay, very interesting question. Hopefully people got that out. And if you didn't, you learned from it there, you know? So I'll pause the video, get our next question. Okay, so this is our next question here. A very interesting one from 2024 mock. So yeah, obviously, first of all, give it a go yourselves. See, can you get past the head scratching stage and actually get something going in the solution? These are tricky. These are tricky and you need to know what to do. So the idea is you bring it all to one side. So you get a squared. Now I'm going to write it like this, 2ab plus b squared, and then write the 25 here, greater than 0. The reason is I know what this thing here is because I've squared things. You see me all the time. Like when I go x, I'll do a negative. X minus 3 squared, like you've seen me doing it where I go x, I square the first term, I multiply it together and double it, and then I get myself a minus 6x and then a plus 9. Now what I done there, okay, if this was a minus b, what I do is I square the first term, multiply it together and double it, and I square the last term, becomes a plus b squared. So you see how I knew what this thing was. This thing, I'll get my red back, it's a minus b squared. And then we have our plus 25 here, and it's greater than or equal to 0. Okay, so this is so easy now. You've basically solved the problem. You just need to know how to tell the examiner, right? You just basically say, you can spell it out in words if you want, but anything being squared is greater than 0. You know, you cannot square something and it end up being negative, okay? So therefore true, okay, if that makes sense. Anything squared is greater than 0. And then you can use your words as well. You can write letters and words on the thing here to tell the examiner this. 25 is greater than or equal to 0. That's true. So therefore, a minus b squared plus 25 is greater than or equal to 0. True. Does that make sense to people? Like this thing has to be positive because you're squaring it. The 25 is already above 0. And so then the whole thing is always going to be above 0 or equal to 0. Okay. Yeah. Hopefully that makes. Yeah. Actually, look at this here. There's actually wrong. 25 can't be equal to 0. 25 is just straight up greater than 0. Okay, that was a little bit of a thing there. So I don't know, would you get deducted a mark for that? You might. But yeah, so that's greater than 0. This thing's always greater than or equal to 0. There's actually, I think, there is a mistake in this exam. This thing actually can't ever be equal to 0. It can't. This is a mock paper, so they're actually wrong here. That can't be greater than or equal to 0. Think about it, everyone. This thing at its very minimum can have a value of 0. This thing has a value of 25. How could it ever get down to 0? Because this thing can never be negative. It can never make the 25 smaller. So that the question here is technically wrong to think that there can be a greater than or equal to symbol there. There can't be. Hopefully you can appreciate that. Hopefully everyone's good with that. Okay. But yeah, that's what you get in mock papers every now and again. They have mistakes. Okay, great. Hopefully people are good with that. I'll get the next question. Okay, we have our next question here in 2022. Now we've already done one like this, but I'll do it here. It's a bit interesting. Well, it's not really interesting. We've already done one like it. So pause the video, just make sure you're able to do it, I suppose. So we bring the 10 over. X squared plus x minus 20 is less than or equal to 0. Factors of 20, probably 5 and 4 will do the job for us. 5 and 4, probably a plus 5 minus 4. So you see how simple this is really, you just get a number line. What are our two solutions here? Our solutions these aren't our answers here. They're just, we need them to plot them on the number line. The minus 5 occurs first, the 4 occurs here. This thing is a U-shaped quadratic, so we put a U through here. This thing is less than or equal to 0, so we shade the part that goes below the x-axis. And we describe that region as x being less than 4, but greater than minus 5. This thing had a equal to, less than or equal to, so then this will also. Done. Only takes a minute. Okay, I'll pause, find our next one. Yeah, I didn't actually put a star beside this one, but I'll do this one just so people can get a few reps on this kind of thing. Okay, so let me do this one as well. Obviously, pause and give it a go. See, can you get it out? Okay, so what do we got going on here? Bring it all to one side. A squared. Again, I'm going to write it like this. Plus 5b squared is greater than or equal to 0. And now this is the big trick. This is the big trick. All right, it's a big smart trick. Break the 5b squared up into a b squared and a 4b squared. Because that is what 5b squared is. It's a b squared plus a 4b squared. Now, why did I do that? Well, because I know what this thing is. I can write that thing as a minus b squared. And then I have a 4b squared here. And then that's it solved because it's just the same proof as before. Anything squared is always greater than or equal to 0. And then I have 4 times something squared, which is always greater than or equal to 0. And all these are true. So therefore this thing is true. Now you would just kind of spell out what I announced to you in words there onto your exam. But the examiner would actually buy this. This is completely fine here, okay? Right, so people, hopefully you enjoyed that there. I'll find our next question. Ah, yes, a very good one. Oh, actually, let me. What did I have from before? Oh, yeah, we're not finding solutions. Yeah, so you've always got to be a little bit careful when like these are like equal signs. You know, you'll get values for x, and then you need to sub them back in and make sure they work. But we're doing inequalities here, so I've actually got no definite values of x that I have to check are correct. I've just got ranges for x. Hopefully that makes sense. We'll see some of that anyways. I don't know whatever part it'll be where we're solving expressions like this where they've equal sign, but this document is based on inequalities. Anyways, pause the video, give this a go. So same logic, just square both sides. So your next line here is this, greater than x minus 3 squared. You should know how to square brackets out quickly. It's a very important part of higher level maths. Multiply them together, double it, yeah, plus 9, greater than x squared minus 6x plus 9, bring them all to one side. 3x squared minus 18. Ooh, the 9's cancel, so this is very interesting. So this is greater than or equal to 0. So what we're going to divide everything by here is 3 first of all. So we got x squared minus 6x is greater than 0. This thing still does factorize, it's just x minus 6. That's the way you factorize this one. And so the solutions then are x equals 0 and x equals 6, right? You can still plot this on a number line. 0 occurs first, then a 6. This is still a U-shaped quadratic, so I'll plot that in blue. Look, the quadratic is what to 0? It's greater than 0. Because we're greater than 0, we shade in the part of it that goes above the x-axis, and then we just describe this region. This region over here is when x is greater than 6, and this region over here is when x is less than 0. Okay, it's the region left of near 0. And this did not have a greater than or equal to, so these are our answers. We don't put the greater than or equal to in. And because these describe separate regions out here, you leave them separate like that. Whereas if they describe the in-between region, that's when we write them like this, okay? Hopefully that makes sense to people. Right, good stuff, good stuff. We're pushing along here. Look how common these repeat, you know, we've already done one of them. So I'll pause, get our next one. Yeah, so look, like this is easy. We've already maybe done one like this, but I'll just do another one here just for people so they can practice them. It's just interesting that the one is on the other side, you know. So you can pause the video, see can you hammer this out. So the idea is to bring this guy to one side and then to bring the one, not an equal sign, bring the one to the other and then square both sides. 2x plus 5 squared less than or equal to 1 because 1 squared is 1. Then this is 4x squared plus 20x plus 25 less than or equal to 1. Then we get 4x squared plus 20x, and then that's a plus 24 less than or equal to 0. Divide everything by 4, you get x squared plus 5x plus 6. I'm doing that very quickly, I hope I done it right. And then this is straightforward enough, probably 2 and 3. 2 and 3 sounds good. And then we write the not answers up here. And then we draw a number line. 2 dots. Who occurs first? Careful. Minus 3 occurs first on a number line. It's further left. This is a U-shaped quadratic. We draw in a U-shaped. We slow things down and think this thing is what to 0? It's less than or equal to 0. So we shade in the part below the number line. And we describe that region. It's x less than minus 2. That's a minus 2. And it's x greater than a minus 3. This had an equal to sign in on it as well, so we put them in here. And we're done. Happy days. So simple. Easy marks. Okay, I'll get the next question. Ah, yes. So a very important type of question here now. This is probably maybe one of the last major questions we're going to do on the inequality. So I've put 3 stars beside this because this is really, really, really important. Okay. So as a student, you are meant to know how to graph y equals modulus x plus 3. And you're meant to know how to graph a line like y equals 4, right? We'll go through that. So yeah, let's get stuck into this. I'm actually going to make a note because I'm thinking about doing another video later on. So there's already a graph tricks video on the YouTube channel, so I'm thinking of doing a graph tricks part 2. So I'll make a note to do this in that graph tricks thing. So it'll be 1 second. Okay, so we're back. So yeah, so we need to know how to graph these. So using your graph, write down the solutions of this. Okay, so we're asked to graph these. So let's show you how that's done. So first of all, we can graph this. This is easy. Okay, anything that's just y equals like a value like this, that is just a horizontal line. Okay, so all we do here is we draw a horizontal line through the y value of 4. So that there is the line g of x equals 4. Now, how do we draw y equals modulus x plus 3? The way you do it is you first of all draw y equals x plus 3. Right, what is this? This is a line with the slope of 1, which means it goes up at 45 degrees when everything is properly graduated. This is, so like 2 blocks is 1, 2 blocks is 1. And it goes through y when it's, y equals mx plus c. Its c is 3, so it intercepts y here at 3. Right, so everyone that, like the junior certs can do this. They can basically and if you didn't know how to do this, I'll show you another interesting way how to plot a line like this. You just need 2 points to plot it. We already have one of the points. So you can get your y-intercept here by setting x equal to 0. And when you set x equal to 0, y equals 3. So that gives us a point 0, 3. And that's what we marked there. That's the c information from y equals mx plus c, right? You can get the x-intercept. How do you get the x-intercept? By setting y to 0. When you put y in as 0 here, you get 0 equals x plus 3. So then x equals minus 3 when you bring it over. So then that's another point, minus 3, 0. So then you can plot this here for yourself. That's if you're not able to draw a line with the slope of 1. But you should, it just goes up at 45. Basically, you just make your line have a rise and run that's equal, Right, so first of all, that's what you graph there. You graph y equals x plus 3. Now, we got to work in the modulus business, right? So the whole idea is when you get the modulus of a number, it cannot give a negative. This thing can never take on a negative y value, okay? Because you've just modulus. The modulus of something is always positive at the end, So basically, this part of the curve down here does not exist. This does not exist down here. And anytime it wanted to report, say, a value of minus 3, you can clearly see it wants to have a y value of minus 3 when x is minus 6. Instead of giving a y value of minus 3, it's going to give a y value of plus 3. And it's the same for every one of these values, these negative values. They'll all occur up here. Okay? All of this here will occur up here. So what actually happens when you're sketching this modulus, right? All you need is like 1 point. Basically, that 3 point there is pretty good. Let me get rid of that. So this 3 point is pretty good. And you just draw a V. So the graph of these guys, right, are V's. So the modulus x plus 3 is that purple V there. And let me rub out the original. We don't need that anymore. So that there is f of x. That is how you graph a modulus function. You're aiming for a V, but you draw the non-V version first and then don't let it go below the x-axis. Okay, hopefully people benefited from that. There's surely a few that definitely did, and obviously draw up a few flashcards on that, right? So using your graph in part 2, write down the solutions for when f of x is lower than g of x, okay? So they're basically asking us to, when is this true, right? When is modulus x plus 3 less than 4? Right, so first of all, this is, let me color code this. They're asking when is the purple graph that I drew less than or equal to the green graph, okay? So you can pause the video and have a go at that. When is the purple lower than the green graph? So it's all in this region here, isn't it? It's all around here. Now they want you to describe this in terms of x values. So this sort of begins from minus 7 and it goes on until 1 here, doesn't it? So write down the set of solutions. This is true when x is below 1 and when it's above minus 7. In other words, as I said, that region in there. So it's above minus 7. So that is the answer from the graph. That came from the graph, didn't it? X is below 1 and it's greater than minus 7. And you see how this had a less than or equal to, so you put the equal to's here as well, okay? Great. So obviously the part 3, you could nearly guess what the part 3 is going to get us to do. It's going to get us to solve the red thing here using our algebra and get the exact same solution that x is below 1 but greater than minus 7. Okay, so let's scroll down to that. Verify your answer algebraically. Okay, and so let's do that. So it was modulus x minus 3, wasn't it? And we want it to be less than or equal to 4. Let me confirm that. Yep. Okay, so we've already done loads of these, so you just square both sides. So you get x minus 3 squared is less than or equal to 16. Then you get x squared minus 6x plus 9 is less than or equal to 16. Bring the 16 over. You'll get x squared minus 6x minus 7 is less than or equal to 0. You factorize this, it'll probably be a minus 7 and a plus 1. Okay, and then you plot the solutions here. Or sorry, you just write the solutions here that aren't your answers. So x equals 7, x equals minus 1. You whip out the number line. You draw the minus 1 first because that occurs furthest left. You draw the 7. This is a u. You draw a u through this. What is it to 0? It is less than 0, so you shade in the part that goes below the number line. And so the answers here are x is less than 7, but greater, less than or equal to, less than minus 1. Okay. So I hope that's what I had up there a second ago from the graph. I can rewind it back anyways and see if that was the case. But what I'm getting anyways from the algebra here is that these are such. And remember, this has the equal to here, so you just put that here as well. And that's a minus 1. So yeah, okay, that's all good there. So hopefully people are good with that. And I'll obviously just go back through my Zoom things here and make sure that that's what I got above there. So I'll pause the video and we'll pick up at our next question, okay? Yeah, so I rewinded that back there and I noticed that our previous answer from the graph was we had like a minus 7 here and a 1. And I was looking through them and I found out why that was. So I actually took this down wrong here. You see, this is like an x plus 3 and I was doing it with an x minus 3. So this should be easy enough fix. So we just put a plus here. We put a plus here. This will be a plus. Then you bring that over, the 16 over. It'll still be a minus 7 there, but then this is a plus 6. The factors then would be a plus 7 and a minus 1. So then this gives a negative 7 here and then a plus 1 there. So then the furthest one over here will be the minus 7. And the furthest one over here will be the plus 1. And then it's the same region, it's between the 1 and the minus 7. So then this goes between 1. And then this goes between minus 7. Okay, so you see how easy that was to get. Like, you know, you wouldn't lose that many marks there because everything is so well laid out, you know. But it still is a big blunder there if you take down something like this wrong. You take down it as x minus 3 instead of x plus 3. But this was a nice question. You couldn't go wrong because you had already gotten that it was between minus 1, minus 7 and 1 from your graph. And so when you were getting something like minus 1 to 7 here, you knew something was wrong. Okay. So yeah, so hopefully people enjoyed that there. And yeah, enjoyed how you can fix a problem if you make it a little mistake too. That's interesting. Okay, cool. I'll clear this away, get our next problem. Yeah, so I have another one of these marked out here. So I'm sure people were a bit afraid, you know, they don't like these. But hopefully you're kind of you've seen me do solve 2 of them anyways, so you're kind of getting a feeling for how they work. So obviously this is from 2017. So pause the video, give it a go, see can you get something rolling. Okay, so the idea is here, the best thing you could do is bring the b over, put it greater than or equal to root 2ab, right? Square both sides. So then this will be a minus b squared. Don't square it out. Then this is greater than or equal to 4. You got to square the 2 as well. And then this becomes ab, right? So what will we do now? We will bring this over here. So yeah, so it's kind of working out what to do here. So I'm going to square this out and see where it goes. So you kind of, you know, you make it up as you go along, you know, as in like, as you can't always, like I'm looking at this now, I don't immediately know what's going to solve this, but you'll kind of move through it and work it out as you go along, you know. So let's, what could we do here? Let's bring this over the other side. I've squared this out correctly, haven't I? So this is all good. Yeah. So I'll bring this over, and then it'll give them negative 6ab, and then plus b squared, greater than or equal to 0. So what could we do here? Let me think. What's a good solution here? Tempted to like add a squared b squareds to make something work here. Let me think. There's definitely more than one way to do this, so I'll pause this and have a think about this. Oh yeah, so I had to pause that there and I seen that I actually didn't bring the b over correctly. So let's do this. This might change the way things look. So when you bring the b over properly, it becomes a plus b. Then this becomes a plus b squared. Yeah. And then we square both sides correctly there. Yeah. So then this is a plus. This is a 4ab. You bring it over. So this is good now because when that comes over, you have a plus 4 coming over to become minus 4. It'll hit your plus 2 here and you'll get a minus 2ab. And sure, that's great because then that's a minus b squared. And sure, that's always greater than 0, isn't it? Because you can just say for the examiner, anything squared is greater than 0. Therefore, it's true. And they'll leave you alone there. You just got to put it into words. If anything squared is greater than 0, then a minus b squared is greater than 0. So this is true. Okay, cool. Right, yeah, so there you go. So you see now I was kind of like, that's nice that you see in a real problem there, I'm getting like a 6. I'm like, what's going on? And then I kind of slow down and I say, I didn't bring the b across right, that kind of thing. So yeah, hopefully people enjoyed that one. That's a nice, unique version of what we've been doing so far. Okay, so I'll pause this, see if there's anything left. Yeah, there's actually another one of these here in 2014. So let's get this set up. You've seen a good few of these now, so you should be able to knock them out. So give that a go. Pause the video. Okay, so we'll bring the 2ab over, obviously. So then we got our a squared. We'll write it like this. Yeah, this is very similar to what we had near enough the start of the video, where it's good to put these together because then these are clearly a minus b squared. And then this is just a number here. I think we had something like this with a 25. So they've basically done the same thing as they've done before with the mock exam, because this thing can never equal 0. Because the minimum value this could ever have is 0. And then you have 0 plus 16. So how could this ever equal 0? So this is like another mock mistake here. So there's the silly mocks. Um, so yeah, but anyways, we'll assume that that's not there because, technically it can't be there. So what we would say for the examiner here is anything squared is greater than or equal to 0, and the number 16 itself is always greater than 0. So therefore, something squared plus 16 is always greater than 0. So therefore, that's true. And therefore, this thing must be true because of this thing. Okay, so you can put that into words. Anything squared, it cannot ever be negative. 16 is always above 0. The minimum this could have is 0, so that's why we write greater than or equal to 0. And then this thing must be greater than 0. Okay, great. Hopefully people are happy with that. So I'll pause. I'll see if we have another one. Yeah, so we have a good one here from a 2014 sample paper. So that's the one we just done above. So this is tying in with their kind of graphing these, and we know they're like V-shaped things. And so you see it's very similar to the question we already solved, where they were nice this year, though. They plotted it for us. And yeah, so basically this graph here is y equals 2, the g of x1. So that's a horizontal line that goes through 2. This is y equals x minus 3 modulus. So the way they plotted that is they drew the line with a slope of 1 and it cut the y-axis down here at minus 3 because its intercept at y equals x minus 3. Its intercept is c minus 3 down there. And so instead of crossing the y-axis at minus 3, it'll cross it up here at a plus 3. Okay, so that there is 2 and that there is 3 up there. So you know a ton about the graph already. Anything else to say there? No, so they just want us to find these coordinates anyways. So where would this cross the x-axis here? So you take the original function up here, and when you cross the x-axis, you set y equal to 0. When y is 0 here, you get 0 equals x minus 3. Bring the 3 over, that's x equals 3. So this point down here is 3, 0. Okay. What do we know about b? So finding b is there's a bit of interesting that it's sort of what is b's x value is the bit of the pickle, okay? So how could we get that? We'd sort of get that from a bit of algebra. So this here in purple is one graph, and then this here in green is another graph. They are two functions. How do we find the point of intersection of two functions, which would give us a and b? You sort of set the two functions, it's simultaneous equations, so you basically set their y values equal to one another, okay? So hopefully that makes sense to people. So basically, this guy's y value equal to this guy's y value, so we basically go x minus 3 modulus equals 2. We square both sides. Now notice this is an equal sign, this isn't an inequality. So then we get, we just got to show it for the examiner first, x minus 3 squared equals 4. And then we write it out, x squared minus 6x plus 9 equals 4. So then bring the 4 over, x squared minus 6x plus a 5 equals 0. Factorize it, so you get minus 5 minus 1 equals 0. And so you get two solutions, x equals 5 and x equals 1. Now you've got to be very, very, very careful here, right? When you get answers from squaring these, you always got to put them back in to see if they work. So when you put the 5 back in here, and you want to show this for the examiner, you go like 5 minus 3 modulus equals 2. And what are we seeing here? That's modulus 2, which is 2, so that's good. This root works. And you put the 1 back in there, so you get 1 minus 3 equals 2. And then that gives modulus minus 2, and that's true. So both of them work. So where these guys intersect is they intersect at an x value of 1 and at an x value of 5 there. And we know we don't need to sub back in to get their y values. We already know they have a y value of 2. Okay, but you could, if you wanted, you could put 5 back in here, and you go like 5 minus 3 modulus, and you'll see that it gives a 2. So basically the coordinates of these are 5, 2, and 1, 2. Okay, so A is 1, 2, B is 5, 2, and D is where this guy crosses the y-axis, and we said that that's at 0, 3. Okay, so that was a really good question there from 2014. So then it says, hence or otherwise, solve this inequality. Now what we could do is we could just, this is basically saying, I'll color code it again for people. This is saying when is the green, see this then is the purple. When is the purple less than, in other words, lower than the green function, okay? And that's in this region here. And that occurs when x is less than 5 and then greater than 1. And notice it doesn't have an equal to symbol in here, so you leave it like that. So it's x less than 5, then greater than 1, and that will be the answer there. So that will be using the hence, okay? And the otherwise will be using the algebra. So we'll get the same answer. I'll remember it now. It's between 1 and 5, okay? So we'll use the algebra to get the same answer. So we square both sides. So we go x minus 3 squared is less than 4. We got x squared minus 6x plus 9 is less than 4. Bring the 4 over. I'll put it up here. X squared minus 6x plus 5 is less than 0. Factorize it. We remember this from before. Minus 5 minus 1. So the two solutions here are x equals 5. We write them from the corner because they're not actually our answers. Then we get a number line. We put 2 dots in on the number line. The furthest left one here would be the number 1. Then we'd have a 5. This is a U-shaped quadratic. We put a U through this. And then it's what to 0? It's, where's my 0? Oh, it's up here, sorry. It's what to 0? It's less than 0, so we shade in the part that goes below the number line. And so the solutions are less than 5, less than 1. Okay, and that's what we got from before. Okay, so that's the or otherwise, that's the using algebra, and then the hence was using the graph. Okay, hopefully people are pretty good on that. You've seen a few reps of that, so you can definitely make some flashcards on these V modulus functions, and yeah, you've seen some interesting stuff there. So I think there's just one more question down here. I spotted it. I put a mark beside it. So it's this one. Now we've already done stuff like this, but I'll do it because it has like a 5/2 here. So I just have I say set up here. Okay, so I'll start this and you can finish it for homework. So this is all the way back in 2012. So we finished the video here pretty much. So what I do here is I would we've obviously got to multiply across by x minus 3 squared. So we'll do that first. So you can go 2x minus 5 over x minus 3 less than or equal to 5/2. Just show it for the examiner like this. So you go bracket x minus 3 squared, and then you go x minus 3 squared here. So then what you get here is this squared cancels with the thing on the bottom. And then what you would do then in the next move is you'd multiply across by 2 as well. So then you have 2 x minus, there's not a squared there anymore. Then it's a 2x minus 5. And then it's a less than or equal to, and there's just a 5 here now. And that's it. Yeah, that's it perfectly set up now. So this is just going to be like what we done, I think, in one of our very first questions where, you're just squaring stuff out. You get a quadratic here, bring it all to one side. You'll get just the one quadratic. You'll factorize it. You'll get two roots that aren't your answers. You'll put two dots. It should be a U, and then you'll kind of shade above or below depending on how it lined up, okay? Great. So everyone's pretty well prepared for what could come up on algebra inequalities. So hope you enjoyed this video and you got some good learning from it. And if you did, be sure to leave a nice comment saying it helped, and of course subscribe. Okay, thanks for watching. Okay, hello everyone, welcome back. So this is part 4 of algebra questions, important past paper questions you should know on the topic of algebra. So the name of this part here is called expressions and factorizing. So I'm sure this will have a bit of a mixture of some interesting stuff that we have to do. So you can see some binomial expansion. And of course I've gone through the document, it's about 30 pages long, and I've marked out with red stars the important questions we're meant to know. Right, so we'll get straight into it. Let me get it set up here. So obviously when I have them set up here, be sure to pause the video and give them a go yourselves, because that's where you'll get your most out of the videos, Right, so this is a pretty big thing. A lot of students, they look at these power 7 and they don't know like Pascal's triangle. So they don't know what this is here, and they don't know how important this thing is. So this is the row you'd use if you were cubing something. So I recommend you'll be able to pick a bit up of what I'm doing in the video on this, but absolutely you're going to want to go and have a look at this in the textbook, okay, to be perfectly familiar with this. So this is when you're cubing something, this row. This is when you're fourthing something, and then this is what you're fifthing. So obviously we're to the power 7 here, so we don't want to get all the terms, okay? So where does this triangle come from? And you can see the pattern there, like you add the two numbers that you have above you. So the 6 came from the 3 and the 3s, the 10 comes from the 4 and the 6s. Okay, so in your formula tables, you'll have the binomial expansion formula, and it goes, let me get it up here. Yeah, so on page 20 in your formula tables, you see this binomial expansion. Binomial, just so you understand, the word bi means two, nomial means terms. So you see there's two terms, x plus y to the power of n. Okay, so this is the expansion for when you have two terms to the power of something. So the big E means sum, so that's why there's loads of pluses here. Plus, 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 plus. And then the n choose or, that n choose or thing is what generates the triangle's coefficients that you seen there a second ago. And it's pretty straightforward. So this is the general term here. We'll be using this in the question. We'll be using this. And as you can see here, it's like the x's power reduces and the y's power increases as you move along until eventually the x disappears and you're just left with y to the n. Again, if this is super confusing, I recommend you'll be able to pick up some of what I'm doing with this in the video, but at the same time you kind of want to sit down with it in your textbook, But if you're watching past paper questions, it's kind of assumed you've already sat down with it a bit, So yeah, so basically what we're going to write here, it's 2x plus 1 over x to the power 7, and that, according to this here, let me get it up here, is the sum. So I'm just going to write it here so I have it, and then we'll go back to the nice neat white paper in a second. So n is 7. It starts out with r equals 0, so then it's 7 choose 0, and then x to the n minus r, n is 7. So again, this looks super messy. Just give it a second. It'll be not messy in a second. And then that's y. Okay, so I've left room for x and y. So let's go back to where it's not messy. Okay, people can relax now. So in for x, you put the first term here, 2x, and in for y, you put 1 over x, okay? And this then is to the or. Let me go back and look at it here. To the or, yes. Okay, so yeah. So that there is what you'd need. So this here is what this looks like in general. In for that formula you had the tables book, I just put n was the 7, or equals 0 is where it begins, and This should be not a 0. This should be a 7 choose or. Yeah. Okay, so I think I have that in now perfectly. Yeah, or. Okay, so as you said, it looks a bit messy there, but it'll make a ton of sense now for what I'm doing. So we're asking to find the coefficient of the term that has 1 over x to the 3. So it's a little tricky. So what we got to do here is study this for a second, okay? Once you see one or two of these questions done, you'll be a little bit more at peace with them, okay? So the idea is here, this is just a big sum thing. We'll talk about this in a second. Or equals 0. 7 choose or. 7 choose or. Line through that. So the first thing I'm going to do here is I'm going to rewrite x as x to the minus 1, right? To the or. Now the rule of indices here is that these powers multiply, so you can go confirm that if you need to. So I'm going to do that here in one move. So basically this now is going to be to the power of minus or. Right, and another really slick move you've got to be comfortable with is this. So it's like a to the b, if they were cubed, they could be written as a cubed, b cubed. So each of them can individually get the power. So I'm going to do that to get the 2 out of here. So I'm going to get the 2 out of here by doing this. So basically I'm going to say it's just the x to the power of 7 minus or, and then there's also going to be a 2 here that's also to the power of 7 minus or, okay? So now the 2 has been freed from the x. Now the idea is now both of these here are to the same base x, right? So because they're the same base, the rule of indices here is the powers can add. So to be fair, yeah, this is a bit of a complicated question if you'd never seen one of these done before. They are pretty nasty, and it's a shame the video has to start off with such a complicated question. But that's the way things go sometimes. But anyways, you're here anyways to learn the questions you're meant to know, and you're meant to know this kind of one. So this has the same base here, so the powers add. So 7 or, 7 minus or, and then minus another or, so that's 7 minus 2 or. Now, we're interested in what the coefficient is of x, 1 over x to the 3. Now, we should know 1 over x to the 3 is really x to the minus 3, right? So that's a hint for us now. We can work out what or should be, so that this, which produces the x, produces an x to the minus 3. So we can work out what or should be to get a minus 3 in the power. So you go 7 minus 2 or equals minus 3. Bring the 3 over, bring the 2 or over. 10 equals 2 or, and so or should be 5. And now this is going to get our coefficient for us, because we basically solved the problem. So let's see, can I just move this up a touch? And then I'll be able to fit it in underneath. So then when we let the or be 5, so we're not summing this, we just want a specific term. We want the term a specific term. So what we'll do here, okay, we'll just kind of put a line here to just kind of say we're not really continuing this up here. So we're just really interested in what 7 choose 5 is, and then what 2 to the power of 7 minus 5 is, because we know or, and then x to the power of 7 minus 10, because or is the thing. So that gets you your x cubed, 1 over x cubed term. So then this here then equals, you can type this into your calculator, 7 choose 5, and then that's really 2 squared, if that makes sense to people. 7 minus 5 is a 2 in the power, 2 squared. So I'm getting that works out as 84 x to the minus 3. So then this is the term that has the 1 over x cubed, you know? And so its coefficient, as you can see there, is 84. Very tricky question. So what could I do that could kind of help people here? So that was really tough, the fact that the 2 had to came out there, so that hopefully people are okay with the thing in pink up there. But now you've seen this, the idea is that you'll be able to write, say, the 1 over x thing as x to the minus something, and then its power multiplies out like it did there, gave the minus or, and then they'll have the same basis, so you'll be able to combine their powers, and then you set that equal to whatever power you want. So we wanted a minus 3 here because it was 1 over x cubed. But yeah, you'll see more of these anyways in the video. You get a bit of practice if that one didn't work out for you. Okay, so I'll clear that away. The answer there was 84. 84. Okay, I'll clear this away. Okay, our next question is literally just below this. This was in the same 2025 mock, so they really turned the knife on people here if they didn't know their binomial expansion. So they even threw up another pretty tough question, because that was pretty tough as it is, you know. But that stuff above can come up, so they have a kind of a unique version of it here where there's an n. So we'll get this set up here, and then obviously have a go at it, you know, have a go, pause the video there, have a go at it. So what are they telling us? In the binomial expansion of this, in ascending powers of x, okay, that just means it goes in the normal direction. Like as in x goes up in powers when you're in ascending powers of x. Yeah, yeah, that's interesting. Um, Usually oh yeah, because that makes sense because x is the second term here. So basically what's happening here, usually you'd have like x to the 1, say cubed, right? And I'll just do this one out by hand. What would normally happen here is this will be this row from the triangle, okay? 1, 2, 1, 1, 1, 1. So when you're cubing something, you use this row. So normally what would happen is you take the coefficient from here, you take the first term, the x, and you cube it. You take the second term and it starts off to the power of 0. Then you plus, this is what that big E thing is about. Then you plus, you take your coefficient from here, bracket. You then take the first term, which was the x, and now it was originally 2, and now it goes down a power, and then the other one then goes up a power. And then you take your coefficient from here, x to the 1 now. The 1 then is being squared, and then you take your coefficient from up here, and this is the last term. The x is now to the 0, and then the 1 is to the power of 3. Okay, so can you see here it started out x cubed, then x squared. So x is descending in power, and that's because x was the first term. But think about it visually. If this was 1 plus x, then x will be ascending in power. Okay, and that's what they have here. They have x in it at the second thing. So hopefully that explains the ascending thing to people. It's nothing to worry about basically in the way they have set this set up. Okay, in ascending, the coefficient of x squared is this. Find n. Given that n is a positive integer, find n. Okay, so it's tough. This is tough. What we could probably do is we could write out some of the terms here, could we? Let's see how we even go about this. How do we get the x squared term? Yeah, so when we have the binomial expansion there, let me write it up again. So it's the sum from r equals 0, so can I remember it, of something like n choose r, and it's, I think, the first term. So it's a shame it's called x. We're going to call it a here. A meaning like the first. So we'll write this here because our x is taken up in the question. So this is x plus b to the n is equal to this. So it's a, I think, to the n minus r, and then it's the b to the r. Okay, this sounds right. Yeah, this looks good. Right, so the very first term starts out when r is equal to 0, right? So the very first term here, if we just start expanding this out, would be n choose 0. Our a here is a 1. So then it's n minus 0. Then our b in this question is an x over n. And that starts out as a 0 because r is 0, okay? So then we have, this is what this big E thing is about there. That's the sum symbol. So then it goes n choose 1, right? It's 1 now, its power will reduce as you can see here, and that's covered by r now. R is 1, so it's like n minus 1 here. So the power went down by 1, where it was originally n, and then this power goes up by 1. So then it's x over n to the 1. And then we do the next term. So this is the term we're really interested in now because this will have the x squared in it. So the 1 goes down by a power, so it goes n minus 2, because r is 2 now, according to this formula up here. And then we have x over n squared. Right, given that the coefficient of this here, so what we have here, we're really just got to isolate this term here. Obviously what I'll go with dot dot dot, that just keeps adding on there, So we'll go up and we'll inspect this. This is a very tough question they came up with here in the mock. Now, it doesn't matter what this is here. This term 1 to the power of something, 1 to the power of anything is always 1. It just, that doesn't matter. So that basically is just 1. So you would write n choose 2 here times 1. It's just 1. And then this term here is x squared over n squared, okay? If you have a squared out there, both terms get squared. And then basically they're telling us that the coefficient of x squared here is 7 over 16. So what's the coefficient of x squared here? I could write it like this here. This is really a 7x squared over 16. So the parts that we'll set equal to one another, let me get rid of this arrow because it's in the way. The parts that we'll set equal to one another, as I said, this is a very tough question, very tough question. 7 over 16 is equal to the n choose 2 part, and then multiplied by the 1 over n squared part, okay? All of that is multiplying and the 1 obviously doesn't matter, is multiplying the n squared. So what I'm going to do is I'm going to clear this away, and I've isolated the problem now. So once we can solve this thing in blue here, we have our answer. Now they're testing us on another thing here. This is a really, really tough question. So basically students are meant to know how combinations work. So combinations work like this. You can do them out by hand. 7 choose 3 can be done by hand. You don't need your calculator for it. What this is basically just 7 by 6 by 5 over 3 by 2 by 1, okay? And type that into your calculator by hand, and then type 7 choose 3 into your calculator by hand. You'll see it's the same thing. Do another one of that. Say you had 10 choose 2. This is important for the example we're doing here. This is just 10 by 9. So you just do two terms. You're basically doing the factorial where you multiply down from 10 and then you divide by 2 by 1. Okay, so that'll work out as 45, and then you type that in, it'll be 45 as well. Okay, so let me clear that away. So then that's a hint at how we do n choose 2 by hand, okay, because you can't type it into a calculator. So I'll do it out by hand here, keep this side as it is. So n choose 2 by hand is n times 1 below it, which is n minus 1, you're reducing it, and you stop, and you go over 2 by 1, and then don't forget your 1 over n squared that's here, okay? So what's nice about this here is one of these ends cancel like that, and so you have a 2 here which you could send up there, so you really get a 14. Well, I could probably cancel the 2 actually with the 16 here, so you get 7 over 8. You multiply across by the 2, it works out as 14 over 16, which is 7 over 8. And then what do we have here? We have an equals an n minus 1 on top, and then it's just an n on the bottom. So what we'll do here is multiply across. Let me see if I've done that all good. Yeah, that seems fair to me. So then we'll multiply across, so we get 7n equals 8n minus 8. And then bring this over here, so I'm seeing n is 8. N is 8, okay? So yeah, we just wanted to find the value of n, so I'm pretty happy with that, okay? Very tough question, very tough question. And obviously make a flashcard there on if you didn't know how to do n choose 2 by hand, and then also how you can do like 7 choose 3 by hand, you know. So you learned a lot there, hopefully. And I know it was tough, but hopefully you learned a lot from that. Okay, let me pause this and clear it away. Okay, so our next question comes from 2025 paper 1. So I think is it just, yeah, it's its own part here. So obviously pause the video, give this a go, see if you can apply some of the stuff you've learned so far. Write down in descending powers of p. Yeah, p's power would descend because it's the first term. The first 3 terms of this binomial expansion. Okay, so yeah, so that's basically just this again, where we have 2p, this is the formula from the tables book, 2p to the 7 equals the sum from r equals 0 up to n is 7, of 7 choose or, n choose or, and then the first term is 2p, and that's always to the n minus r, and then the second term is a 3, and then that's to an or. So it wants the first 3 terms of this. So the very first term starts out where r is 0, so it's 7 choose 0, 2p to the, oh, I shouldn't have wrote n there, and we know n is 7. So then it's 7 minus 0, because r is 0, and then it's 3 to the 0, because r is 0, and then we go to plus, that's what the big E is about. That's capital sigma. I call it big E because that's what people see it as. 7 or is 1 now for this term, so we got 2p to the 7 minus or. I'll write it as 7 minus 1, but it's obviously 6, you know. 3 to the 1 because or is 1, and then this is the last term they want us to write because they just wanted the first 3 terms. Yeah. So 7 choose 2. 2p to the 7 minus 2, which is 5, and then 3 to the 2. Okay. Obviously for the examiner here, you want to maybe multiply out some of this stuff. So I wouldn't leave that like that, as that was my state exam now. You should know 7 choose 0 is 1, 3 choose 3 to the power 0 is 1, and 2 to the 7. 2 to the 7 is 128. So I'd be like writing the first term there is 128 p7, and then I'd do the rest for these here. So 7 choose 1 is 7, you should know that. But your calculator will tell you if you didn't know. And then multiply by 2 to the power of 6. So this next term is plus 1, 3, 4, 4, p to the 6. See, the p power is descending. And then plus, what's 7 choose 2 times 2 to the power of 5 multiplied by 9, which is 3 squared. So I'm getting like 6048 p to the 5. So that was a fair question, that. That was a fair question. So it's basically just, practicing this binomial expansion formula, okay? Okay, great. I'll clear that away. We'll do our next problem. So you'll be happy here now. If you kind of give me questions, they're fairly easy to kind of calm you down after the binomial expansion stuff. So pause the video, make sure you can knock these out. Bit of a confidence booster for you if you can get them out. So this is an interesting one. This is basically the difference of two squares once you factor out the 5. So you have to realize you take out the 5 first. Okay, and then this is the difference of two squares. We've got to know the difference of two squares pops up all the time. So that's x minus 3 and that's x plus 3, okay? And if you don't believe me, just multiply those two brackets together and they become this, okay? Because the rule is if you have something like this squared, take away something like this squared, that becomes a minus b times a plus b, okay? A plus b. And that's what I've done there. So that's that fully factorized. And now this is an interesting one. This is like a junior cert problem, but it's still pretty tough. Sometimes they like mess with people here, and like what you're meant to do is like put this one with this one and then this one with this one. It's very rarely, if it's a hard question, it's just this one and this one, okay? So I'm gonna predict that that's what they've done here, and I'm gonna just try and factor something out of those two. So what comes out of those two? Probably a 3y, and you take a 3y out of this, you're left with a 2x. You take a 3y out of this, you're left with a plus 7. Okay, what can I take out of this? I want to try take a 2x and a 7 out of this as well. So let's take a minus, let's take a minus 4 out of this and see what happens. So I'm going to say minus 4. If you take a minus 4 out of this, it leaves a 2x. And then you take a minus 4 out of that, leaves a plus 7. So I done it correctly. So I guessed what was going to happen. As I said, in the hard junior cert questions, they always make people not just think it's the first two to take out of. They'll usually be like the first and last and jumble it around, okay? I seen it coming. So the idea is these now are the same, which is what you aim for. And when they're the same, you can write it like this. And a lot of people don't know why you can kind of just write it like this afterwards. Okay, people are like, why can you do this? People just know that once this and this are the same, you can write it like this. But the reason you can do that, okay, this is mind-blowing for people who didn't know this. Say you had x plus 3 multiplying by, say, I'll keep away from the y's. Let's say we had x minus 5, right? We all know that the way we multiply this out in our head now is we go x by x, x by minus 5, then we go 3 by x, and then 3 by minus 5. But when we're really small in first year, the way we would have done this is we would have put x multiplying by the x minus 5, and then we would have went, now we do the 3 multiplied by the x minus 5. You remember this? You go x by all of that, and then you go 3 by all of that, and sure, that's what you have down here in red. They're the same thing. So it makes sense that if you got into the pink, it must have came from being purple, which is where they were like this, where those two are in a bracket. And that's what happens here. Okay, so that's fully factorized. Hopefully people enjoy that. Very interesting stuff for who didn't know it. Okay, so another one down here. I'm not going to go through this with you because this is just one of those annoying things you have to kind of learn off by heart, how to prove that root 2 is not a rational number, and you do it by proving it by a contradiction, where you start off by saying root 2 equals a over b. A rational number is something that can be written as a over b. So I'm going to just show you the solution to this, and you can just learn it off by heart. And it's the kind of sad thing that this gets asked, where it's basically you get marks for regurgitating something onto a page. So let me get it up here. So there it is now. So basically you want to take a photograph of that with your mind, and basically store it in your mind, and then when it comes up in an exam, be able to just regurgitate it out into a page, okay? That's all it really is. You start off by saying root 2 is a over b, do these steps, state this, state this, state this, and then eventually, oh, but sure, it can't be a rational number because they have a common factor of 2, okay? Right, there's another thing that can come up as well. It's a really kind of spicy question, is when they say prove root 3 is irrational, okay? And I'll show you a solution to that as well, and you can take a photograph of that in your memory. So there you go. That's the version if you're asked prove root 3 is irrational. Kind of similar thing. You'd get marks by just going root 3 is a over b, same sort of thing. But what's interesting now, it's divisible by 3. Not that it's even. And then that means a is divisible by 3 if a thing a squared. You can read through it in your own time. And then it just means again they have a common factor of 3. And then it can't be a rational number, so it must be irrational. Okay, basically regurgitate into that the page if you're asked it. Great. Right, so let me get back to the document. Okay, so you're back. You're back in the firing line. So it's binomial expansion one here again from 2023 DeVert exam. So it's the power of 10. There's a k. There's an x on the bottom. Okay, so there's going to be, we want the third term. There's two parts to this. There's no third part. Okay, so let me maybe just snip the two parts, and I'll let you pause the video and obviously give them a go and see can you get something going for yourselves, and then watch me do the solution. Right, hopefully you gave that a go. So are ascending in powers of x, yeah, are written ascending power of x. Okay, that just it's in bold. So like, yeah, x would ascend here. Yeah, it would make, oh, in ascending powers of x. So that's interesting because they have put it in bold, so it does look like they put a really mean question here now to try to catch people out. Find in terms of k and x the third term of the expansion. So let's do this the natural way first, and we'll see what I think they're trying to catch people out here with this thing in bold. Okay, it's not very sound what they've done here. K over x to the power of 10. According to the binomial expansion formula, it can be written as the sum, starting at or equals 0, up to n, which is 10 in this question, of 10 choose or. The first term here is known as x, and that starts out with n minus or. And then this term here is k over x to the power of or. Right, so what the student would do here is they'd start writing out what this is. So the very first term starts when or is 0, so it's 10, choose 0. Then it's the x to the power of 10 minus 0, which is just 10, okay? And then it's k over x to the power of or, which is 0. And then I'm going to write the second term, and you can see why this is a mean question. So it's 10 choose 1. Let me move that over so it's not on the black line. So it's 10 choose 1, or is 1 now. So then it's x to the power of 10 minus 1, which is 9. And then it's k over x to the power of 1. Now look at this. If I kept going, if I multiplied all this out, this would give me an x to the 10. If I multiplied all this out, I get an x to the 9 and an x to the 1 on the bottom. And so that would be an x to the 8. So if I kept writing it this way, I'd be writing it with x in descending order. And so whatever I'd write as my next term wouldn't be the correct third term because it's the third term going the wrong direction. So this is very mean, okay, what they've done here. So we've got to kind of think about what would happen if we were doing this in the reverse order. So what you could do here, I'll actually leave that there for a second. So this is not what that's what that equals, but what we really want, I'll write it down here, is we want to do everything in reverse. So what would the last term be? The last term would be when or is 10, right? So then this will be x to the power of 10 minus 10, so this will be the 0. And then this will be k over x, and or is 10, that's when you get the last term. Now if we go the opposite direction, now if or started at 10, it goes down to 9, so the next term is 10 choose 9, so this is the reverse order. Then it's x to the power of 1. It would, yeah, well you can kind of see it just rises up here, but I want to explain why it's 1. Or is 9 now, so it's really 10 minus 9 here, if that makes sense. It's 10 minus 9, yeah. So, and that was a 0 because that was 10 minus 10. So 10 minus 9 gives a 1 here, and then this is k over x to the power of or is 9 here. So you can kind of see the pattern. X's power increases and k over x's power reduces. And then this is 10 choose 8. I don't want to hit the camera thing at the bottom. 10 choose 8, x goes up to a 2, and then it's k over x to the power of 8. And that there is the correct third term when they take into account this very mean thing in bold. Okay, very, very mean. And yeah, right in terms of k the third term. So that's what it is there. So 10 choose, what is 10 choose 8 in your calculator? It's 45. So we got 45 times x squared, and then we have a k to the 8 over an x to the 8. And so then when you multiply that out a little bit more, it becomes 45k8 on top, and then an x squared, x to the 6 on the bottom, because the x squared cancels with this, becomes a 6. Okay. Yeah, so that there in blue would be my final answer that I'm circling or squaring here now. Okay. Yeah, very tough, very mean. Okay. Uh, right. Let me clear that away, and we'll get set up for the part 2 down below. Right, so that's cleared away. Yeah, so we should have room here. We'll write in here, even though it's got the annoying squares. Find the coefficient of x to the 4 in this expansion, right? So you've kind of seen, maybe I can use some of my thing that I had up there before. Yeah, this I'll not completely throw this away because this is be useful for what I'd write here as my first step. Um, so that's that. So this is still absolutely true here in red. Um, are written in ascending order. So this won't matter because the x to the 4 term will be whichever way. If you extend or descend, there'll just be an x to the 4 term, so it doesn't matter. Anyway, so this here is absolutely true in red. This is just fundamentally true for this question. This is a binomial thing to the power of something, and it expands according to this rule here. So we want to find which term would have x to the 4. So the way you write this here is, if this is similar to our very first question, you write the fact that um, this is the general term here, what I'll circle in purple. So what we'll write the k over x as is k x minus 1, similar to what we done in the very first question. So the general term is this, x to the, and again, I don't know how that got in there as n, because n is 10 for this question, as we know. So then this is 10 minus r, and then what we're writing in here is k x to the minus 1 to the r, right? Now we want to get the k out of there like we did in the first question, so I'll show you the same thing. That's just repeat that kind of pink rule for people. If you have a to the b cubed, you can each take them out separately like this, okay? Where they each get their own cubed like that. So that's what I'm going to do here. That's how the k is going to get out of here. So I'm going to let the k out by doing this here. I'm going to give it its own power of r. So that's going to be k to the r. And then this guy is going to be in here just on his own, x to the minus 1 to the r. And the rule is here the powers multiply. The powers multiply. So what I'm really dealing with is a 10 choose r. I'll bring the k up forward. And then I'll let this x here sit beside the other x, 10 minus r. And then this x now is the power of minus r because the powers multiply. And so it's the same as before. They have the same base, so their powers can add. So you have 10 choose r, k to the r, and then it's an x now to the power of, add their powers, you'll get 10 minus 2r. If you want to get an x to the 4 coefficient, you can work out what 10 minus 2r should be. 10 minus 2r should be 4. So then 2r equals 6, and then r should be 3 to get the x to the 4 out. Then you put that information up here. So we go 10, choose 3, k cubed, x then to the power of 10 minus 6, which is 4. Okay, that got us our x to the 4. 10 choose 3 in our calculator. 10 choose 3 is 120. So basically this term is 120 k cubed x to the 4. And we're told its coefficient is 7680, and the coefficient here is 120 k cubed. And we're just going to set those equal to another. I'll get a blue color here. 120 k cubed is going to be equal to 7680. So then k will be equal to whatever 7680 over 120 to the power of a third is. Let's type that into calculator. And if it comes out right, we know we've probably done something right. Yeah, that works out quite neat as 4. And I'd be pretty confident in that. Okay, yeah, pretty tough. I thought this was super nasty. And like, you'd still probably give students very high attempt marks if they'd done it the original thing I was writing out that time in descending order and they gave that third term. So yeah, but this down here, this part 2 stuff you should be able to have done because I'd already done one like that in our very first question. Remember, it was like an n to the power of n kind of thing. Okay, right, let me clear that away and get our next question. Okay, so we've a mock paper here in 2022, and then there's an interesting part two to it. Let's see, can I somehow snip the two of them? So the writing will get a bit small here, so people won't like that, but it's nice to be able to see our part one and part two. Yep, so that's all it is, part one, part two. So it's a bit annoying here. Is this a mock exam? It is a mock exam, so it's a pretty ridiculous thing to ask people to do is to five out a bracket like this. Um, so you can use your binomial expansion thing that I had there a second ago. I've used it quite a lot today, so people will be pretty comfortable with it. It's when all of this is going to be equal to the sum. The sum. I'll actually do it this way because people are getting probably pretty comfortable with it now rather than me using the quicker triangle thing. So this starts off with or equals 0, goes up to n, 5. This is just from the tables book. We have, this is the n, choose or. N is 5 in this question. The first term is 1, so that goes in the x slot. Then this is n minus or. N is 5 in this question, so 5 minus or. And then we put the minus 2x in here, careful with the sign, minus 2x, and then this is the power of r. You get a ton of marks for that, right? So then when this expands here, you just basically follow the rule here. So then it's 5, choose 0, start off with or being 0. Then it's 1 to the 5 minus 0, which is just 5. Then it's minus 2x to the 0, plus, that's what the big E is about. Then it's 5, choose 1. So it's pretty easy now here. The powers just reduce. You can pause the video and think about this if you want to. And then this guy's power increases. Then the OR goes up to 2. This guy's power reduces. This guy's power increases. Plus 5, choose 3. This guy's power reduces. His increases. Then it's 5, choose 4. This guy power goes to 1. This guy power goes up to 4. And then the final term, 5, choose 5. This guy's power goes to 0. He disappears. And it's minus 2x to the 5. He gets the full power of 5. And you get an absolute ton of marks for that, okay? That's basically the question solved. So all you got to do now is the grunt calculator work of typing this in. Just be careful with the negatives when you're typing them in. Like you can't type, for example, minus 2x to the 3 into your calculator. So when you're typing this into the calculator, what you would type is 5 choose 3 bracket 1 squared bracket minus 2 cubed. You don't put the x in, and then you just, whatever you get, you for your number there, you just basically write x cubed after it, okay? So I'm going to pause the video here and write out an answer for that with my calculator. Okay, so I typed all that out in my calculator, and that there in blue is what your final answer should be. That's all the terms there. There's your x, no x term because x is 0, that's a 1. And this is the x squared, and so on and so forth. You know you've done this right if the signs go minus, plus, they go plus, minus, plus, minus, plus, minus, you know. It basically alternates every time. That's what happens when you're expanding something that has a negative in it, like this up here. Okay, hopefully people enjoyed that there. So we actually need that. We need that blue expression to do the part 2 here. So let me rub this out. We don't need this anymore because we've already expanded it. So let me get rid of that. Let me write this up here. And all of that worked out as what 1 minus 2x to the 5 is, okay? Right, so hence you have to use this. Use this expansion to find this. Okay, so how did that become that? Well, it's pretty clear that 1 minus 2x is meant to be 0.98 without reading any more. So then we can work out what x to be. We could probably see in our head that x is supposed to be 0.01. Yeah, looks good to me. So we just basically let x be 0.01, stating clearly what you're subbing in for x. I'm going to put that in for x, and then I'll get an answer for this. So if you put 0.01 in for x, the left side becomes 0.98, the 5, and then you put 0.01 in for x over here. So it's minus 10 times 0.01 plus 40 times 0.01. So this was kind of a smart question here, I suppose, this part of it, but otherwise it's a lot of just grunt work, isn't it? And then it's a minus 32, 0.01 to the 5. So we type all that into a calculator. I'll pause the video and get us an answer. Okay, so I typed that in there. If I typed it in correctly, I hopefully did type it in correctly. But the examiner is basically looking for this, like literally like 14 out of 15 marks is for this, and you get 1 mark maybe for typing into your calculator right. 0.90392 to 5 decimal places. Yep. Okay. Cool. So I'll clear that away, get our next question. Yeah, so I put a star beside this one. This is from 2022's exams. This was a bit interesting what they're asking here. They're kind of talking about odd numbers and they're not talking about even numbers, but I'm just going to remind people of something they should know about odd and even numbers. Usually when we're writing our patterns and sequences, we write Tn equals some term. So when Tn equals 2n, that generates all the even numbers, and Tn equals 2n minus 1 generates all the odd numbers. Because the whole point is the very first term in patterns and sequences is n is supposed to be 1. Okay, we don't start with an n equals 0. So when you go T1 here, what does this produce? If we go and we work through our T1, so we get 2 times 1, which is 2. Then we let n be 2, and then we get 4. Let n be 3, you get 6. Let n be 4, you get 8. Do you see that gets all the even numbers? If we let n be 1 here, we go 2 by 1 minus 1, that gives 1. Let n be 2, you go 2 by 2 minus 1. So that's 4 minus 1, so that's 3. Let n be 3 for the third term. This would be T3 here, this term. You go 6 minus 1, which is 5. So can you see how this is the rule for all odd numbers? This is the rule for all even numbers. When n starts at what? 1. If n is allowed to start at 0, which it is in this question, the rule is not 2n minus 1, it's 2n plus 1. And sure, you can just confirm this works. If n is allowed to be 0, or k is allowed to be 0 here, you go 2 times 0 plus 1. The first term is 1. Then k goes up to 1. Then it's 2 by 1 plus 1, so that's 3. So you see this does generate the odd numbers, okay? Great. So they give us a bit of a hint up here anyways to just multiply this out first of all. So we'll hammer that out of the way. So that multiplied out is 4m squared. Square the first term, multiply them together and double it. So it's 4m, and then it's plus 1, okay? So what they're kind of getting at here, right, is this in here is an odd number, all right? And we have just squared an odd number, haven't we? And this is the result, right, of an odd number squared. Now look at this carefully. We can take a 4 out of the first two guys here, and we're left with m squared plus m plus 1. Now, as I said to you there, when you anything that's 2 times a number, okay, basically the 2n thing, right, that's an even number, right? So what we have here is 4 times a number. So this is even, right? This is even. If you want to make it really explicit for the examiner, you could just write that as 2 times 2m squared plus m plus 1. And you make it very clear that this is realistically just like 2k, if that makes sense. So that this here is even. You just need to, the examiner will leave you alone. You just basically have to make that the fact that that there that I've circled up is even because it's 2 times a number, and all even numbers can be written as 2 times a number, okay? So the idea then is, if you have an even number and you add 1 to it, an even number plus 1 is an odd number. And so that proves this rule up there. When you square an odd number, you get something like this, but sure, this thing is an odd number. So then an odd number squared is still an odd number. And that's what they're getting us to do. Using your answer to part AI, show that the square of an odd number is also an odd number. And the answer to that here basically is just let these be k's, as they say here, swapping the variable as they do it up there. Yeah. And so basically just make it very clear that 2 times a number, I think that was a 2 there. Yeah, hopefully, basically, yeah, you get what I mean here, hopefully. I hope that wasn't written as just an m there, because you have to multiply the 2 back in here, and you should get the 4k squared plus the 4k, which is what this is here, 4m squared plus 4m plus 1. But the point is 2 times something is even, because it's, as I talked to you at the very beginning, 2n is something even. So yeah, even plus 1 gives odd numbers, and so an odd number squared is still odd. So it's a little bit of a funny thing that I know people really struggle with that kind of thing. But for yourselves there and making your flashcards, remember that when you're allowed to start from n as 1, all even numbers are this rule and all odd numbers are this rule, okay? And then if you were to start from n equals 1, which you're not allowed in patterns and sequences, it looks like this here. Great, so that's your learning from that. Okay, so I'll pause this, scroll along to our next question. Yeah, so pretty easy one here. I'm just checking, do people know something here? Okay, so when you're dividing by something, if you want to divide by something, it's the same as flipping it and multiplying. Okay, so that's why, like, just to prove this rule, everyone's comfortable with it. Like when we take the number 5 and multiply it by a half, that's the same as 5 divided by 2, isn't it? Because 5 times a half is 5 over 2, so 5 divided by 2 is 5 over half. But this is the same as going 5, flip the 2 to 1 over 2 and multiply. Okay? So what this is here, what they really want you to do here is realize that this, and I'm sure people know this, but just in case there's someone watching that didn't know this, is that dividing is the same as flipping it and multiplying. So then this just comes up here and multiplies. Minus 21x squared over 5x plus 4. And then it's just some pretty brutal factorizing from here out. I'll just do it here. So you should realize that this is the difference of two squares on top here. So that's 5x minus 4 times 5x plus 4. Right, this is pretty intense what this thing is here. It's pretty crazy. You can kind of guess it's something to do with this thing here. Now look at it. There's an x. You could probably take a 3x squared out of it. So I'm going to take a 3x squared out of that thing on top here, and it'd leave behind another 3x squared. It'd leave behind a 20x, and it'd leave behind a minus 7. I knew to take that out of it because it was probably always going to cancel with this thing down here. So then this on the bottom is 3x squared plus 20x minus 7. And then that's this. Oh yeah, this is the 5x plus 4 now. Yeah, because we've done that. So then this cancels with this cancels with this, and you're really just left with 3x squared on top multiplying a 5x minus 4. And that's probably as tidy as you'd leave that now. I wouldn't go messing around with it anymore. Okay, that'll do. Hopefully people enjoyed that example. Hopefully anyone who didn't know what was going on there, they learned from it. So I just scroll down here and I see our next question. So let me zoom in and we'll do this one. So obviously pause the video, give it a go yourselves. Right, hopefully you tried it. In the expansion of 2x plus 1 times this, right? So this would give a cubic if we multiplied it out. The coefficient of x is twice the coefficient of x squared. Find the value of p. So what I'm sure people would do is they just multiply this out. And that's completely fine. You know, you can just multiply it all out if you want. Or you can be quite precise about this and just work out where coefficients of x come from. X's would just come from the 2x by the 4. So then the coefficient there is 8. They would come from the 1 times the px, so it gives a coefficient of p. That will be equal to a coefficient of x. That's just your coefficient of x, right? There's no equal sign here. Okay. So then let's study what the coefficient of x squared is. So there's a video on the YouTube channel called why you shouldn't be doing long division, and I teach a little bit about this comparing coefficients thing. Anyways, where do the x squareds come from? You should go watch that video, by the way. So then it's 1 times an x squared, so that gives a coefficient of 1. Then it's a 2x by a px, that's where the other x squared comes from, and that gives a coefficient of 2p. So that's what I'm circling in pink. This is our coefficient of x squared, and then this is our coefficient of x. And we follow the instruction here. The coefficient of x is twice the coefficient of x squared. So the way I do these when they say an instruction like that in a question is, first of all, I set them equal to one another. And then I carefully read it and see which one is smaller. Coefficient of x is twice the coefficient of x squared. So I read that carefully and I see that x squared's coefficient is the smaller one. So I know this side over here is smaller than this side, so this side needs to be pumped up to be equal to the bigger side over here. So I give this side the 2. Did that make sense to people? This kind of idea of work out who's smaller and pump them up? Okay, coefficient of x is twice that of x squared, yeah. So you got to double the x squared one to make it as big. Right, and then you can just do this. 2 plus 4p. Bring the p over here, bring this over here. Then 6 is equal to 3p. P is 2. Okay, hopefully people enjoyed that. I'll get the next question. Yeah, this was a bit of an interesting question in 2019, so I put a star beside it, and so we'll do it. So basically it says show that the mean of set A and the median of set A are the same. So basically this is getting us to, it's more of an algebra question, that's why it's here. So the mean of all these is just add them up and divide by 4, right? And you can actually do some of these. So people need to know that the square root of, this is a rule, square root AB can be written as root A times root B, okay? So when you're looking at these, you've got to, you could first of all just rewrite A. A then as a set is really root 32k, because then that's, you separate it into a root k squared, and root k becomes a full k, okay? That k isn't in the square root anymore. Then it's root 50. Okay, so this is before I work out mean or median. I'm just doing this. K, and then it's root 98. Okay. Now your calculator will tidy these up for you. Now just so you understand what your calculator does when it tidies these up for you, I'll do the root 51. What's happening here is we write root 50 as root 25 times root 2. Now the reason we pick 25 and 2 is when we separate them like this, root 25 is 5. So when you type root 50 in your calculator, it says 5 root 2, and that's why it says 5 root 2. So root 32 can be written as 4 root 2k. As we've seen, this one is 5 root 2k. Root 128 is 8 root 2k. And then it's root 98, which is a 7 root 2k. Now we can't actually work out the median of this until they're ordered. As you can see, they didn't have them ordered for us. So we'd have to reorder this to put them in ascending order. So the first one's 4 root 2k. Then it's 5 root 2k. Then it's 7 root 2k. And then it's 8 root 2k. Right, we can do the median. We get the median by adding them all up and dividing by 4. Now you can do this in your head, believe it or not. There are 4 root 2k's, there are 5 root 2k's, 7 root 2k's, and 8 root 2k's. So you really just go 4 plus 5 plus 7 plus 8. So realistically, all those red numbers add up to 24 root 2k, and then you divide it by 4 because there's 4 numbers to get the mean, okay? And then that goes into that 6 times, so then you get 6 root 2k. That there is the mean. Okay, and the median is got by taking, when you have 4 numbers, it's got by taking the average of the second and the third. And so you just show that for the examiner, that you're going 5 root 2k plus the third number, 7 root 2k, dividing it by 2. That's 12 of something divided by 2, and then that works out as 6 root 2k. So it's a pretty easy question if you just do the kind of tricks I showed you there. But it can be just a bit scary looking at it like that, you know. But both the mean and the median worked out to be 6 root 2k with the k outside the square root. Okay, hopefully you enjoyed that. Bit of an interesting one from 2019. Okay, I'll scroll along and get our next question. Okay, so a bit of factorizing here. We're told to fully factorize this out, so make sure you give this a go. Pause the video, try it. Right, so first of all, let's see, can I take something out of things? So I can definitely take an x out of everything. Can I take 686, does that divide by 16? It does not. Can I take an 8 maybe? 686 divided by 8 doesn't go in, so then 4 is probably the biggest I'm going to do. 686 divided by 4, that doesn't even go in. So then I must do just 2. 686 divided by 2 is 343. So all I'm going to take out is a 2x, because 2 goes into this, the only thing. That leaves behind an 8x cubed minus 343. Now, people need to know that, well, first of all, I'm going to write this the way this is. This is the difference of cubes, believe it or not. So this is a 2x cubed, and then you should know that number. That number is 7 cubed. Okay, that's just one of them numbers to kind of be aware of. You can test it there. 7 cubed is that number. It is. Okay, so there's an expansion formula for this. You should know it off by heart. I'll get it up in the textbook here as a yellow box for people. Okay, there you go. Bottom left, yellow box. That's what you're dealing with here. Difference of cubes, it expands like this, and then no need to learn off this more complicated one here. You should just be able to work out on the day that your x is the 2x here, and then the y is the 7, and sub it in properly there with neat brackets. Don't be learning this one. Okay, so back to the question. So yeah, believe it or not, you're meant to know that formula off by heart, and I do. So this thing here, I can use a square bracket for this. So the way this expands is it goes 2x. If this is a minus, you start with a minus. Then you square this term, so it becomes a 4x squared. If you start it with a minus, you switch to a plus. Then you just multiply them together and don't double it. If you multiply 2x and 7 together, you get a 14x. And then you finish with a plus, so you square the last number, so you get 49. And then, yeah, that's pretty much this thing fully factorized. So it's a 2x out the front. It's a 2x minus 7. And I don't think this is going to factorize anymore for us. You know, I just don't get that feeling that this will factorize more for us. Unless maybe it's a 2x times 7. No, I don't know. Will it factorize more first? You can run the quadratic formula at it and see does it have neat roots, and if it does have neat roots, it'd factorize. So I'll do that now. So minus 14 square plus square root of 14 squared minus 4a, which is 4 times c, which is 49 over 2 by 4. So I'm getting a math error there. So we can check the discriminant on that. B squared minus 4ac. B squared minus 4ac, so that's 14 squared minus 4 times 49. Okay, hopefully people know what the discriminant is. Sure, if you've watched the previous algebra parts, you should be okay with what it is. So then that's 14 squared minus 4 times 49. And that explains the math error because that's minus 588. And then that's less than 0. So then there's no real roots. So then this thing can't be factorized with real numbers. You need complex numbers. Okay, that thing in pink is as factorized as that gets. So hopefully people enjoyed that. Particularly that thing with the b squared minus 4ac to see that don't waste your time. This can't be factorized, this thing. Okay, so was there something? Yeah, there is something just below us here. It's only, oh, there's another part here. So let's do this. This is our next question. Find the coefficient of this that's independent of x. Okay, so it's this binomial expansion thing again. You've seen this a few times, so hopefully people are getting the swing of it now. You've actually pretty much learned it, I think. This is 1 over x. You can actually get ahead of this by calling it x to the minus 1 now, okay? So you can call it that, and then according to this rule, it's the sum from r equals 0 up to n, which is 8, times, oh, this is the choose thing, so this is 8 choose r. This is from the tables book. Then this is 8 minus r, and then this is x minus 1 to the power of r. Okay, and you see what I mean? You can get ahead of this because you know now that their powers multiply, so you could actually even just write that as x to the minus r. Okay, but I do it in another line. Okay, I wouldn't do it straight away here, but I'm just doing it here just to save myself having to write it out a second time. So then this is the general term here, right? So then they're the same base, so their powers add. So then this really is 8 choose r, it's an r, times x to the power of the powers add, so you get 8 minus 2r. And so you want the term that's independent of x. The term that's independent of x has no x, and an x to the 0 is a 1. So this is the term that has no x, whichever one has a x to the 0 as a power. So then basically you want your 8 minus r to take on what value? You want your 8 minus 2r to take on a value of 0 to kill off the x. And so when that happens, you can see it just by looking at it. R needs to be 4. And so then we can find the term here. So then this is our general term. So then we go 8, choose 4, and then x to the power of 8 minus 2 times 4, which is 8. And so we then get, what's 8 choose r in our calculator? 8 choose 4 is 70. So this is 70. And then it's x to the 0, and that's the term independent of x because x to the 0 is 1. So the answer is 70. The coefficient is 70. Right, hopefully people enjoyed that, and they're well into the swing of the binomial expansion formula now. It's not so scary now, hopefully, for people. Okay, yeah, that looks good. We had another factorizing thing down here. I think this is, yeah, so that's another one of them where you flip and multiply. So here we go, next question. So 2017, factorize this. So pause the video, give it a go. So this is just the difference of cubes formula we seen a second ago. So you should know that 64 is 4 cubed. So then you can write that like that. And you should know 125 is 5 cubed. They're just numbers you should know. You can check, you can just cube that again and see it becomes that, and cube that becomes that. So then this is just that expansion formula where you start, if this starts off with a minus that I had in the yellow box down there, this starts off with a minus, if this starts off with a minus, and then bracket, you square this term, so you got a 16x squared. Then you change to a plus if you start it with a minus, and then you multiply them together and don't double it, so then it's just 20x, and then you square the last term and it's always plus, so that's 25, and that's her. And yeah, it'll probably be the same thing again. You do a discriminant on that, it won't factorize anymore, so you get b squared minus 4ac. You should know what 20 squared is, it's 400, minus 4 times 16 times 25. You can just see in your head that this is less than 0 because 4 times 25 is 100, so this is 1600, so that's like minus 1200. And so therefore there's no roots, which means you won't have any nice factor, no real roots. There'll be imaginary ones, so that won't factorize. Okay, cool. That's it there. That purple thing was the final answer. So was there something else down here? No, there wasn't. So I'll pause, see our next question. An easy one here for the binomial expansion. They just want you to write out the general term. Now there might be a part 2 here to this. There is. Oh yeah, so this is just like find the term independent of x. So this maybe is a chance for people to practice what they learned there a second ago. When you see me do this, find the term independent of x. So definitely be pausing the video, see if you learned from the last example, see can you do this. Okay, so in general, x, and then this is 1 over x, so we'll write that as the minus is just the minus. But then because it's 1 over x on the bottom, we can bring it up and it's x to the minus 1 there. And this is the 15. And that follows this formula. Sum from r equals 0 up to n, which is 15. The first term's an x, and then that's the power of n minus r, which is 15 minus r. And then the second term is x minus, we nearly got caught out there. It's minus x minus 1, and that's the power of r. Great. So you just got a bit, what's a bit tough about this one now is this minus. You have to treat that minus with care, okay? So the general term, oh, look what I've got my n choose or. I've been threatening to do that a few times now when I've been writing it out. So do not forget your n choose or here, 15 choose or. Right, so you need to know how to deal with this minus thing. So the way you deal with that minus thing is, I'll write this out here so I have another line. 15 times 15 choose or times x to the 15 minus or. Now I'm going to do things over here. So what minus x minus 1 can be written as is really minus 1 multiplying by an x to the minus 1. Okay, you can just take out the minus 1 from it. You can factor it out. And so then if the whole thing is to the power of or like this, you can then individually give them a power of or like that. Hopefully people are okay with that. Think about it. It seems fair. Like if this was the number 3, you'd be happy I could just factor out the 3, you know, and then it would be 3 to the or. And so it works the same if there's a minus 1 multiplying your x to the minus 1. Great, so that's what I'm going to do here. I'm going to go minus 1 to the or, and then I'm going to go x to the minus 1 to the power of or, but we know the power is there multiply. So then I'm going to just call this x to the minus or. Great, so then what we have then is this is what's called the general term here in pink without the summing thing. Let me switch color maybe to blue. So what we have here is 15 choose or. Then the x's are to the same base here, so the powers can add. So I'll move the minus 1 to the or out the front, and then you have an x to the minus 15 minus 2 or. Okay, hopefully people are good with that. And that thing in blue there is the final answer. That is the general term. And then it says hence, we're obviously going to use hence, find the term that's independent of x. This will be independent of x when this thing has a power of 0. So then we set 15 minus 2r equal to 0. So that looks like it's going to give an issue there. Oh, sure, look, I've a thing. Because, yeah, so we know there was something. I hope people didn't get too panicked by this, that I missed the fact that this was x squared in the question. So we'll deal with that in a sec. I knew there was something wrong here because look at this. When I move this across, I get or is basically like 7.5. Or can't be a non-integer number. So that means something was wrong. The thing that was wrong here is that in this question, I took this down as an x when it was really an x squared. But this is so easy fix. I'll just come across here with another color, put the squared in, put the squared in, and then put the squared in here. See how easy this is fixed? The examiner will see that this was fine. And now, what's the rule of indices here? The power, now these are not the same base, so their power is cut and add because this is x squared and this is x. But these multiply here, right? So this 2 here will multiply this out here. And so this becomes a 30 minus 2r. Okay? And now they have the same base here, x and x, so then their powers can add. So then you get yourself a 30 minus 3r, actually, minus 3r, because it's minus 2r minus r, so that's a minus 3r. Tough question. Okay, so then the term independent x will have a 0 there, so we get the green back out. It'll work this time. So we get 30 minus the 3r, bring the r, you can basically just see r is 10, can't you? Okay, so if r is 10, we can find this term. So then we go 15, choose 10, minus 1 to the 10, and then we go x to the power of, we know it's going to be 0, but we'll just type it in here anyways. It's going to be 30 minus 30. Okay, so then it's going to be x to the power 0, but x to the power 0 isn't 0, x to the power 0 is 1, okay? Minus 1 to the power of an even number is also 1. You can check that in your calculator. So all that this really becomes is whatever the value of 15 choose 10 is. And it's an unusual number. It's 303, which is very unusual. But that is what 15 choose 10 works out as in the calculator. So yeah, the answer I'm getting there is 3003. Okay, hopefully people enjoy that. I'll clear this away. Okay, so scrolling on to our next question here. So this is 2015. It's a mock paper. What is an irrational number? Give an example of a rational number. So they're just checking, do you know the definition of a rational number? So first of all, you got to give the definition. Just remind people there's a cool page in your formula tables for this. So let's go here. Let's go to, I think it's sets and logic. And it's here. So you see there's a nice page here where you have the definition of a rational number. So it's Q, where it can be written as A over B, where A and B, well, you can call them P and Q if you want, where A and B are an element of an integer, and the bottom here, B or Q, can't be 0. So you would just start off with that first of all, that definition, that Q is basically all numbers that can be written like this, where A and B are an element of Z, where B can't be 0, right? So then what's an irrational number? The irrational numbers are r less q, okay? They're basically all the numbers that can't be written as a over b, if that makes sense to people. So that would be the definition of one there, and probably the most famous irrational number is root 2, or pi, whichever you like. But yeah, root 2. And pi, you have pi over 1, but it's not that it can be written as a fraction, it's that a and b have to be integers, and pi isn't an integer. So hopefully that makes sense to people. So yeah, I'd start off with the definition of what is a rational number, and then I would say an irrational number is basically not this. It's basically can't be written as a over b, where a and b are integers. Okay, so basically just bring this part here in with this definition here. Okay, so I hate these Venn diagram things. They're always really stupid, but this one seems pretty straightforward. We have our natural numbers. Our integers contain all our natural numbers, and then so all your integers can be written as rational numbers, which is something we should know. So that's kind of like this outer circle here. And then we have our real numbers here. So then it makes sense that this out here is the or without the q. And that's our rational numbers in there. So this one wasn't too bad. Okay, so let me pause and scroll on for our next question. Yeah, so that's basically it for this document on algebra expressions and factorizing, this part on the algebra. Now, at the end of this document here, they have this question, which is basically a junior cert problem where they have like, ticket prices and the number of people that can attend. So I might do this out just for people. We'll only do maybe like A to D because it's actually a long question, so it's all kind of, just small little calculations. But it may be no harm, people actually give it a go and then see if you were able to do it. And we'll finish the video here with this. So, yeah, so hopefully you can read that. You can obviously zoom in on it on the YouTube and read it a bit better and take your time with it. And we'll go through it now. So pause the video, give it a go. Right, let's see, can I make sense of it? A stadium can hold 25,000 people. People attending a regular event at the stadium must purchase a ticket. When the ticket price is €20, the expected attendance is 12,000 people. The results of a survey carried out by owners suggest that for every €1 reduction from 20, the ticket price is expected to increase by, or the expected attendance is expected to increase by 1,000 people. Okay. If the ticket price was €18, how many people would you expect to attend? So we're €2 below this, so we'll have an extra 1,000 people, so I'd say 14,000 people. Makes sense to people? Let X be the ticket price, and X is less than 20. Write down in terms of X the expected attendance, so they're kind of leading you through it here. So what did we do to get that 14,000 in our heads? Well, we really got the 12,000, didn't we? And we added 1,000 for everything we were away from X. Let X be the ticket price, so we took €1 away. So hopefully people can realize this is like 20 minus X. 20 minus X, does that make sense? Yeah. So if the ticket price was 18, X is the ticket price. So you like test your formula, let's see if it works. Put 18 in there for X, the ticket price, and then you go 20 minus 18, so that's 2. So then you got your 2 by 1,000, that gave the 14,000, okay? And check that it works as well too. When the ticket price is the full €20, you go 20 minus 20, this would give us 0, and then you get the original 12,000. So this looks good to me. No need to have it equal to something, but you could say it's equal to A for attendance if you want. Okay, write down a function that gives the expected income from the sales of the tickets for such an event. So it's a very junior cert problem. So income we can call I. So basically you just take the number of people that attend and multiply it by the ticket price, and the ticket price is X, isn't it? So you just take that and multiply it by the attendance. Okay, so hopefully we're doing this right. I'm pretty sure we are. It's pretty straightforward stuff, isn't it? Find the price at which the tickets should be sold. Find X basically, so that we can maximize I, income. So this is a differentiation problem when we want to maximize a function. So we multiply this out. I is equal to 12,000x plus, we multiply this in here. This is 20,000x. You can take your time to multiply this out if you want. And then this is minus 1,000 x squared. So just so how you can see how I've done that, I went x by 1,000 by 20, which gave the 20x. I went x by 1,000 by x, which gave minus 1,000 x squared. So then you can put these together here and call them a 32,000x. 32,000x. Okay. You want to maximize that I function, so you get di dx. Okay, this is if you didn't know this, right, to take the derivative, and people haven't done calculus yet or differentiation, what you could do is you could realize that's an n-shaped quadratic, right? And you should know how to complete the square on this. And so you complete the square on this and find its turning point up here, and that'll be the maximum point. And you'll work out your x value for that, and then you'll work out what that turning point is for I, its y value. So that's a way for people to do it who haven't done differentiation, but most people I assume will have done it if they're looking at exam paper questions. Take a derivative of this with respect to x, you get 32,000 minus 2,000x. Set it equal to 0 to maximize it. You'll see that it gets maximized when x is equal to 32,000 over 2,000. So basically sell the tickets at €16 and you'll get your maximum attendance. Yeah, find the price at which the ticket should be sold. So that's all we wanted. We just wanted the price. We didn't actually want the max income. If you wanted the max income, you just put the 16 back in for x here, and you'll get what the max income is. Okay. And just for anyone who done it the other way, where didn't know what differentiation was, sure, I'll finish the question on this. So we'll complete the square because people should know how to complete the square. So we'll revise that. So this is maybe an interesting one to complete the square on because it has no number. So pause the video, everyone, give a go at completing the square on that. So it's basically I'll move the x squared forward, minus 1000 x squared plus 32,000x. So we want to get the x squared on its own first. So we take out a minus 1000. And it leaves behind x squared. You take out a minus 1000 out of that, you'd be left with negative 32x. Hopefully people are okay with that. You can multiply it back in and see if it goes back to what it should. It should go back to 32. It does, yeah. Okay, so then what we do is we half what's in front of the x. That's how you complete the square. So the minus 1000 is just chilling out here. So you half what's in front of the x. So you got, and then you square this. Because the rule would be if you were squaring this out, you'd multiply them together and double it to get the x term, so that where the minus 32x comes from. And the idea is here, if you were to square this out, you'd get a number. 16 squared positive. You'd get plus 256 if you squared all this out. Just kill it off. Get yourself back to 0. And usually like there's like a 7 here or something. You just add on the 7. You make that happen. But the nice thing about this is there's no number there. So when you're completing the square, you just add a 0. Okay. Just to tell the examiner, if you want. So yeah, that's basically it. So the completed square format on this, which people should be able to do, because you've all done your algebra, so you should know this. So this is that, and then it's a minus 256 here. And as always, we multiply back in by the 1000. I ran out of room, so I'll write it up here. The income can be written as minus 1000 times an x minus 16 squared. And then this is a plus 25600. Yeah, 256,000. Yes. And so the maximum income happens when this thing is made into a 0, and that becomes a 0 when x is 16, as we found from our derivative there a second ago. And then when x is 16, this takes on a value of 0, and so the maximum income is 25600. And so this n-shaped quadratic, its turning point here is 16 euros and 256,000. So some very cool maths for people there. So I hope you enjoyed this video and you learned a lot from it. And if you did, be sure to like, comment, and say it helped. And be sure to subscribe. Okay, thanks for watching. Okay, hello everyone. Welcome back. So this would be part 5 of important past paper questions you should know on the topic of algebra. And this document is referred to as cubics, okay, on the topic of cubics. And it's about 37 pages long, and I've gone through it and marked out with red stars the important questions we need to know on this topic of cubics and algebra. Okay, so we'll get straight into it. Obviously, be pausing the video, giving these a go yourself, making sure you're able to do them, because they're all important questions you should be able to do. Okay. So let's get the first one going here, and then it says we can remember what part 2 is here, hence find the rest of the roots. Okay, so we'll hammer this one out. I can probably make that a touch bigger. Okay, so what we've got to do here is find k. Now the easiest thing to do here is called the factor theorem. So if x plus 1 is a factor, that means x equals minus 1 is a root. Okay. So then when you put a root back into the function like this, f of minus 1, it'll make, this is the y value, it'll make that equal 0. So you would just state that for the examiner, and then you go 0 equals minus 1, putting minus 1 in for x, plus 5 times minus 1 squared. So this is the quickest way to find k. And then negative 12. Yeah, that looks reasonable to me. So always slow down and just make sure you've typed everything in correctly. So that gives a minus 1. This gives a plus 5, minus k, minus 12. What am I getting here? Minus 13 plus 5. Let me just double check that. Minus 13 plus 5, and then bring it over. See, there's a negative on the k as well, so I'm going to bring the k away from these here. And then it's minus 13. Plus 5. Okay, so k is minus 8 when you bring the k over, and you leave these guys here, okay? Okay, so we have k, so now we got to get the other factors. So then it's x cubed, you update your cubic, minus 8x minus 12, and we'll know k is right here by basically seeing does this long divide in. Now on the YouTube channel, I have a really important video, and we're going to need it because you're not going to see me do long division at all in this video, so you're going to see me using this kind of cool comparing coefficients thing. So what I'm going to do is I'm going to maybe pause the video for a second and just get you a screenshot of the video you should watch on this because it's pretty important. Okay, so that's the video there. So make sure everyone's watch that video because it shows you that there's a much better way to do something like what we're about to do here, which is show that this is a factor of this and find the other roots. The other factors. This video is very important. Okay, it's only like what 30 minutes long. Okay, anyways, right, we'll get back into this. So what you do is we have the x plus 1 here. We have the linear factor, so we're missing the quadratic. So we leave a triple space here, right? So you can basically just guess what has to be here. X squared has to be here because the x by the x squared gives the x cubed. So they both have a coefficient of 1. He's a coefficient of 1. So then the number by the number has to give the number. So this has to be a minus 12. So then all we're missing is what's the x term. And we call that plus ax when we're trying to guess the quadratic. So what we do then is we get a look at coefficient of x. Where do x's come from? If we were to multiply this out, we'd get 6 terms, but that takes ages. We only actually need to multiply out 2 terms to see where the x's come from. The x's come from the x by the minus 12, and that has a coefficient of minus 12. They would come from the 1 times the ax, and that gives a coefficient of a. And you set that equal to the coefficient of x on the right, which is minus 8. And then you see here that a is a plus 12. Okay, so you see that there's no need for long division. You can just basically get the other guy like basically 0 effort. So the other guy is 12x minus 12, right? Yeah. So let's, what else do we got here? You've always got to check this then with the coefficient of x squared. Make sure you get the same result here. Oh, this is me being silly here. That's not 12. That's a 4. Bring that over. 4. And then that's 4. Okay, so yeah, you always check this using the coefficient of x squared as well, so you see where they come from. So that's that by that will give a coefficient of 1, and then it's this by this, which gives a coefficient of plus a, and you set that equal to the coefficient of x on the other side. So then you get the same result here, bring the 1 over, you see a is 4. Okay, great. So that's the other factor that's there, and no long division needed, okay? So let me clear some of this away. So you can, if you want then, so yeah, you have to because you want the other factors, so you just need to factorize that. So that's probably what, plus 6 and a minus 2. X and a minus 2. That's it, yeah. So then these are your 3 factors written out like that. And then obviously the 3 roots, if you're asked for them, are minus 1, minus 6, and 2. Okay, pretty important question that. Okay, so I'll clear that away and get on to our next one. Find the roots, yeah. So you had to get the factors and then the roots. Okay, so I'll pause the video, get our next one. Right, so our next question is from this 2024 deferred paper, and they're talking about something to do with sheds. But we're interested mainly in just this part of the question down here, the part C from this deferred paper. And it's this important sort of graph idea, okay? So I think it's just, yeah, it's just one part from this deferred paper. So this is really, really important. As students, you're meant to be pretty comfortable with what I'm going to discuss with you here, okay? So the idea is, right, they are giving us the roots from the diagram. Okay, so I'll just we'll deal with a quadratic here first so I can teach people something. Okay, so let's say we knew the quadratic went through 2 and it went through 4. Okay, nice and straightforward. So then it's a U-shaped quadratic and it would look something like this. Right, the idea is everyone knows that the roots are 2 and the roots are 4, and they're probably pretty comfortable that you can go and you can put them back into factors, multiply them together, and you get back to a quadratic. But what you've got to understand, and this is really, really important, this thing is supposed to be equal to 0. You cannot set this thing equal to y. Okay? This is not correct. The reason this is not correct is because if you multiply this out, all you would ever get is a 1x squared. Your x squared would always have a coefficient of 1, and that's not possible, as in like there are other quadratics that have, like how would you ever get a quadratic that has say 3x squared plus 5x plus 1? You'd never get it, you know? So if you just kept doing this kind of thing, okay? So the idea is here, you can absolutely set this thing equal to 0, and that's what you do. But if you want to set this thing equal to y, you have to put this thing in here called an a. Okay, this takes into account the possibility that there's something like a 3 there, okay? Um, okay, so that's a big thing here, and they help students with this here in this question because they remind them, okay, there's this other thing called the a. And the way you get that is you need another point on the graph. And usually the easiest point that you'll have here is you'll have where it crosses, say, the y-axis, say across the y-axis there at 7. So this is a point here, 0, 7. So then what you do to get the a down here is you'd put 7 in for y, and then it's a times 0 in for x, and then another 0 in for x here. So that's minus 4. And then you multiply that out, you get 7 equals 8a, and then you can see then the a is 7 over 8, okay? So then the original quadratic is y equals 7 over 8 times these, and you can times it out. Okay, so that's a really big thing. You can put the factors multiplying together, but it has to be equal to 0. You can't just set it equal to y. You have to remember there's this a thing you have to work out, and you need another point for that. So why is that important? Because that's what's going on in this question. Absolutely, they give us this root, and this root. Now this here turns twice, so it's a cubic, right? Now another thing that's interesting about this, it's down on the right. And if you've watched some of my graph tricks tutorials on the YouTube channel, anytime a function is down on the right, it means its leading power of x is negative. So that if this is, in general, all cubics can be written as ax cubed plus bx squared plus cx plus d. If you are down on the right, it means that your leading coefficient, your highest power of x, is less than 0. So that must be like something like a minus 2 or something like that, or a minus x, uh, if that makes sense to people. So it has to be, that a has to be negative if it's down on the right. Any function that's up on the right, the a is greater than 0, okay? And that's the origin for, as we would have learned at junior cert, if we have ax squared plus bx plus c for all quadratics, if a is positive, it's a smiley face. If a is negative, it's a sad face. And that's because if you're down on the right, you get a negative there. And think of it as well for your slopes. Your ax plus b. Okay, this is for your straight lines. We know if you have a negative slope, you're down on the right. If you have a positive slope, the slope is in front of the x, you're up on the right. Okay? Pretty important stuff for people who didn't know it. Make some flashcards on it, of course. Okay, right, so let's work through this. Let me just pause, make a note on something. Okay, yeah, so let's get stuck into this. So what we got here is we're setting this equal to y, and we've got some roots here. So what we can say is x plus 21, okay, and then we go x minus 12. So if the root is plus 12, you go x minus 12 for the factor, and then the other one is x minus 47. Now you can absolutely set that equal to 0 if you want, and that's completely fine. But if you want to set that equal to y, okay, or h of x as they want to call it, you just put an a in there, right? And the way you get your a is you need another point on the graph, and the nice point, if they give it to you, is the y-intercept here, okay, because it's easy sub in. So you just sub minus 1316 in for y. This will get your a. You just need any point. The point could be here, it's fine. So a times, the nice thing about this is you put zeros in for x, so then it's a bit like 21 minus 12 times minus 47. So then a here is equal to minus 1316 over 21 times minus 12 times minus 47. That's nice for you in the examiner, because now you only need to pick up the calculator once to type that in, and you've shown the workings on the page. 21 times minus 12 times 12 times 47. And yeah, we get a there is something like minus a ninth. Okay. I believe I typed that in correctly. Yeah. We can check it in Desmos anyways afterwards. But the main thing is you're seeing it's working out as like minus a ninth. And it's negative, and that's what we said it would be, down on the right, wouldn't it? So let's have a look at this in Desmos, just so you can see what I'm on about. So I'll pause the video. Okay, so we're in Desmos, so tricky plot this because the numbers are so big. So if you ever need to do this in Desmos, you can edit the numbers here to change the scale and stuff for anyone who likes Desmos. Okay, so yeah, I've plotted that there, so I can clear this away. So this is the function I wrote up on the screen there for a second ago. So you can see it does all it's supposed to do. It goes through there, it's there, and then it goes through there. So we've done it right. We've worked the A out correctly. Now what I'm going to do for people here is I'm going to show what happens if you change the A's value. So let's tweak this. Say it's like 1 over 7. Do you see what's happening? Say you make it like 1 over 5. You make this number bigger, you can make it skinnier, you know, and if you make this like 1 over 50, it gets very wide. You see this here? See, doesn't get as skinny. So again, this is something to kind of play with in Desmos. See if you make it like a half, it gets like really tall and skinny, you know. But you see, it still has to go through the roots down here. Okay, so hopefully that makes sense to people. What's happening there? Okay, so we make that a 40. See how wide it gets, you know. Okay, but it still has to go through the roots. Okay, so yeah, hopefully people are good with that. So I'll go back to our questions. So this is our next question here. So these are tough. Okay, so these are straight up pretty tough. And the great thing about this is that video that I showed you a screenshot of there near enough the beginning of the video. That's very useful for doing this type of question. Okay, so this is a tough question, but that video shows you the stuff you need to be able to do it using the comparing coefficients, not using crazy long division. So find the value of P and R, right? So what you want to do here is you want to find the missing factor, and you do that by going using your comparing coefficients. Okay, this is the quadratic, so we're looking for the linear, and we set that equal to the cubic. The cubic is missing an x squared, so you just put in a 0x squared, like you would if you're doing long division. Minus 2x minus 3r. Okay. So this is really easy when you don't need to use an ax when you're looking for the linear. You can just guess it straight away. You just look at the x squared times whatever's here would give the x cubed, so that has to be an x. The 1 times whatever is here would give the minus 3r, so that has to be minus 3r. Okay, because it's 1 times minus 3r. The number by the number gives the number. Okay, so we've got the missing factor. You get loads of marks for that. So then what you do now is you go and you look at the coefficient of x. Where do x's come from here? They'll come from the 1 times the x, which gives a coefficient of 1. They'll come from the minus px times the minus 3r. Okay, so then what does that give us? That gives us a plus 3rp as a coefficient. And then that's equal to the coefficient of x over here, which is a negative 2. Okay, so we can't get r and p from this because we have two equations, two unknowns, but we could tidy it up. We could say 3rp equals minus 3. So then RP equals minus 1. Okay, so we need to go now look at coefficient of x squared. Okay, this will all make a ton of sense if you've watched that video. This is way better than doing something like long division, you know. And I have a few examples of this anyways in this tutorial video, so definitely watch that video first and then kind of come back here if this is confusing. Right, so what do we got? Where do x squareds come from? They come from this by this. So that gives a coefficient of minus 3r, and they come by this, so that gives a coefficient of minus p, and then that's equal to 0. So then we have that p is equal to minus 3r. Okay, so we can sub that in for p here, so I'll get a different color for this. So we'll go r times minus 3r equals minus 1. So then we get minus 3r squared equals minus 1, so then r squared is a third. So then r is equal to plus and minus 1 over root 3. Okay, you got to be careful. It can be plus or minus, but this will be the defining thing here that p is less than 0. So if we want p to be, we'll get p on its own here. So p is equal to minus 1 over r. If we want p to be negative, we'd want r to be positive, if that makes sense, to keep p negative. We don't want minus over minus. So we want r to be the 1 over root 3. And then when you go 1 over root 3 here, you'll get that the root 3 pops up on top. You can just do it in your calculator. Minus over 1 over root 3, you'll see that you get minus root 3 there. Okay, so that's p. You'd circle this up for the examiner, and then that's the correct r value for p. Okay, hopefully people are good with that. That's an interesting question. Yeah, and again, that's the kind of question that's an absolute nightmare if you're using something like long division. Okay, so I'll pause the video, get our next one. Okay, so our next question comes from this 2023 deferred exam paper 1. So what do we got here? Show that x equals 10 is, so this seems to be like its own thing up here. So this seems to be a separate sort of question here. Interesting. And then hence, so this is only like a 1-part thing. So what I'll do is I'll just snip this, and you can pause the video, of course, give it a go yourselves. Okay, hopefully you gave it a go. Right, show first of all that this guy is a root of this, and hence find the other two roots. Okay, so basically, you just put it in. Okay, you just put it in there. This is the factor theorem. It's the idea that if you put the root in, the thing equals it's a solution. So can we do some of this in our head? We should be able to. So that's 1,000. 10 by this just adds a zero to the end of it, and then you add 10. So then yeah, that's zero. Okay, no need for a calculator. It's nice to do things in your head if you can do them, but show it on the page as well, of course. Um, right, so now we know that that's a root, so then this is a factor. Okay, so then we leave room for a quadratic. That should be a bit wider. Same thing as before, leave room to a quadratic. Again, you don't want to be needing to use long division. This is so much quicker than what I'm doing here. Plus 10. So then we can guess what has to go here. It has to be an x squared because you go x by x squared gives an x cubed. Minus 10 by something gives a plus 10. Has to be a minus 1. You just put a plus ax here. Then you look at the coefficient of x. Where do x's come from? Let me switch color. We get it from this by this, so that gives a minus 10a as a coefficient, and we get it by this, so that gives a minus 1 as a coefficient. And set that equal to the coefficient of x over here, which is minus 101. Great, so bring the 1 over, you'll get minus 100, so you get minus 10a is minus 100, so then a is 10. And then confirm that by looking at the coefficient of x squared. And where do x squareds come from? They come from this by this, so that's a minus 10. And they come from this by this, so that gives a coefficient of a. You set that equal to this guy's coefficient, which is 0. Bring the 10 over, you see a is 10. So it's the same result. You only really need to do one, but if this is your state exam, you want to check both to make sure you've done it right. So then the missing factor is x squared plus 10x minus 1. So yeah, we're definitely going to be looking at getting some weird square rooty things here. So we're going to have to use the minus b formula. Now, before you use the minus b formula on that, we're going to be setting this equal to 0. You want to show it on the page. So you want to say like x equals minus 10 plus minus square root of, 10 squared minus 4 bracket 1 times minus 1 all over 2 times 1. And then you can just write down the answers for the examiner, okay? And they'll have weird square root things in them like that there. So let me type that in here. Should I take a second? Plus root 100, basically plus 4 over 2. So very quickly typing that in, I'm getting something like minus 5 plus root 26, and probably minus 5 minus root 26. Okay, sound. And if this was your exam, what you could do to make sure that they're right, you just take both of them and plug them back in here for x. And then if they make it go to 0, like putting the 10 in made them go to 0, you can move on from this question happy in the exam knowing you've done it right. You've found the other roots. Okay, so I'll pause the question, find our next problem. Okay, so our next problem is from a 2022 deferred paper 1. And they give us some function up here. Now they say it's something to do with a box, but we don't really need to know much about that. What's interesting is it does have units, okay? So if u is in units of cm squared, that means x's are in units of centimeters. So if you ever write down an x, you'd want to make sure you write it down with centimeters. It's a little bit of an annoying thing that, because they deduct marks for it in a question that had units. So write down the 3 roots. So for example here, yeah, you'd want to be writing centimeters after this. It'd be a deduction if you didn't. So the roots here are fairly straightforward. So x equals 0. What would you put in there to make this factor go to 0? I'd put a 21 in there, would do the job. And then what would you put in here to make this go to 0? I'd put a 15. And if you can't see that, you can just go 30 minus 2x equals 0, move it around, and you get x is 15. And again, too, they're in unit. They have units, centimeters, so watch out for that. Okay, so they're the 3 roots. And then we're asked to plot them down here, so I'll probably try to keep them there so I can plot them. Okay, so let's go up here. Sketch the graph of this, and on your show all 3 roots of this. So that's when y is 0. When y is 0, they are giving these x values. So like you mark these in here. When y is 0, x is 0. When y is 0, you get a point like 15, and then you also get 21. So like as coordinates, these are like 15, comma 0. That's what this means. When y is 0, x works out as like 15. Okay, so now I know I have to go through them 3 points and I need to work out am I up or down on the right. So this is something you want to be careful with. You see, you do need to kind of multiply it out to find out a little bit more about it. So where would the x squared thing come from? It would come from the x times the minus 2x times the minus 2x. So that would, if you multiplied it all out, you should get a plus 4x x cubed. Okay, so that means it's up on the right. Okay, hopefully that makes sense to people. So I know I'm roughly sketching something like this. I'm going up, and I'm turning, I'm going up, and then I'm going down like that. Okay. And yeah, that'd get some decent marks on your sketch. Just draw a sketch of it, yeah. So I think that's good enough. If you wanted to do a really good job of this, you might remember, and you maybe yeah. So you want to label the points in there as well. You want to go 15, 21, 0. And what I'd recommend doing is getting maybe one more point, kind of get like what's going on at 7.5, and then getting what's going on at whatever the midpoint is here. What's the midpoint of those? Like, is it 18? 18. So what I mean by that is get whatever the value of u 7.5 is, and see how high up you're meant to go there, and then go u 18 and see how low down you're meant to go here. Okay, so I'm going to put them into I'm going to pause the video, put those into the original function there, and get values for them. Okay, so I'll pause the video, get that. Okay, so I've done that. So the numbers are like huge. So when you go and put the 7.75 in it, this thing goes all the way up to like 3037.5 there, kind of. And now that's not necessarily the turning point, but it's not far off. Like the turning point might be here or here. Okay, we don't know. You could go and find the turning points if you wanted from taking derivatives, but let's not get into that. So then we've 18 here. So then this guy comes down here when you're 18 to like minus 648. Okay, so that's not too far off because this number is about 4 times as big. So this distance down here should be a quarter of this height up here. But otherwise, it's pretty close. Okay, hopefully people are good with that and how to draw a good sketch of a graph like that in an exam. Oh yeah, what's this saying here? So it says the function u of x above there that I've just sketched there, it gives the volume of this third box for a particular range of values. Write down these range of values. Yeah, so we'd imagine because x is something to do, it's probably like a dimension of the box. Now we probably could do it a bit more context in this question, but I'd imagine that the problem is only valid in this region here, okay? Like the box's volume could never go negative here, if that makes sense. And this negative region doesn't make sense, okay? So it makes sense that changing x like this, there is like a maximum volume they could get in a box for a certain x value. So I'd say it's between there and there is where the problem is valid. So it's between 15 and 0. Okay. And I wouldn't put equal to symbols because if you put the equal to symbols there, that would give a box with volume of 0. Okay. So we don't want that. We want the box to just have a bit of volume. Okay. Oh, and again, true, that has units, centimeters, between 0 centimeter. So you can just write centimeters once here. Okay. So watch out for units when they're in a question like that. Okay. So, oh yeah, our next question just down below here. So this should be fairly easy. The part two then is hence or otherwise find the third factor. So we'll do both of these in one go. So let me get this set up here. Like, I'm sure everyone can do this, but just hammer it out to make sure you can, because it's one of those questions you're kind of meant to be able to do. So I'd say the best way you can be doing this question is to just use your factor theorem twice. So if that's a root, then x equals 2 is a factor. And if this is a root, then x equals a half is a factor. And so then you just put these in here. So you put 2 in for x, 2 cubed, plus 2 squared, plus b times 2, plus 6. And then when you put the root back into the function, this thing equals 0, okay? And so you get something like 8a plus 4 plus 2b plus 6, and then you get an equation that says 8a plus 2b is equal to minus 10, and then you can divide by 2, and then you get 4a plus b equals minus 5. So there's like one of your junior cert equations with one equation, two unknowns. So we'd get the other one by putting the half in here. The half is a little trickier put in. So we would go a times 1 over 2 cubed plus 1 over 2 squared plus b times a half plus 6, and then it's equal to 0 because that's the factor theorem, okay? So then we get a over 8 plus a quarter plus b over 2 plus 6 equals 0. Maybe multiply everything by 8, and then you get a plus 2 plus 4b. Oh, what's 8 by 6? 48. 48 equals 0. So I'm doing this pretty quickly. So that's a 2 gives a 50. So I get like a plus 4b equals minus 50. And yeah, pretty easy solve the simultaneous equations. I'll do it here because the a is pretty much on its own. So I can just say like a is equal to, oh, it's negative, it's really annoying, minus 4b minus 50. And then you just put that in for a over here. So then you go 4 times putting this in for a, minus 4b minus 50. And then add your b that's here, and then equals minus 5. So then what is it? It's minus 16b minus 200 plus b equals minus 5. And then this should tidy up a bit. So then I'm getting a minus 15b on the left. And I'm getting something like a plus 195 over here. Now, if minus 15 doesn't go into that, there's probably something wrong in my calculation. But it went into it. So then b is working out as minus 13. I'm pretty confident in that. And then when you get b, you sub it back into where you moved around a. So then a equals minus 4, bracket minus 13. Oh, I'm sure you can all solve a simultaneous equation, you know. So minus 50. But I said I'd do this here just for people. So what's that there? 4 by 13, take away 50. 4 by 30, yeah, so that's working out as 2. A is 2, okay? So A is 2, and then B is minus 13, right? So let's write that in here. 2 minus 13, hopefully I remember that. So 2x cubed plus x squared minus 13x plus 6. We're asked then in the next part of the question to find the missing factor. So what we do here, it's so simple. We just combine these into a quadratic. You can multiply them out for yourselves. So you get 2x squared. I'll just do it here quickly. You get a minus 4x and then another minus x there. So that's a minus 5x in total. It's plus 2. So what I done there, I combined in my head where the x's would come from. So that gives a minus 4x and that gives a minus x. So that's minus 5x. And then I multiply the numbers together. So then you just use the comparing coefficients thing that's mentioned in that video I told you to go watch. And it can guess the missing linear factor basically instantly. No effort at all. So then you just look at this. What would you multiply 2x squared by here to give the x cubed thing? You just multiply it by an x. Okay, that gives 2x cubed. And then what do you multiply this number 2 by here? To get a plus 6. So you plus 3. So that's the missing factor. And then the missing root is minus 3. Okay. Hopefully people are good with that. That sound. Okay. Hence or otherwise find the third factor, yeah. So you just wanted the x plus 3, you didn't need the other root, x minus 3. Okay. Hopefully people are good with that. So I'll pause, find our next question. Yeah, so I said I'd do one of these. So these come up. They're pretty annoying. I think they're kind of moving away from this type of question now where they just get the student to guess one of the roots, you know. It says 2 non-real roots. Okay, so find the 3 roots. So we'll have to use a bit of complex numbers to get those non-real roots. But the idea is here where they make the student guess one of the roots. Nowadays, they're like actually telling you like, oh, show x equals 2 as a root, okay? They give you the guess rather than wasting time guessing. So the way this is meant to work is the guess will usually be either minus 4, minus 3, minus 2, minus 1. It usually won't be 0 because there's a number at the end here, it won't work. It can be 1, 2, 3, or 4. And you just got to show this for the examiner, you putting the numbers in. So I'm just going to guess one of them here. I'll see does the 2 work, okay? So I put the 2 in, minus 7 squared. So this will be your workings for the examiner. And as I said, like they're kind of moving away from this now because, you know, if the student knows to do this, why are you making them guess all of this, you know? 8, what's this? This is 4, so minus 28 plus 34, take away 15 equals 0. I can see this probably isn't going to be 0. So we see that this gives like a minus 20 here. And then this gives a plus whatever. It's close though. 34 take away 15. So that's a plus 19. And so then you would just say for the examiner, minus 1 here does not equal 0. So then therefore x equals 2 is not a root, okay? The 2 didn't work. Okay, and you just got to keep guessing there until you get one. So I'm going to pause the video and get the right guess, but you know what I'm basically doing. I'm just going through the options. Okay, so I worked it out. So 3 is the one that does it. Okay, so you would have guessed 3, and this is what would have happened for you. 3 cubed minus 7 times 3 squared plus 17 times 3. Take away 15 equals 0. So then this is 27 minus, 9 by this, that's like minus 63. Then this is a 51, and this is a minus 15, and that's equal 0. And then you can hammer that into calculator. 27 minus 63 plus 51 minus 15, and that will be a 0. So that means you just concluded for the examiner x equals 3 is a root. So therefore we have a root. So what we do now to get the other roots, it means that x minus 3 is a factor. We leave room now for a quadratic. We'll guess it using compared coefficients. Minus 7x squared plus 17x minus 15. It's so simple. Has to be an x squared here because of that. And then how do you get a minus 15 from a minus 3? It has to multiply by a plus 5 here. Okay, it's so simple. Watch that video. Okay, so then you look at coef of x to get the a. Where do x's come from? They come from this by this. So that's a minus 3a, and they'd come from this by this, and that's going to give a coefficient of plus 5, and you set that equal to the coefficient of x over here, which is 17. Bring the 5 over, you get plus 12. So then a is negative 4. Confirm that then by checking it with, so that's the answer basically done. See, there's no need for long division. So then coef f of x squared, I'll switch up the color. So we go this by this will give an x squared, so that's a coefficient of minus 3. This by this, and that gives a plus a. And then that's equal to this coefficient over minus 7. Bring the 3 over to plus 3, and then a is minus 4. Great. So we have our missing factor up there. I'll write it up here. So it's x squared minus 4x plus 5. We're not going to waste time factorizing that because the question basically told us we're looking for 2 non-real roots now. So we'll get the minus b formula at this guy, and then we'll see why the discriminant is negative because there's no solutions for this. So no real solutions. X equals minus b, so that's 4 plus and minus the square root b squared, which is 16 minus 4 times a times c. So you can see straight away there that's going to be minus 20 over 2 times a. So you're going to get x, you'd show the work and stuff for the exam like this, plus and minus, no calculator work. So that's a root minus 4 over 2. And we should know that root minus 4, we can write that, we can take the root minus 1 out. So then we have an I out here. And then you get the root 4. Root 4 is 2. I'm just kind of showing it all here in one step. So then we get a 2i there. 2i. And then we cancel in our 2. And so our two solutions are 2 plus and minus I when you cancel in the 2. So the other roots are 2 plus I. And the other root is 2 minus I. And you can go watch the complex numbers videos on the YouTube channel to see more of that stuff. Okay, cool. But you're on exam papers now, so that's why I do it that quick. Right, I'll pause the video and get our next question first. Okay, so this is from a 2019 mock paper. These are very important. I think I've maybe 1 or 2 of these now in a row. And so this is where you have to get these unusual sort of things out of like a cubic up there and a quadratic. So this here is an absolute nightmare if you're relying on long division, but it's super routine if you're using the comparing coefficients thing you've seen me be doing and that you would have seen in that video. So let's do this. Basically, I'm going to tell you now, this is going to come from looking at coefficient of x, and then the other one will come from, say, coefficient of x squared, or the other way around. Basically, there's 2 equations here, and both of them come from looking at the coefficient of x squared. Right. They give us the quadratic, x squared plus px plus 3. We leave room for the linear, which we're missing, and then we set that equal to our cubic, bx squared plus 11x plus r. Now, so this is the tough part here for people, okay? And I'll just quickly show it. What do you multiply? We'll get the ax out of the way here first of all, because that's easy. Because you go x squared by ax and you get ax cubed. Now, the number by the number gives the number. Now, people are like, what on earth do you multiply a 3 by to get an r? And if you watch the video, you'll see that it's very straightforward. If you want to turn a 5 into a 7, what do you multiply it by? 7 over 5. Okay, you put the thing you want on top and the thing you have on the bottom. Okay, so if you want to turn a 3 into a 4, What do you multiply the 3 by? The thing you want on top and the thing you have on the bottom, because then they cancel down, you see? Okay, and then a really silly example, how do you turn a chair into a star? Okay, you multiply it by the thing you want on top over the thing you have, and then the chair is cancelled and you're left with the star. Okay, so then how do we turn a 3 into an OR? Well, then the 3 has to multiply by the thing you want on top and the thing you have on the bottom, and then we keep a plus because we want everything to stay positive, okay? So the missing factor is ax plus OR over 3. Hopefully people are good with that. Okay, so then what we do, so simple, we'll get these two equations then by looking at coefficient of x. Okay, where do the x's come from? They'll come from the 3 times the ax here, which gives a coefficient of 3a, and they'll come from the px times the number at the end there, so that gives a plus PR over 3, and we set that equal to the coefficient of x over here, which is 11. Right, and what we do here, we might multiply this across by 3, so we get ourselves a 9a plus PR equals 33, and so you can see it's this thing down here, isn't it? We just write it that way, so you leave the PR on one side, so PR equals 33 minus 9a, and that is part 2 of the question solved. So simple, you know, you'd have such a nightmare of a time if you weren't using this comparing coefficients method. Right, coefficient of x squared, where do they come from? So if you go with the x squared by the number at the end, you'll get yourself an x squared, and that gives a coefficient of r over 3. And then you go this by this, and that gives a AP. Well, that gives an AP as a coefficient, or you can call it PA. They call it AP here, so we call it AP. And then that's equal to the coefficient of x squared over here, which is b. Right, so looking at this here, they have no or. Do you see there's no or in this? Okay, so we need to get rid of the or here, but I'll multiply across by 3 first. So we get or equal, we get or plus 3AP equals 3B. So we've got to get rid of the or. So what's annoying about this one is you'll need to get or on its own here to make this work. So what I do is I'd say down here, I'd say or is equal to 3 minus 9 over a over p, and then put that in here. So then we get 3 minus 9a over p plus 3ap equals 3b. And now this is just in terms of a, p's, and b's. And that's what this is, a, p's, and b's. Maybe multiply everything by a p. So you can see, what can we do now? So everything, it's a little tricky here now, but I'll kind of hammer this out. So what we'll do is we'll multiply across by a p. So then we get 3 minus 9a plus 3ap squared equals 3bp. Divide everything by 3. I'll move up here now. 1 minus 3a, but I'm sure you can all do the algebra from here. It's easy enough. It's ap squared, dividing everything by 3, and then you get a bp over here. And it wants something like what does it want here? Where's it getting the 11 from? Where to get that 11 from? So, have I got this all good here? So B's, BAP. The 11 looks unusual. I can see how we'd get. Yeah, I think there's either a mistake on my workings or mistake. We'll see, this is 11 here. Did I start calling something non-11 somewhere? I don't think so. So there might be an error here. This might mean a 1. So I'll just double check this. So what we basically can do here, because they have 11 minus 3a, I just move the AP squared over the other side. So then I'd get 1 minus 3a equals something like BP minus AP squared. And then I would just factor out the P on this side. And then I get B minus AP, which is this side here. And then I'm getting a 1 minus 3a, not an 11 minus 3a. Now, if this is a mock, that's it there. Stupid mocks. So I think that's incorrect. That should be 1. But I'll just double check that now. I'll pause the video and check. Oh no, that was on me. So we'll hold back our stupid mock thing for a second. So when I had this down here, I had 9a plus PR equals 33. And then somehow when I moved this around and I brought the 9a over, I stopped calling this a 33. So then this was always a 33 here. This was always a 33. And then when I multiplied across by P, this was still a 33. And then when I divided everything by 3, wherever I done that, I think it's up here, this became an 11. And then this is still an 11. And then this is still an 11. Okay, so very straightforward stuff to fix that. So yeah, hopefully people are good with that and how that kind of question works. I think we've one or two more of them anyways in the document. So, okay. So yeah, I'll pause and find our next one. Yeah, so we've basically another identical one like this here, 2018 mock paper 1, and so they're just basically the same kind of problem, isn't it? So different things they want us to get out. So pause the video, see if you've learned from what I showed you there a second ago using the comparing coefficients, see can you get it out. Okay, so what we do again is we are trying to guess a linear. So we leave room for two pieces there. Set this equal to our cubic as such, plus qx, take away 4. This then has to be an x because it's x squared by x gives the x cubed. What do you multiply a c by to get a minus 4? That's easy. You put the thing you want on top and you put the thing you have on the bottom. Okay. So then what we do is we go and look at the coefficient of, say, x first of all. Where do x's come from? They come by the c by the x, so that gives a coefficient of c. And they come from the bx times the number at the end. That'll give a minus 4b over c as a coefficient. And set that equal to the coefficient of x over here, which is q. Okay. Does that give, yes, that'll probably give the part 2 down here. You multiply everything by c. What you'll get is a c squared minus a 4b equals a qc. And then if you bring the 4b over, you get 4b, and bring the qc over, you get c squared minus qc. Okay, so that's that one done. So we're going to do coef of x squared now. Okay. Where do x squareds come from? They come from this by the number at the end. So that's minus 4 over c. They come from this by this, and that'll give a coefficient of b, and that'll be equal to the coefficient of x squared over here, which is p. And great thing about this is we don't have to do like a sub in like we did the last time there. So we just would multiply things here. I'll bring the b over first of all to make this look the way they have it. So it's p minus b, and then you multiply across by a c. So minus 4 equals c times p minus b, and that's what they have there. So that one was really easy. Okay, hopefully people are good with that. So we get our next problem. See how quick that was, you know? That's the way the comparing coefficients can get it done. Okay, I'll find our next one. Okay, so our next interesting problem here is from a 2015 mock exam, and we're told to basically convert this graph back into the original polynomial here, okay? Back into what f of x was, okay? Notice it's not equal to 0, so they mean this is equal to f of x. In a state exam, they'd be a bit more clear on that. So the big thing for students here is to understand that this is a special point here. When you just touch a graph like that, when you just touch an axis like that, the x-axis, that counts as a double root, okay? That's a double root. So the root there is x equals 1. So it really counts as like two roots. So when you're turning that back into a factor, it's like an x minus 1 and another x minus 1. And so the way we usually treat a touching root like that is when we'd write it as x minus 1 squared, okay? So that's what he'll count as when we put him back. And then we have our other root here, x equals 4. So that'll give a factor of x minus 4. I can start putting this together down here. So there's our double root, a double factor from the double root. And then we have our x minus 4 because we have a root of 4. And then we have our other one here. This is x equals minus 2, so then that gives a factor of x plus 2. Now, you can absolutely just go and set that equal to 0. That's fine. But if you want to set that equal to y, you need to include an a here, okay? As I spoke about earlier in the video, very important. Now, this thing will be up on the right, so we'll expect the a to be greater than 0 here, okay? That's what we can expect. And we're going to get, when you multiply all this out, you'd get something that's x to the 4. And something that's x to the 4 turns 3 times, and this thing does turn 3 times. So something that's x to the 4 turns 3 times, something that's a cubic turns twice, a quadratic turns once, and a linear turns 0 times. Okay, hopefully you're good with that pattern. So we need to find the a. To get the a, we need another point on the graph, and they're not very clear about what the other point on the graph is. In a state exam, they'd make it very clear one of these other points here, and they don't here, unfortunately. So I don't know what this point here is. Is it 7 or is it 8? I doubt it's 7.5, you know. So it's impossible to know what they're getting at there. If I was to make a guess at it, let's call it 8. Okay, minus 8. Let's see. But in the state exam, they'd make that very clear that that cuts at minus 8. Okay, so in for y, you put minus 8, and then what is x at this point here? X is 0. So then you just go a bracket 0 plus 2. Okay, or you can just write 2 because 0 plus 2 is 2. And then you go minus 1 squared because you're putting 0 in for x. Or in your state exam, you could show it a little bit clearer. So 8 actually works out quite nice here because when you multiply this together, you get 2 times a plus 1. So that's a minus 8a. So they probably did mean it to go through 8 there because then a works out nice and neat as 1. Okay, and then that's the plus 1 that we're on about, as in it has to be up on the right. So the a turned out to be greater than 0. Okay, so hopefully people are good with that. Cool example there of how you convert. Very important. Make your flashcards on that, you know, and particularly this touching point if you didn't know what it does. And that's how you convert a graph into a polynomial equation like that. Now, the really, really annoying thing here now, and I'm not doing it. I better do it because people probably have done it. Is they're not happy with it in that format. Look at the format they wanted in here. So they're just completely wasting the student's time by having to multiply out brackets like a junior cert thing. So I'll just do it here really quickly. So it's x plus 2. Square this bracket out here. You get x squared minus 2x plus 1. And then you have an x minus 4 at the end. Do you know what I mean? Like, this is just so boring to have to go and multiply all this out. Out of protest, I'm not going to do it. Okay, so you can obviously multiply out things. I'm not wasting video time on doing it. Okay, so yeah, Grant, I'll get our next question. No. So what I did is I actually did multiply it out because I said it'd be interesting to show you it in Desmos. So that's it multiplied out there. And I know that's correctly multiplied out because then this is it in its not multiplied out version. So you see that they sit on top of one another. And because they sit on top of one another, they must be the exact same thing. So that's it there multiplied out for everyone. So I've, what do I have there? I have a 6 written down here. So that's a 3 there. So minus 3x squared plus 14x. Yeah, so that's all good there. So what do we notice as well too? We see the sort of same thing that we saw in the graph. See the double point there. It works as a double root, and then we come up here, and then it's going down to there and there. Now we can kind of see, what do we see? See how it's going? The scale is a little bit off. See, this goes like down to 100. So like one block here is worth 20. So you see it goes down to like minus 20-ish, and then you can see the minus 20-ish here. And you also see it cutting y here at the minus 8 as we predicted, okay? So hopefully people are good with that. So Desmos is very useful for people. Okay, I'll pause this, get our next one. Okay, so these are our next two problems. These are actually from the same year here, the 2015 mock. So you're just asked to investigate if this is a factor. So there's actually two ways you can do this, okay? So the quickest way is the factor theorem, and the other way is to actually factorize it in, okay? So we'll show you the quickest way to do this. So you just go and you put the minus third in here, in for x, and then if it equals, you put its root in there. So if it equals 0, it is a factor, okay? And that is a root. So then this is 4 times a third, and then plus 5. So you'd show that for the examiner, and then I'll pause the video, type that into calculator. Yeah, so when I type that in there, I get 6, and 6 does not equal 0. So therefore, I'd say, therefore, this is not a root, and therefore, this is not a factor. Okay, so that's the quickest way to check it. It would be more of a headache to actually then try and factorize it in. You could use like a long division to get a remainder. That would be another way to do it if you're into that. But you could use your comparing coefficients there, and you'd see that like you're not getting a solution for the ax that's in the quadratic you're trying to guess, you know. So hopefully people are good with that. I'll actually show that because that might be interesting for people to see. It'll only take a second. So let's say you thought that it was a factor. So let's do this here. We'll leave room for a quadratic. So let's see how this goes out. X cubed minus 5x squared plus 4x plus 5. Okay, so assuming it is a factor, you could write it like this. And then what has to go here for this to give this would have to be a 2x squared, because this by this gives this. and the number by the number gives this, so then this has to be a minus 5. And now we're going to try guess our ax, but we're probably going to run into an issue here with getting ax because this thing isn't a factor, okay, as you'll see. So where do our x's come from? They come from the 3x by the minus 5, and that gives a minus 15. They come from the minus 1 times this, and that gives a minus a, and then we set that equal to the coefficient of x over here, which is 4. Okay, so what does that give? That gives, you bring the a over, bring the 4 over, you get minus 19, but you're not going to get the same answer here. Watch this, for when you do coef of x squared. I'll change to blue. So this will be the hint that there's something wrong. Where do our x squareds come from? They come from here and here. So you get a minus 2 from that when they multiply. And then this by this gives a plus 3a x squared. So you just write down its coefficient and then you set that equal to minus 5. And so you get 3a equals to a minus 3 when you bring the 2 over. And then you get a is equal to minus 1. But sure, they can't be two different values. Okay, so then that means this is the conclusion. Therefore, not a factor, okay? Not a factor. So that's how you would do this. And you could also do it using long division, and you'd see that there's a remainder, if that makes sense to people. Okay, so hopefully this proves here why it's not a factor, because both of those a's should be the same thing, and they're not. Okay, great. Very interesting question. So I'll pause, get our next one. So this is our next problem, as I said, from the same year. So let's get this up here. Okay, so given that this is a factor, let's show this. So that's just our comparing coefficients thing again. So I've already done loads of these. But you know, it's always good for you to get good reps on them. So to see me do another one, so we'll leave room for the linear. And then we set that equal to the cubic plus px squared plus qx plus r. Okay, and what are we trying to guess here? So this has to be an x, because you go x squared by x gives the cubed. What do you multiply a minus 1 by to get an r? You multiply it by minus r. Easy stuff. So then we look at the coefficient of x. Where do x's come from? You get them from the minus 1 times the x. So that gives a minus 1 as a coefficient. And then this by this, that gives a minus a r as the coefficient of x there, and then that's equal to this coefficient of x over here, which is q. Oh, and that's it. So it's basically done now. So q equals, you just factor out a minus 1 out of this, and you get 1 plus AR equals q. So we don't even need to look at coefficient of x squared. They didn't want that piece of information. They just wanted the one piece. Look how easy that was, you know. Couldn't be easier. So that showed how powerful comparing coefficients is there. Great, so yeah, our next question here is just below. It's from 2014's official paper, and there's a few different parts to this. Okay, so let's, what's the video on now? 55 minutes, I will get there. Okay, so what are they saying here? Pause the video, obviously give these two parts a go. The graph of a cubic function cuts the x-axis here, here, and here. So when you cut the x-axis, they're your roots. And then this is your y-intercept. So they've given us those 4 pieces of information. So then we have enough to write back to this, okay? So, and they've actually drawn a graph of all that information there. So the way we would do this, to show this, we'd show that f of x is equal to the 3 roots. So x plus 3, convert the roots into factors, x plus 1 and x minus 2. To be able to set it equal to y, you need to include an a here. And then you go and you include this other point that they gave us. So you let y equals minus 6 and let x be 0. So then it looks a bit like this. 3 times 1 times minus 2. And so then a here, it'll be minus 6 equals minus 6a. And then that means a is 1. Okay. And then there you go. And then obviously if you multiplied all that out, it'll become that. Okay. Great. And you see why a is a plus 1 there, because it's up on the right, as we'd say. Okay. There's another function called g of x. It's a straight line. It has a slope of minus 2 and it has a y-intercept. C is minus 6 here. So what that means is it cuts the y-axis at 0, minus 6. So basically solve when these things are equal to one another. Okay, so how do we do that? So let me show you how you do that. and solve the resulting equation and to find the coordinates of their points of intersection, right? So that's a bit of tough algebra. It's like a simultaneous equation. So you've got two equations here. You have y equals x cubed plus 2x squared minus 5x minus 6, and then you have another equation which is minus 2x minus 6. So basically this is simultaneous equations. You want to find where these guys intersect, so their x's and y's would be the same then. So the quickest way to do it is set their y values equal. So then you get x cubed plus 2x squared minus 5x minus 6 equals minus 2x minus 6. And this is super mean because you have to actually kind of solve a cubic here, you know. So they wouldn't really ask something like this nowadays because it's so intense what the student has to be able to do here. So they have to write this here, and then it's like a minus 3x when you bring the 2x over. Now, oh well, this is actually easy factorized because look what happened. The 6 is cancelled, didn't it? So then you get equals 0. So this is easy factorized now. So you can just take out the x's. You can take out one of the x. The reason this would have been tough otherwise, if there was still a number here, this would have been the thing where you have to guess one of the roots. If that makes sense, and that would have been tough if you had to guess one of the roots. You would have been there like x equals 1, x equals 2, x equals 3, x equals minus 1, minus 2 until you got a solution. But anyways, this is easy factorized. You just take the x out and leaves behind an x squared plus 2x minus 3. Okay, and then that factorizes to x times x plus 3, and then an x minus 1. Okay, so remember this is equal to 0 as well, equal to 0. And so the solutions are x equals 0, x equals minus 3, and x equals 1. So that's where this straight line crosses this guy here. Now we need y values for those points because we asked for coordinates. Okay, so this is actually a pretty good question. So we got to go and sub our x values back in, say, to the straight line. It's the quickest place to get the y values. So then we put 0 in there, and we'll get a y value of minus 6. So then the point is 0 minus 6. If you put minus 3 in here, you'd show the workings for the examiner. If you put minus 3 in there, that turns to a plus 6, and that gives a y of 0, funny enough. Okay. And then you put the 1 in here, you'd show it for the examiner, minus 2 bracket 1. You put a 1 in there, y works out as minus 8. So the straight line will go through these 3 points. So I think the next question is mark this stuff in on the graph, draw this guy's graph, yeah. So to draw the straight line's graph, you just need 2 points, but we actually have 3 points that this line goes through, so it's easy to draw it. If you didn't, the way you draw a line is you find where it intersects y and where it intersects x, and then just connect those 2 points so that should make sense. The junior certs can do that. The junior certs can sketch a straight line, so you should know how to. Okay. Right, so 0 on the x, minus 6 on the y, 0, so this is it here. Okay, so that's one of the points. Then it's minus 3 on the x, 0 on the y, it goes through there, and it goes through 1 minus 8, so it must go through here. Okay, so then this is our line g of x going through those 3 points. Happy days. Okay, so that is what they call g of x in the question. So hopefully you enjoy that. It's an interesting bit of algebra. It looks a bit messy on the screen, but it was actually a good question this year. Yeah, okay, cool. I could draw that in Desmos for people if they're interested. Let me pause the video. Okay, so sketch that up in Desmos. There's our function as we worked it out before. And then there are the 3 points that we found. I'll try and bring it back here. 0, minus 6, minus 3, 0, and minus 1, or 1 minus 8, sorry. So yeah, hopefully you enjoyed that. It's quite cool how our diagram basically captured that as well, you know. Okay, so let's roll along here. Draw a sketch of that. We already done that. And then yeah, so like I've already done so many of these here. Like, is there any point in doing it? What's the video on now? Like an hour. Because I put the mark in, I might as well do it. But you've seen me do so many of these comparing coefficient ones, particularly those as well who have seen me. You should have watched that video as well, where I'm doing them. But anyways, I'll knock this question out here. Given this is a factor of this, find P and Q. So actually, there's 2 ways you could do this. So that's probably why I've marked this in, because this is an interesting question. You can do this 2 ways. You can factorize this, and it will be a plus 3 and a minus 2, right? And then that means this guy's roots are x equals minus 3. And then x equals 2, okay? So that's good. So what you could do here is you could use your factor theorem. You could put minus 3 in for x. You'd get one equation with p and x in it, and then you could put 2 in, and you can get another equation with p and x in it, and then that's junior cert problem, find p and x, okay? So that, hopefully people appreciate that. That's the factor theorem way. I'll get one of the equations so you can see what I mean. You put the 2 in here, you go 2 times 2 cubed minus p times 2 squared plus q times 2 minus 6. Remember, it'll be equal to 0 when you put the root in. So then this is 16 minus 4p plus 2q minus 6 equals 0. And then we'll have something like minus 4p plus 2q. That's a 10. Bring it over. It'll be a minus 10. And then you might divide by minus 2. Might make it a bit easier. So that'd be 2p minus q equals 5. So there you go. You have an equation. And then you just do the same with the minus 3. And then you get another equation. Then it's the junior cert. 2 equations, 2 unknowns. Okay. So the other way, it'd be using my comparing coefficients. So where we write this fella here, we guess the linear. And we set it equal to this. We can fully guess the linear because we have the front and the last thing here. So let's do this. 2x cubed minus px squared plus qx minus 6. We can guess the missing factor. The missing factor is, it has to be a 2x here because you'd have to go x squared by 2x to get 2x cubed, and the number by the number gives the number, so this has to be a plus 1. So you can see how quickly we were able to get the other factor, and then we have the other root as minus a half. Okay, this would be the quickest way to get the other factor and the other root. Okay, but that's not what they wanted here. They wanted the p and q first. So you can actually get, as you've seen there, the other factor without getting p and q. But to get p and q from this, then you just look at your coefficient of x. Where do x's come from? So they come from this times the number at the end, and they come from this times this. So that's, oh, why did I write an x? The coefficient is 1. Okay, and then they come from this times this, so that's a minus 12, and then that's equal to the coefficient of x over here, which is a q. And you see how quick this is. So then q is minus 11. And then you look at the coefficient of x squared. Where do x squareds come from? They'd come from this times the number, which is a 1, and this by this, which gives a plus 2, and then that's equal to the coefficient of x squared over here, which is minus p, and so then p is equal to a minus 3. Okay, 3. Okay, so hopefully people enjoyed how quick that is when you use the comparing coefficients. You don't need a simultaneous equation then, okay? Right, let me clear that away, get our next problem. Okay, yeah, so we're basically finished the video now, so we're on the very last question here, where the last mark is, so all the way back to 2012 mock paper. So obviously people pause the video, give this a go, see if you've learned stuff through the video, for those who came along. So really awkward looking, pretty crazy looking cubic there, you know, pretty intense. And you're asked to show that x equals 1 as a root of this, okay? So that is basically the factor theorem thing. So when you go and you put f of 1 in there, it will equal 0. So we can do this pretty easy because it is the number 1 we're putting in here. So you go 0 for y, then 1 cubed, you'd want to show it for the examiner, plus 2p minus 1, put a bracket there, times a 1 squared, plus q minus 2p times a 1, and then take away a q. So then after you've shown that subbing in for the examiner, you can then quickly tidy it up to 1 plus 2p minus 1 plus q minus 2p minus q equals 0. The 2p's cancel, the q's cancel, and the 1's cancel, and so 0 equals 0. So therefore, x equals 1 is a root. Okay, that's how you do part I. Was there no part 3 to this? No, just 2 parts. So this is our final part. They tell us that when you set y to 0, okay, and then you divide this thing, is divided by x minus 1, the resulting quotient is called g of x. Prove that g of x has equal roots. Okay, so they're bringing a bit of the discriminant in here. So when you have equal roots, b squared minus 4ac is equal to 0. So that's a very good question they came up with here. So they get to examine the student on do they know what this means here, you know. So right, so dividing that into that is extremely intense if you don't use the comparing coefficients, you know. So let's do it with our comparing coefficients. So we leave room for the quadratic that we're trying to guess, and we set that equal to our really nasty looking cubic here. So this is as tough as it gets now, okay, in terms of how this guy looks. Q minus 2p x, take away a q. Okay, let's see, can I move that over so that it all fits? Okay. So great thing is we can guess what goes here. It's an x squared because x by the x squared gives the x cubed. And then we can guess what goes here because the number by the number gives the number. So this has to be a plus q here. It has to be a plus q, okay? Um, yeah, yeah, because you go minus 1 times q, you get minus q at the end. That's the only number. So then you put your plus ax here. And then you do your comparing coefficients. So you go coef of x. Where do the x's come from over here? They'd come from this guy by this guy. So that gives a q as a coefficient. And this guy by this guy, that gives a minus a. That gives a minus a. So then that's equal to the coefficient of x over here, which is q minus 2p. And this is great because we can see that the q's cancel there. And so then a is really just equal to 2p. Okay, so you'd want to confirm that then obviously with coef of x to see you get the same x squared, make sure you get the same result. Like it's hard to describe how much easier this is than using long division, you know. This is incredibly simple. You'd have such a nightmare doing long division on this. It'd look crazy on the screen. Okay, x squareds come from here, so that gives a coefficient of minus 1, and then here by here, and that gives a plus a. And then you set that equal to the coefficient of x squared over there, which is 2p minus 1. The ones cancel, and you get the same result that a is 2p. So then we know our missing quadratic. It's this one here, which is x squared. We know a, it's 2px plus q. Okay. Now, we're told that this guy has equal roots, and that's an instruction that b squared minus 4ac on this guy would equal 0. And so we just sub that in here. So we get sub in b in here, you get 4p squared minus 4 bracket a, which is 1, times c, which is q, equals 0. And so that says that 4p squared, when you bring the q over, is 4q, and then you divide by the 4, p squared equals q. Okay, so hopefully people enjoyed that and just how easy I made that problem look because I do comparing coefficients, okay? And at the very beginning of this video, I told people what video to watch that's already on the YouTube channel about why you shouldn't be doing long division, you should be comparing coefficients. Okay, so hopefully people enjoyed this video, and if you learned some interesting stuff from it, be sure to comment saying it helped, and of course like, and be sure to subscribe for new stuff. Okay, thanks for watching. Okay, welcome back. So this is the final part. So congratulations for everyone who's watched the previous 5 parts. This is the final part of algebra, important past paper questions you should know. And this is on the topic of solving equations. Okay, as you can kind of see some of these ones with square roots and moduluses and all that. So it was only a short document. It's only 24 questions over 23 pages, and I've gone through it and marked in the importance ones we should know. So like you can see here, these two are basically the same. So all we need to do is do one of them, that kind of thing. So yeah, so we'll get straight into it. And congratulations everyone who has been kind of following along to have gotten this far. Okay, and yeah, as usual, be pausing the videos and trying them yourselves if you want to get the most out of them. So you can see here I've put the word check. Okay, this is the big thing. Okay, you've got to really watch out for here. Is when you square both sides of something like this, you can create solutions that aren't actually solutions. Okay, so you just got to always you'll sometimes get like 2 answers and you got to put both of them back in and check if both of them work because sometimes they don't both work, you know. So you've always got to be careful when you square both sides. So yeah, that's what we do here. So we square both sides first of all. So m minus 2, and you show it for the examiner, squared, and then this becomes a 3m minus 2. You should know to square a bracket like this out quickly, multiply them together, double it, then square the last one. Equals 3m minus 2. And we got m squared minus a 7m plus a 6 equals 0. They usually factorize unless they say something funny is going to happen. Natural numbers here, so it should factorize. Minus 6 minus 1. Now we get m is 6, m is 1. And don't be too excited. You've got to go and check them. So always have a note to check them. And you do this for the examiner. The examiner expects this. You have to do this. And you get 18 minus 2 here. So then 4 equals root 16. So we're all good for the m equals 6. Okay, that's all good. M equals 6 works. Put the 1 in. So we go 1 minus 2. Now this looks wrong because how could this ever be negative? Do you see? This is what we're on about. So you go 3 times 1 minus 2. So then we get minus 1 equals the square root of 1, and that's not possible. Okay, so therefore m does not equal 1. Okay, uh, hopefully people are good with that. So there was only one solution here. Okay, so very interesting stuff. Always check them. Okay, right. So let me pause, get our next one. Okay, a very easy one here, just making sure people can do it. For those interested, it's from 2024 paper one. Just making sure people can move this around. You'd be surprised some people just aren't able to do something as simple as this. So do it yourself there, see what you can get done. So they tell us, are they being mean here? They are. I think they are being mean here. This is shocking behavior. Okay, so what they're doing here is they're checking, does the student know what? So they say V is in centimeters cubed, and then this is in liters. Find x when the volume of the hemisphere is 3 liters, yeah, and the hemisphere is covered by this. So that's shocking behavior. So you need to know what 1 liter is in centimeters cubed. Okay, so let me get it for you here. You can obviously type that into Google yourselves, you know. So yeah, so 1 liter is 1,000 centimeters cubed. Okay, so it's pretty mean. So some people remember that. So some people do certain subjects like chemistry and that, and they know like 1 milliliter is 1 centimeters cubed. 1 milliliter, that's 1,000 to that. Okay, so that's how some people remember it. But I usually go for the 1 liter is 1,000 of these. So what they basically said here is V is actually 3,000. Okay, when you read that, so they should have put that in bold. It was very mean. Okay, so basically, put the 3,000 in. Go pi over 12 equals your x cubed. So what I'm really interested in here is that students know how to get the x on its own. So you go x cubed first of all is, and again, we want to be able to write things like this. We don't want to be picking up our calculator to need to type that in. So what's really important here now is when you get the x on its own, you take a third of the power of the other side. So x is equal to the power of a third over here, whatever 12 times 3,000 is. Over pi. Now you got to be careful when you're taking an odd number power like this. The answer will just be whatever is the positive there, right? But say this was like a squared, right? You need to go plus and minus. If it's an even power, you've got to remember to go plus and minus, okay? Because also negative solutions work when this thing has an even power. So hopefully you're okay with that. But because this is an odd power, you don't need to go plus and minus. So I'll type that into our calculator here for those who worked out this problem. Power of 1 over 3, and then that works out to 1 decimal place, and it has units as well, so watch out, 22.5 centimeters, okay? 22.5 centimeters. Okay, right, I'll clear that away, get on to our next one. Oh yeah, so just another comment for people there. When you solve equations like this and you want to be confident you got the right answer in the exam, you can just always put them back in. So just put that back in there and see if it solves the equation, you know? So you go like pi over 12 multiplied by 22.5 cubed. Now it's going to be close to 3,000. It's working out like 2982.06. And the reason it's not exact is because remember we rounded this number to 1 decimal place. That's why it's not exactly 3,000. Okay, so remember that. When you get x's like this from this, you can always like sub them back in, make sure they work. Okay, so this is our next kind of question here. So we have a 2024 question and it's about kind of moving something around. Okay, so it wants to get h on its own here. So people pause the video, see can you get h on its own here. So h is locked up there. It's got loads of stuff around it. So the first thing you want to do is get the square root that h is in on its own. So what you'd say here is like root r squared plus h squared is equal to s over pi r. You get rid of the square root now, so you square both sides, so you get r squared plus h squared equals s squared over pi squared r squared. Okay, so that's what that looks like. And then to get h on its own, then you just bring the r over, okay? So the r squared over, so you get h squared equals s squared over pi squared r squared, and then you take away r squared. So that will be the answer. But what's a bit mean about this is they want it as a single fraction. So to get this as a single fraction, you need to multiply above and below here by r squared. Okay? Not just r squared, actually. It has to have the same denominator of what's over here, so you need to multiply above and below by pi squared r squared. Pi squared r squared. So then your h here, your h squared, becomes s over, so they're all over the same denominator of pi squared r squared. And so then this is really like a minus pi squared r to the 4, okay? And then what you can do then is you can take square root of both sides. You've got to be very careful when you take square roots. You got to go plus and minus. So first of all, your examiner will be expecting you to go plus and minus. Um, this is squared as well, s squared. S squared minus pi squared r to the 4 all over pi squared r squared. And you've got to know a rule that when you have like root a over b, you can write that as root a over root b. And so what we can do here is we can take a square root of the bottom, and that works out. And obviously h is going to be positive because h is a distance, so it can't be negative. So then you write that it's positive. So it's really just we leave the square root on top like this, pi squared r to the 4. And then over, there's no square root down here, we take a square root of the bottom using this up here, and we get pi r. Okay, pi r. Okay, and then that still has a squared on it there, sorry. Okay, so hopefully people are good with that and you enjoyed that. And there's no way you can take square root of that thing in there. Okay, it just doesn't work. Okay, great. That was a good question. Hopefully you learned something from that, how you move things around. I'll get our next question. Okay, another similar kind of one here, moving stuff around, making sure you're able to move things around, guys. So 2024 here. A is locked up. It's got A, we're asked to get A on its own here. But A is in two locations. So when you got something like this, you're going to need to factor out the A in the end, okay? But we need to do a bit of algebra first of all to get it tidied up a bit. Now what you could do here is you could just square both sides at the minute. So square this side, and then you square this side. So this becomes a 4 and a full A, and then it's over 1 minus A down here, okay? Because you square the bottom as well. And then that gets rid of the square root down there. So hopefully people are good with that. So what we got to do now is we need to multiply across by this. So it's x squared times 1 minus a equals 4a, right? So then we'll multiply this out. So we get x squared minus ax squared equals 4a. Now you see this is the problem. We have a occurring in two locations. So what we got to do is bring all those to one side. So we might bring them over the other side. So we get x squared, leave him on his own, and then bring this over here. So we got 4a plus ax squared. Now, when you got your a's together, you factor out the a, right? So this side stays the same, and then we take out the a, and it leaves behind a 4 plus an x squared. So that's how you do that. You basically, if you get your a's together and then take it out, and now we have a in one location, so then a is equal to x squared over, we'll write the x squared first here, x squared plus 4. Okay, that's your a. Okay, hopefully people enjoyed that. I'll find our next problem. Yeah, a little bit of an interesting one here from 2024 mock paper. I think it's just, oh yeah, this is another separate thing down here. So yeah, let's do this one. So it's interesting. So you're like, ah, sure, look, all I can do here, I could just type this into a calculator. You know, you could just go 1 over 3 root 5 over 1 over 2 root 20, and then divide the whole thing by root 5, and that's k because it's all numbers. Now, I'm pretty sure I'm not going to do it, but if you type that into your calculator would just like not take part in what you're trying to do and then just give you a decimal. And then if you wrote the decimal down, the examiner would know you used a calculator, and that's not it. So it probably works out as a nice third thing, you know. So we'll show you how to do that. So first of all, people, we've got to understand that you can write things like root 20 as something else. Now, root 20, so what we could, yeah, there's a few different options here that we could do. So first of all, I'll explain how we could write root 20. Let's see what the calculator says for that. We'll explain where it gets it from. It says root 20 is 2 root 5, okay? So where did that come from? You can break root 20 up according to this rule. If you've got root AB, it can be root A times root B. So we can break root 20 up into a root 4 and a root 5, and a root 4 is a 2. So that's where the 2 root 5 comes from. So that would be my first move here. And again, you don't need a calculator for that. You could have just broke it up like that with the 4 and the 5. So we'd write it like this now. 3 root 5 minus, so as we said, root 20 was 2 root 5. And remember, there's a 2 already here. So then it becomes a 4 root 5. Okay? And then that's equal to k root 5. Now, a really smart thing you could do here is multiply both sides by root 5. So if you multiply both sides by root 5, it looks like this, root 5 over 3 minus root 5 minus root 5 over 4 root 5. It's like the examiner would be expecting these workings, you know, to know you didn't use a calculator. And then if you multiply this side by root 5 by root 5 gives a full 5. Okay, hopefully people are good with that. What's cool about this now is you can cancel the root 5s here. And this problem becomes 1 over 3 minus a quarter equals a 5k. We should be able to do this in our head. 1 over 3, these are in terms of twelfths. So we have, this is 4 over 12, and then this is 3 over 12. Are you okay with that? Hopefully people are. So so a quarter minus a third minus a quarter is a twelfth. Again, like you don't need a calculator for that. You should be able to do that kind of stuff. So then k here, k works out as 1, you divide both sides by 5, and then it's the same as multiplying the 12 by 5, so I'm getting k is a 1 over 60. 1 over 60. So again, here, what could you do if you wanted to be happy, you know, you got that right in the exam? You could just put it back in. You could just put 1 over 60 in there for k. So then you have root 5 all over 60 here, work that out as a decimal, and then compare that to this as a decimal, and then you'll see you have got the proper k as the 1 over 60, okay? So hopefully people are okay with that, how you do that without a calculator, and you learned something there. Okay, I'll move on. Yeah, just another thing there, just in case anyone did use a calculator there, the idea is you've got to be able to do that without a calculator like I done there, because what they'll do is they'll put in like this as A, and they'll put in this as like 4A, you know what I mean? And then you won't be able to type like root A into your calculator. So they'll just introduce letters, and you've basically got to still be able to do what I showed you there. So what I showed you there is really important. Anyways, our next question just below here. Explain why this equation has no real roots. So this is a good one. Make sure everyone pauses and give this a go. It's very interesting. Right. So, trick here. This is written in a funny way, okay? Now you can just cross multiply if you want, but what you could realize here is you could just write this as x to the 4. You could just give them each individually under x to the 4, because then this will cancel down to give a 1 over x to the 4 equals a half. You see what I mean? So then this cancels down to give a 1, so that's a 1 plus 1 over x to the 4 equals a half. And then bring the 1 over, and then it'll become minus 1, so that gives minus a half over there. So this is the problem now. You 1 over x to the 4 equals minus a half. You can flip both sides, that's a kind of rule of maths, so then you get like x to the 4 equals minus 2. If you didn't see that, you could just cross multiply, and then you'd see x to the 4 minus x to the 4 is equal to 2, so then x to the 4 is 2. So this has no solutions, okay? You can't go and this here, basically, you type that into calculator, it'll say error, okay? Because it has no real solutions, okay? You can't do that. Basically, you could just explain this for the examiner as well. There's no way you could do something to the power of an even number and the result turn out to be negative. It's not possible, okay? So it has no real roots. Yeah, so hopefully people are good with that. Yeah. Okay, so I'd leave it there. Yeah, that's grand. Just to explain anything to the power of an even number can't give a negative answer. But just for an interesting thing here, if it's an odd number, you absolutely can get negative answers. Say if you raised minus, I won't pick minus 2 because that's in the question. Say if you raised minus 4 to the power of 3, type that into your calculator, you'll see that works out as minus 64. So when you have odd numbers, this would be possible. This would be possible. But when you have even numbers up here, it does not work. You can't have an even power and then have the result work out as negative. Okay, so hopefully people enjoyed that. Learned something from it. All right, I'll pause this, find our next problem. Yep, so our next problem just occurs underneath this here. It's from 2023, paper 1. Find the values of m that satisfy this. Now there's two ways to do this. I recommend people kind of squaring both sides. It's the safer way always, you know, particularly if there's like another modulus over here. The way to do it is to square both sides. We'll do that first and then we'll talk about the quicker way. So we square both sides like this for the examiner. You should know the square of 11, it's 121. This gives 25, multiply them together and double it, 30m plus 9m squared equals 121, and you basically just let the quadratic formula worry about this from here out, you know, it's easy. Obviously we need to see how the 121 crashes into the 25. So I'm getting a minus 96. And then obviously try and make it a bit smaller if you can too. So like I'd divide everything here maybe by just 6, no, 3 goes into everyone. So then I got like 3m squared plus 10m. Ooh, what's that in my head? 32 is it? 96 divided by 3. 32, yeah. Like it should factorize, but you could just use the minus b form, particularly if the numbers get quite big after you square it there. But sure, we'll spend a second try and factorize it. So 3m and m factors of 32, 16 and 2 by any chance? 16, ooh, 16 and 2 might do it. If you put a 16 there and a 2 here, and then a plus here and a minus here, it would do it. Because then you get a plus 16m, take away a 6m, that does it, yeah. So then the solutions here are m equals minus 16 over 3 when you set this equal to 0, and then the other one is m equals 2. Right, and you've always got to check these. You've always got to put them back in and kind of show that for the examiner. Let me get another color. So you just kind of show yourself going modulus 5 plus 3 bracket minus 16 over 3 and showing that's 11, which it will be 11. So let me check it there. You can see it in your head as well. Look, this is the 3's will cancel and you'll get a negative 16 here, so you get 5 minus 16, so that's minus 11, and then modulus minus 11 is 11, plus 11. And then the other one then is modulus, so you just put it like a tick on this, and then plus 3 times 2, modulus equals 11, so then that's 11 equals 11, so then that's also a tick. So both worked. Okay, that's the squaring both sides. Yeah, I'll share this with you as well too. So there's a quicker way to do this when they're nice and simple like this. I'd only do it when they're this simple. You can say that the inside is equal to the positive 11, and you can also say that the inside would be equal to a minus 11. Now the reason you can do this is because there's two ways you could get an 11 here. It's if that in there was 11, or if that was in there was a minus 11. And so that's what we're saying here. And so you get your two answers from this. This one up here, 3m, bring the 5 over, gives a 6. And then you see m is 2, very easy. And then you bring the 5 over here, you get 3m equals minus 16, and then m is minus 16 over 3. Okay, but I still recommend squaring both sides in case anything funny goes on in the question. Okay, cool. Our next question is just below here. It's from 2023 as well. So it's a little bit tough. I think this is another one of them fun ones. So this was actually a junior cert question, okay? And it was interesting to just give it to the leaving certs and see can they do it. So that's where this came from. So this is absolutely a junior cert question where they have like two Ks in one location and they have to get the K on its own, and the students have to know how to do it. So we cross multiply here is probably the cleanest thing to do. So when you cross multiply, the j plus k times the 1, so it's just a 1, and then you get equal to a hk here. So you got to know this. There's k in two locations, so you bring all your k's to one side and then factor it out. So you get like j equals hk minus k, and then you take the k out. So then it's k leaves behind a h minus 1. And then the k on its own, you divide by this, is the j is a really annoying symbol to write down. J over h minus 1. Okay? So yeah, the big thing is if k is in, or whatever variable is in two locations, you need to eventually do a factorizing out step like that there. Okay, well, I'll pause this, get our next one. Okay, so our next question here comes from 2021, so I'll get this set up. And obviously pause it, give it a go yourselves. So would they say that given that x minus 3 is a solution of this, find two values of p? Okay, so we'll just kind of maybe follow the instruction here. We let x be minus 3 and see what happens. Again, I'd recommend squaring both sides. You can obviously do that other quicker method I showed before, but safer square both sides, I think. So we square both sides. You need to tell the examiner that though before you do it, and always watch out that you square the other side as well. Sometimes people get so excited about squaring one side they forget to square the other. Happens in exams. Multiply them together and double it, minus 6p, square the last term, p squared equals 25. And this should get us two values of p. So then you get p squared minus 6p, bring this over, what is it, minus 16? If I can do that right in my head. And then this looks like 8 and 2 job. 8 and 2, probably a minus and a plus here. That looks good to me. And so then our solutions are p equals 8 and p equals minus 2. Okay, and then you can put them back in there, see if they work into this pink thing here. And they should. You put the 8 in there, you get a +5 modulus, that works. And you put the -2 in here, you get a -5 in there, and -5 modulus is a 5. So they both work. You can just see it in your head, but you'd show that for the examiner, you checking them, like I did before in the previous example. Now, a bit of a tough one here. They seem to have put a speed time thing on here. So let's see, can people make sense of this? This is tough, so I might have to pause and read this as well myself. So sometimes when there's lots of words like this, you need to kind of think about them for a second. So I'll see, can I do this at my usual speedy pace? Thinking it up on as I go along. So at 9 a.m., delivery van leaves the factory. So make sure you pause and do this yourselves. This is one of those tough questions. It travels towards its destination at this average speed, okay? 1 hour and 45 minutes. So that's annoying in there. That's an awkward unit. So you want to keep everything in hours. So I'd write that as 1.75 hours there, okay? So 1.75 hours later, a second fan leaves the factory and it travels much quicker. Both fans arrive at the same time. Right. So what's tricky here is you've got to understand that the first fan has spent T hours on the road, okay? He spent T hours on the road, right? T hours. How long has the second van spent on the road? The second van has spent T minus 1.75 hours traveling, okay? So that's a big thing you have to understand there, that this guy has been on the road for less time. Now, the idea is they both leave the same factory. So, I'll write in, at leaving cert higher level, we should be writing, velocities and displacements and that. But what will help people here is doing the old junior cert speed equals distance capital D over T. So we'll keep these as capitals and then it'll kind of be like the junior cert thing. So the idea is both of them cover the same distance, okay? So basically we could call it distance 1 equals distance 2, okay? Whereas T1 for the first fan was just T, and capital T2 for the other guy was the T minus the 1.75, if that makes sense. So hopefully people are okay with that. And so we can write an equation for the first guy's speed. His speed was 60, and he traveled a distance of, as we said, D1. D1 equals D2, so we could just call that D. So he covers D, and then that's over his T1. So this is speed 1 was 60, so T1 is T. And then we can write that the distance is equal to 60T for this guy. Okay. So then let's do it for the other guy now. I need a different color so people don't blow up. Okay. So the other guy's speed, when we sub in for S, this is his S2, so it's 95. The distance is the same. And now this guy's time is this T minus 1.75. Okay. T minus 1.75. And so then I'll multiply across by that. So then I have room here. So then D for this guy equals 95 T minus 1.75. And so then you just set the distances equal to one another and you get an equation to find the T. Okay, so let's see, can I make some room for that? So setting the distances equal to one another, we get 60T equals this thing here, which is 95 T minus 1.75. So that there is worth most of the marks in this question. So then we just multiply that out. I might switch to blue. 60T equals 95T. And then what is 95 multiplied by 1.75? It's a little bit of an awkward number. It's minus 166.25. And so then you bring the 166 over here, bring the 60 over here. And so I'm seeing that T works out because you'd get 35 there. So you can kind of see T is meant to be positive anyways. So over, what is it, 35? Because you bring this over, you get 35T and then divide by the 35, yeah. Okay, so let's see what this works out as. 166.25 divided by 35. So it works out as a nice number. So T there worked out as 4.75 hours. So pretty confident. We're happy with that. Right, they're tough questions. Students would struggle with that kind of thing. Don't be too worried if you can't get that out. It might only be worth 10 marks on the day, that kind of thing. That's complete, like for people who do stuff like physics and particularly applied maths, that's such an easy question for them. But if you're not used to that kind of stuff, this is tough. So that's why I helped you out there by calling it speed, distance, time, rather than bringing in velocities and displacements and different symbols. Okay, so hopefully people enjoy that. I'll clear it away, get our next problem. Oh yeah, just before I clear this away, there was a little extra bit here. So we worked time for the first fan to travel was 4.75. I remember that fan left at 9 a.m. and they wanted the time they arrive. So because that first fan left at 9 a.m. and he was 4.75 hours on the road, which is 4 hours and 45 minutes, very basic problem. So then it'll arrive at 1:45 p.m. if that makes sense. 1:45 p.m. Okay. So that they deduct a mark if you just found T and then didn't get the time, you know. You'd lose 1 out of 10 marks, you know. It's not the end of the world. Okay, so this is our next problem here. This is a pretty important problem. Okay, so what's tough about these is students have to remember that you have to square twice, okay? So you'd make a flashcard on this if you didn't know this. This is from 2020. Tough question. So you've got to square twice, and then you've always got to check your answers afterwards. So before you square twice, you got to arrange it a bit like this, where the square roots are on opposite sides, and then you square twice. So we do our first square here. So this is tough now, squaring this stuff. These are tough questions, and they do repeat a bit, so you want to be able to do these. This side squared just becomes this. Now squaring this out is tough. So you square the first term, that becomes a full 3x minus 5. You multiply them together and double it. So then it's a minus 6 out the front, and it's a 3x minus 5. And then the last term is squared, and that's a 9. And that's equal x minus 6. Now, you have to square again, but before you do that, you get everything away from this square root. So I might bring this over this side so it's positive. So then what do I got? The x comes over here, so then that'll be a 2x. I've got a minus 5 and a 9, which gives a plus 4. This comes over, then I get a plus 10. And then that's equal to 6 here, and it's a 3x minus 5. Now, before I'm going to square both sides, I might divide everything by 2. So then you'd show this in an x line, you know. So divide everything by 2. So now you got to square both sides. So you just, in another line here, you'd show this for the examiner. Okay, that'd be the next line there. I'm saving myself having to write it. So then you'd write this is x squared plus 10x plus 25. And then the 3 becomes a 9. And then this becomes a full 3x minus 5. Okay, so we're pretty good now. We're pretty close. So then we just square that out. We multiply this bracket out. So this x, this stays the same this side. So then we get a 27x minus 45. So then we got x squared, bring this over, minus 17x, bring this over, plus 70. This usually should factorize. You know something's wrong if it doesn't, you know. Look at this for a hint. You have to get nice numbers for x. So x minus 10 probably, x minus 7. So then x is 10, and then x is 7. And I said, don't be getting excited here. You've got to go and check both of them. So, and you got to show this for the examiner. So you got to go root, whatever, 30 minus 5, take away 3 equals root 4. Okay, when I put the 10 in, what's this? This is root 25. Root 25 is a 5 minus 3 equals 2. Okay, he's good. We can put a circle around him and a tick. Now we test the 7. We put the 7 in. We get root 21 minus 5, take away 3 equals a root 7 minus 6. This is going to give us 16. That's a 4. 4 minus 3, and that's a 1. And then this is also a 1. So both actually worked here, okay? And you just got to check that for the examiner. So sometimes both won't work, you know? Okay, hopefully people are good with that. And that's nice too, because you can move on happy from this knowing you've done everything right because they went in and they worked, you know? So it's a really pleasing question, that kind of thing, because you can check if they're right. So I'll pause the video. Oh, well, I don't have to. Our next question is just below this. So that we need to use our answer from part A here. So this is I've already covered the factorizing part. Factorizing part, I don't know which part it was of this 6-part series on past paper questions you should know in algebra. But I'm just going to factorize this here. Let's assume it's the first two that go together. So I'm just looking at this. If I take a 3x out of them, it would leave behind a y and a minus 3. And then if I take a 4 out of this guy, it leaves behind a y and a minus 3. And I already talked about why once you have them like this with the same thing here and here in the factorizing part of this tutorial series, why they can go back together like this. Okay. And yeah, so I recommend going back and look at that. If this is a complete curveball from what you learned at junior cert, that when they're like that and that, they can be written like that. Okay. So use your answer from here to do this. So this obviously is going to be writable as you can see that they basically just said y is ln x, right? And then what they're saying is this thing then is equal to 0. See it here, equal to 0. So what I do here is I write 3x plus 4 times ln x minus 3, because y is ln x from this thing above here. And then we set this equal to 0. So the solutions here are x, when you set this one equal to 0, you get x as minus 4 over 3. Sometimes people can see them in their head, and sometimes they have to do it by hand, where you go 3x plus 4 equals 0 and move it around. And then this other solution here is when lx has to be 3. And then you break your log here, because this is log e, the x equals 3. The whole point of logs here was to get the power on its own, so that must be the power. Who's the base here? The base here is e, so that stays the base when you go back to exponential form. Its power is 3, and that leaves the x. So the other x solution is e to the 3. And yeah, hopefully people are good with that. Interesting question. Right, so I'll clear that away. We'll move on. I think I've done that all good there, yeah. The y minus 3, and then y was ln x. Yeah, looks fairly solid. Okay, so let me clear that away and get on to our next problem. Again, too, that's one of them, you can move on fairly happy from this knowing you done it right. Like, what were my solutions there? You can put the minus 4 over 3 back in for x's here, and then the whole thing should go to 0, and then you can put the e to the 3 back in for the x there, and it should go to 0, and you've done it right, There's no guesswork then. Right, I'll pause this, find our next problem. Okay, so our next problem is from a 2019 mock paper. Now, we've already done stuff like this earlier on in earlier parts of my algebra past paper questions. You should know where I showed people how to graph these where they're V's, But this is an interesting one where they're just kind of set them equal to one another. So we're going to use our graph to find these answers after we plot them. And then part 2 down here, part 2 is verify your answers algebraically. So we'll do both in the same kind of solution thing. So obviously pause the video and give this a go yourself. Right, so you should know how to plot this. That's just y equals 3, so it's a horizontal line that goes through a y value of 3. So that's what horizontal line is, just like they're like y equals a number. Now, how do we plot the other guy? What you do first of all is you plot the line y equals x minus 2. How do we plot a straight line? Well, we can find where it crosses the x and the y-axis. When it crosses the y-axis, x is 0. And so that tells us y is minus 2. So we have a point 0, minus 2. It's pure junior cert stuff, So he goes through 0, minus 2. And then to find where it crosses the x-axis, you set y to 0. 0 equals x minus 2. So then x is 2. And so that point then is 2, 0. So 2, 0. And now we have that line. So we first of all draw this line, like such. And there we go. Now, once we've drawn that, and you show whatever the workings there for the examiner, like such, you then got to plot this guy here, and I'll plot in a different color. Let's use, say, purple. Right, we're going to plot modulus x minus 2 now. It's going to be basically, this part of the curve is not going to exist because it can't have negative y values, okay? Because of the modulus forces it positive. So whenever it would want to have taken on a value down here of minus 2, okay, that minus 2 is going to instead report a value of plus 2. And same down here, when it's minus 2 and it says a y value is like minus 4, it'll want to report a plus 4 up there, okay? But you only really need 1 point, because what happens is it makes a V. So once you have 1 point, you just connect to where it hits the x-axis and then make your V back like that. It'll be symmetrical. Okay, so there is our purple function. And then you can get rid of the green function then. Or you can have it in dashes or whatever. Draw it in pencil maybe, so the examiner can see how you drew the V in the end. So the question is then, where do these intersect? Where are their y values equal? So it looks like it's about there. And it looks like it's about there. So this is what is the values of x that do this. So we can see it's x equals minus 1. And then it's x equals 5. Okay, there are the answers. And then how do we do that algebraically? Well, we just set the two functions equal to one another. So then you say 3 equals modulus x minus 2. And as I recommend, always square both sides. So 9 equals x minus 2 squared. So then 9 equals x squared minus 4x plus 4. Bring it all to one side. x squared minus 4x minus 5 equals 0. So then we get x minus 5 times an x plus 1 equals 0. And the solutions are x equals 5 and x equals minus 1. And there's kind of no need to check if they work because we already got them to be confirmed to work from a graph, you know. Same answers. Okay, so hopefully people enjoyed that and make a flashcard on it if you didn't know that. But if you'd watched the earlier parts, you'd have already seen that being done, okay? So that's the end of that there. So let me pause, find our next question. Yeah, just a bit of an easy one here. We'll hammer this out in a second. This is so simple. It came up in 2015's official paper. It's so unusually simple that we'll do it. So pause the video and give it a go, and then as always, check your answers afterwards. So square both sides. X squared equals x minus 6. Bring it all to one side. X squared minus x plus 6 equals 0. And then it becomes x minus 3. Oh no, they both. How does that work? So x probably won't work out nice here. So this is why this is it, because these are a real number. So they would have said it'd be like an integer if it was nice. So let's see if we've done this correctly. So that's an equal sign there. X. So that's me being silly. So that's a plus 6 there. I took it down wrong. So x squared is root x plus 6. So that's all good. And then let me redo this line. So that first line's correct. So then, see, when they're so simple, you can make mistakes. So x squared minus x minus 6 equals 0. So then we'll do this again. That's a minus 3, and that's a plus 2 equals 0, because they multiplied to give minus 6 and had to give that. Cool. So they could have really said this was an integer here, you know. So then x is 3 and x is minus 2. Now you've always got to check them. And I know this one's not going to work, because how could you take the square root of a number and then get a negative answer? This one is just not going to work, okay? But you got to show it for the examiner. So then you go minus 2 does not equal the square root of a positive 4, okay? So this one does not work. And then you check the 3 probably will work. So it's 3 root 3 plus 6, and then yeah, obviously 3 equals 3. So this one does work. So only one answer. So always check, always check. Right, so I'll pause this, find our next problem. Yeah, so just one more problem here. This is the last problem of all the algebra problems that we've done now in all the part series. This is our last problem, so you'll be excited if you've gotten all the way here. Aren't you brilliant? Okay, so back to 2012 mock here, and we have a bit of a funny thing. We're going to square this up, and we'll check our answers afterwards, okay? So obviously you begin by getting the square roots to the same side, opposite sides like this. We'll have to square twice. So then it becomes 2x plus 7 equals, and you just write it like this first of all for the examiner before you square it. Right, so then let's do it. 2x plus 7. You square the first term, comes an x. Multiply them together and double it. You get 4 root x. Square the last term, you get a 4. Right, I'll switch to a blue. It's nicer. So we get everyone away from our root x now. So we bring everyone over. So this x hits the 2x, makes a full x. Just an x. The 4 comes over then and it makes a 3 there, because minus 4. And then you get yourself a 4 root x here. Square both sides again. You just need to explain to the examiner that's what you're doing here. And then this gets squared and that becomes a 16 and then a full x, okay? Hopefully people are okay with that. Or you could show it as an extra step there if you wanted. Grand, so we multiply that out. Let me switch color. So x squared plus 6x plus 9 equals 16x. Bring this over, as I said, it usually factorizes quite well. Minus 10x plus 9, this will factorize. So it'll be x minus 9, x minus 1 equals 0. So the solutions are x equals 9 and x equals 1. And then as always, we've got to check those. Let me move those into a whiter area. There are answers, and so we check them for the examiner. So we put the 9 in here. Root, putting the 9 in, so you get 18. I made that root too big. I'll put them up here. Root 18 plus 7. Does that equals root 9 plus 2? So this is root 25, so that's 5, and then that equals 3 plus 2. So he's good, but the 9 is good, and there's your workings for it. So then we'll check the other one. We put the 1 in. You put a 1 in there, so you get root, you just show for the examiner, 2 plus 7 equals root 1 plus 3. That's a root 9, which is a 3, and then, oh, sorry, that's a 2 here. So that's a 2, and then it's 1 plus 2, so that's 3. So they both work. Okay, so happy days. So hopefully you enjoyed all of this tutorial series. It took me ages to make it, as you imagine how long it is, and hopefully it helped, which is the most important thing. And you were able to make loads of interesting flashcards at it, and your algebra is much better now. And so if it did help you, be sure to leave a comment saying it helped, and like and give us a subscribe too for some future content that will interest you and your maths career. Okay, so thanks for watching and best of luck. Bye now.